Hello, everybody. My name is Vedant Khandelwal, and I'm glad to be here with you today for Python for AI and ML Global Summit. Today, I'll broadcast from Colombia, USA, and here the weather is currently a bit hot. I've already prepared myself a cool drink and some snacks. So make yourself comfortable for the next couple of hours. We will have two speakers with us presenting their topics on artificial intelligence. I hope you all are excited and in a pleasant and safe environment. Be sure to write to me in chat from which city and country you are from, and how long have you been studying computer science or artificial intelligence. Please also prepare your questions to which speakers will answer on the question and answer panels, and do not hesitate to share your opinion with each other in the chat and be open to new knowledge and ideas. So, moving on to our first speaker, Bojan Miletic, who will be discussing the brief, wondrous life of AI, putting ML models to bed. Just a brief introduction about Bojan. He's the CEO of Softerific. He has been working as a Python developer for almost a decade. During that period, he closely worked with ML scientists and helped bring their models into production. He has also worked as CEO of few startups to get a deep understanding of the ML business impact ML can have. Now, due to the time zone of the speaker, this session will be pre-recorded, but be sure to have questions prepared for the question and answer panel where the speaker will be joining with us live.
Everybody. Today we're going to talk about brief and wondrous life of AI models. We're going to go over the best practices for iterating quickly into production, making sure models are healthy, and a bunch of other interesting things. So let's get started. Well, first of all, let's talk about me. I've been a Python developer for almost a decade. I love unicorns, baking cakes. I've worked with AWS for the last 5 years, worked in various roles. Started as a backend developer in PHP, then I did some frontend. Got some nightmares from JavaScript, decided never to do that. I also tried doing design. Turns out, not a very good idea for me. So, right now, other people do design for me. And I love helping other companies develop their machine learning projects. I've been working with several of Silicon Valley startups where we went from basically zero to a production-ready environment, serving several million users per day. I'm currently CEO of Softerific, and that's about it about me. Let's start with our tale. During this presentation, I'm going to share my knowledge about life cycle of machine learning models in real world. We're going to start with one of the companies that has huge impact on the world and their journey in the land of machine learning. Some of the spoilers about the story. We'll follow the journey of that typical company into machine learning, basically starting from no machine learning in the company, traditional stuff, and then slowly integrating machine learning products into it. Sadly, during this course, many beautiful machine learning models will die way too early. That's the way of iteration. And many will die way too late. And that's the sad story about not monitoring carefully. We'll get there. For some of you that have more sensible character, there are gonna be tears. It might end like a Shakespearean play, or there might be a happy ending. In any case, let's find out. So, once upon a time, there was a little bakery high in the clouds in the little unicorn village. We have the owner Luffy, who is operating a bakery for as long as anybody could tell. And for unicorns, that's quite a long time. He's been making the same cupcake recipe for eons, and he managed to get a good deal with Rainbow Factory, main and only ingredients of his cupcakes. And he's able to sell his cupcakes at a very low price. However, lately, sales have been declining as unicorns got tired of the old cupcakes and wanted some novelty. Lofty has sadly figured out this way too late, and he realized he doesn't have much of the resources to experiment with new recipes, try new products that he could provide to the unicorns, or try to pivot into something else, maybe selling unicorn milkshakes. And at this very moment, our hero, Grace, returns from the School of Sorcery and is determined to use her magical powers of machine learning to save a family shop. She's going to try to do this with almost zero budget, as it is usually the case when you're starting with machine learning in a company. Now, she starts with the first idea. She's going to make a machine learning model that's going to predict what sort of drink unicorn would want with their cupcake. That way, she can upsell the unicorns and make them happier by offering some additional products based on their preferences. With this brilliant idea, Grace outlines the normal steps for creating machine learning model, that is, collecting data, training model, deploying it, and profiting. So tomorrow, after she gets a good night's rest, she's going to go around the village and ask every unicorn what their favorite drink is. But as she gets ready to sleep, something horrible happens. She gets attacked by common sense fairy. Now, in machine learning, that's the scariest sort of fairy that can visit you. It's both a good and a bad thing. And luckily for Grace, she gets visited quite early in her plans. Grace did one of the most common mistakes. She got caught up in building a cool solution and she forgot to think about what she's trying to solve. That's it, and that usually happens with everybody. We start thinking about cool models and we forget what's the bigger picture, how is this model going to be used? Well, it turns out unicorns don't have hands, so they can't carry drink and cupcakes at the same time. Their powers of telepathy are also quite weak. Back to the drawing table. Okay, maybe we can still use this idea. So she decides to go to her dad and ask if they can buy tables so unicorns can sit at the shop and enjoy cupcakes and drinks. As it often happens with dads, he tells her that he doesn't have money for tables. Get back to a drawing table. Things look super sad because our solution got rejected even before it was even created. But this is a good thing, because we have saved a bunch of valuable time and resources by consulting with a dad, common sense fairy, before trying to build a solution. Which leads us to the first and most valuable lesson. Always consult business owners. Usually we love getting into our silos. I believe we repeated this a couple of times, but it's true. The machine learning model is not just a thing for itself. It works in an ecosystem of various other solutions and inside the business as a whole. And usually when a company decides to incorporate machine learning into its business, their motivation is driven by the hype usually. And once that hype wears out, if your solution doesn't start generating value, they are going to shut down your project. This is the most fragile part of the machine learning development, and this is where sadly most of the projects end. So, Grace is going to do a responsible thing. She sits down with her dad and they brainstorm a bit about what can be done. My advice to you is the same. Don't skip this step. In the big companies, you probably won't be able to sit down with the CEO, but you need to get a bigger picture and learn what are the usages and resource limitations of your model. You're also going to have probably some regulations that prevent you to use certain data. There might be a fixed budget for monthly cost of the project. Your dreams of using a farm of GPU service might get easily crushed and you might need a different solution. So, always talk with the people outside of your team, especially with people who are decision makers in your company. We want to survive this first step, and I'm gonna share a couple of things. Grace talks with her dad, the business owner, and they figure out a new idea. Grace is going to make a machine learning model that will make a recipe for each of the ingredients that Unicorn has bought. And for a small fee, they're going to throw it into a magical furnace that her dad has and they get a cupcake. That way, her dad doesn't have to spend any money on ingredients and unicorns get to try all sorts of crazy recipes. Win-win situation. Now, in your case, you're going to have a very different scenario. But it is important to get everybody on board. What are you building and how it's going to provide the value. Always start with that. As soon as your machine learning model starts providing value, it's not so easy to kill. Otherwise, it's gonna be that cool experiment that we did, and it's going to belong to the history. So, first rule of machine learning is talk with the people. Couple of things during this first step. As I mentioned, what we want to do is produce results and values. And this is the phase that most of the engineering, machine learning, and any other sort of the best practices don't matter. It's going to depend on your company, size of it. You might have a budget, so you might be able to afford some time, but usually in smaller companies, you have very limited resources and time for this. So you want to throw every good practice, everything you know out of the window, and just make that model as quickly as possible. That's the most important thing. How are we going to get there? Does not matter for now. That's the problem for our future self. And they can handle that, usually not. As with any other advice that I'm going to give you during this lecture, use common sense. Decide what is best suited for you and what you should skip for now, or what should you completely ignore. Reason why I'm telling you all this is because you need to have time and resources to develop a machine learning model. And in order to get that, usually you need to provide some value. It's basically a chicken and egg problem. You need to provide value in order to get money and resources to provide value. And you can't do that if your project gets abandoned. I'm gonna quote Zola here: "Not even the brightest dawn can lighten up the dead sky." So no amount of best practices is gonna save your project if it's just being pretty and sitting there eating up the costs. That in mind, we need to solve a problem. No matter how fancy our model is, we need to solve a problem. I'm repeating myself, but this is very important to understand. And also the first iteration of machine learning needs to be just good enough, basically just passable enough, so we can get quickly to a product market fit. That way, once we get validation from our users that this is actually good and they want to use it, then we can start working on it. This is not probably going to happen on the first try. So we are going to try a bunch of different solutions and figure out what our users actually want. And they can be quite tricky. Also, second rule of Machine Learning Club is it doesn't have to be machine learning. It can be a good heuristic. Don't reach out for deep learning models unless you really need to. You can do a simple linear regression, or even better, if-else rule-based system, decision tree, something simple that's going to work. There are of course other domains at which you need to use advanced models such as machine learning translation, but for majority of the cases, simple metric is quite good enough. We just need to get 80% there, and after that we can use machine learning to improve further. Also, one good thing to know at this point is at what point does your model starts generating value. Does it have to have 10 users using it? Does it have to have 20, 100, million? This is a very good question, since it's going to put into perspective if this is a feasible solution. If you're a small startup that needs 10 millions of users to start generating return on your investment, you are going to want to rethink of the machine learning solution you're trying to implement. So do these steps first, because fastest way to iterate with machine learning model is to basically not do them at all. Sooner you can eliminate a non-working solution or non-feasible solution, sooner you can focus on the solutions that actually work. Important questions that you're going to be asked. It's a bit of a rephrasing of the previous slide, but these questions are important and you're going to be asked this all the time. First question is it even working? That is basically, does this model generate for given ingredients usable recipe? We'll get how we're gonna test that. In your test, just run a couple of inputs and providing outputs so you can make a demonstration PowerPoint presentation to the stakeholders, and your manager is perfectly fine. Next thing you're going to be asked is how much does it cost to predict something? And this is quite tricky, because usually when you're doing in your Jupyter Notebook, you're going to test it on your super fast computer with 20 GPUs and everything is going to work perfectly fine. But when you deploy it into AWS or another cloud, you're going to realize it costs you about $30 per hour to just run the model. Try to figure out that as quickly as possible. Sometimes simple models are much better. I had the opportunity to work with really amazing models that took about 20 hours working on 2 GPU AWS instance to produce output for a single user. And they were super accurate. Team was very happy about it. Sadly, I had to explain that is not a feasible model, since it was very expensive to do that for each of the users. Next one is how much business value does it provide? Is it just a cool feature that's going to be displayed in our CV, or is it something that's going to generate value for our users? And in our case, with the cupcakes, we can answer that question. It doesn't cost anything at the moment, and basically we're using the spare oven time to generate some extra revenue. We made a very nice product. Usually in the non-unicorn world, things are going to be more complex. Try to figure this out, or if you can't, ask your manager. They're there to help you, hopefully. Work with them to figure out how is this going to bring value to the business. This is important stuff. And the last but not least, how long does it take to make prediction? This is going to vary on your domain and is going to be important. For example, when you're working with daytime trading on stock market, anything above a few milliseconds is not acceptable time. When you're working on the web and trying to detect if user has uploaded a picture of cat or a dog, anything around below a second is perfectly fine. When you are doing some asynchronous microservice architecture, you can in some cases go with few hours. So once again, you need to understand your domain. With that in mind, we are going to make our first version of the model. And we're going to do it without machine learning and no data at all. So in order to iterate very fast, Grace, our hero, she's going to go and find the old granny unicorn, which is the best cup maker in the world. It's going to be a long journey full of adventure, which we will have to skip due to a time limit. However, I advise you, as exercise left to your listeners, to imagine the best possible voyage story, something even greater than Lord of the Rings, and just insert it here. Here is our cupcake making systems. Since we're going to go public, we're going to have to do a few things first. We're going to use this initial system for generating a data set. For every input and prediction that our domain expert makes, we're going to record them, and later we're going to train machine learning models based on that. This is our golden set. We are lucky here to have a granny unicorn to help us. But almost always you're not going to have domain experts making decisions as system is running. More likely it's going to be a heuristic that's partially good. If it's perfect, you don't need the machine learning. So you're going to have to create your golden dataset with manual labeling, or by going and cleaning public or private dataset that already exists on the internet. There's going to be a bunch of metrics that we are going to start monitoring right away. But first, let me explain a couple of things. Inputs, outputs in our system are basically user is going to tell Fairy what's the list of ingredients. Fairy is gonna fly to a granny unicorn and give her the list. Granny unicorn is gonna produce the recipe, and then the fairy is gonna get that recipe and ingredients, throw it into the oven, and return to the user finished cupcake. In other systems, your user input and user output is probably going to be some web app or mobile application. Your pre-processing pipeline is going to be very complex. It's going to be handling authentication, a bunch of other stuff, permissions. It's going to be a whole complex system, which luckily here I can just say it's pre-processing pipeline and ignore the complexities. But be aware, in the real world, this is quite complex. Same for your post-processing pipeline. Lots of stuff is going to happen there. But for now, inputs, domain expert prediction, and data storage is where we are going to focus most. However, we talked about a couple of metrics. Here, first thing we are going to start tracking is what is the number of active daily users. We don't need our machine learning model to track that. We can do that inside of our system. And this is important because when we go to our dad or business owner, we're going to have to tell him, okay, today we served 50 unicorns and that made us X amount of money. And tomorrow we can say, okay, the number is increasing. In your case, it might be time spent on your website, click-through rates, user engagements, anything else. You will notice that here we are not measuring accuracy, we are trying to get to the business metrics first, because they are the most important part of our system. And it turns out Our launch was a success. We got the first users and they seemed quite happy. However, Gram Unicorn can only work an hour per day before needing her nap. So now that we have validated our idea with the market, we can start with our machine learning model. But first thing first, more metrics. Always think of the metrics. Well, first thing when you're training your model, which you're going to be thinking is accuracy. How can I get 0.05% more accuracy on my model? And this is perfectly fine. When we are training models, things can be rather straightforward. We know inputs, we know what are the outputs, and we can easily tell when model has produced the wrong output. However, even when we get high accuracy when training the model, that's when we need to call our common sense fairy and not be satisfied with just that one number. We need to look a bit deeper and see what's the accuracy in different segments of our data. For example, overall accuracy can be quite okay, but it can fail in specific geography. Proactively search for the low performing ones to understand when you need additional labels or data. Don't be satisfied with accuracy. Find where your accuracy is low. For example, in our case, maybe there's 2% of the unicorns that don't want to use rainbow in their cupcakes, which is madness. But for them, model is going to perform horribly. Even though for the other 98% is going to work perfectly fine. So we did this, and we learned a bunch of other interesting stuff. And we're ready to go further. Congratulations! At this moment, your model is at its most accurate. It has finished training. Hopefully your training set reflects the state of the universe at that exact moment. Well, I got some sad news for you. From this moment on, it's only the journey downhill. Just as no plan survives first contact with the enemy, same fate awaits your model when it meets the real world. Which leads us to our next topic. Second day. This is the expression that is used quite a lot because usually machine learning scientists, they're focused on the first day, training your model, and they don't think what happens once that model goes outside and starts being used. There are a couple of scary things out there in the real world. First of all, we almost never get the ground truth instantly. Ground truth are also called actuals, so keep that in mind. Sometimes it can take minutes, days, or even months in some cases. For example, when we are doing insurance fraud detection, which will require investigation to determine if model has made a correct prediction. If you're working in finance, you're usually going to get the ground truth in about several milliseconds, because your model has either lost or gained money. However, for majority of us, due to the lack of data luxury, we're not going to be able to determine accuracy of our model in the real time. You will sometimes have to do manual labeling on the inputs, try to do that at the end of the day. That's expensive and takes a while. So what we're going to do, we're going to monitor other things from which we can determine our model performance. So let's get started. We're going to use something that's called quality metric. This is an amazing idea that I heard from Lina during her talk on machine learning operations, episode 24. And quality metric is a simple heuristic that you can apply and get a feedback on how your model is performing in the real time. It's highly dependent on your business use cases, and no size fits all, which makes this metric extremely difficult to figure out, but also extremely useful. And here are some of the best practices for making your choice. It should be something comparable across different models, because over the time we will want to look at the previous models and the current models and see how they improve based on this metric. It should be simple and it should be collected in real time. This is why we want to generate this metric inside our system instead of getting the feedback from the user. And it should allow for actionable alerting on problems. And this is all quite important. Metric on which you cannot connect and which you're getting way too late is something that is not very useful. So spend some time on defining your quality metric in advance and then set up alerts about that. Because if something goes terribly wrong, you want to know that as soon as possible. And you want to be able to see how your model is performing when you need to do some tuning up, retraining, or stuff like that. As I mentioned, it's quite hard to choose a good metric. And that's because choosing a quality metric doesn't require just data science. You need to think from a business and user perspective to find something that would be a very good approximation of how good our model is. For example, here, even though we are dealing with unicorns, things are not easy. Here are some of the candidates that we could use. What is the percentage of the cupcake that's made of at least 50% rainbows or any other ingredient? We can use that to measure our cupcake quality. But this is not quite as good. Second of all is how many ingredients are not being used. As I mentioned before, unicorns don't have arms. So they're just going to bring a bunch of ingredients in a basket, get their cupcake and walk away. All the leftover materials are just going to be left there at the bakery. And we want to be eco-friendly and make sure that as much as ingredients are used. Normally, using this without unicorns in mind is going to result in some disastrous recipes. But unicorns are not very picky, and things they bring out are usually quite eatable when mixed together. So let's go with this. Let's talk now about some not so good candidates for quality metrics. How happy are unicorns with the cupcakes? This is something that people are going to try and implement first. However, there are problems here. First of all, this is very subjective metric, and we want to be objective as possible. It's going to depend on the type of weather that day, mood of the unicorns, bunch of different factors, and there is a very high ratio of noise to signal in there. We can use how often do they return. That's much better indicator of how they are satisfied with our service. But it's going to take quite a long time in order to get this metric. So in that case, not something we can use since it's not real time, but it takes quite a long time. And as I mentioned before, now that we have some training set, we're going to make our first model. And it should be as simple as possible a model, because trust me, now that we are starting to actually use machine learning, there's gonna be a bunch of stuff that we need to build in the background to make sure it's working correctly. Don't go with a deep learning, complex neural networks, decision trees, linear regressions, random forests. They are all good and simple candidates, which are also quick to train and very fast to respond to your requests. However, once again, common sense is required. And the next point is, know the limitations of your model. This is an often skipped step, because usually this is a step that we skip quite often. But it is extremely important. Luckily for us, we have a common sense fairy. So before we get unicorns use our machine learning system, she runs out and get a bunch of colorful looking mushrooms. She gives them to a system and makes sure she gets a cupcake, which pretty sure can be classified as a chemical weapon. Also, word of advice to all the listeners out there: if mushroom is colorful, do not eat it. So before letting this into production, we need to add another system that will check if some of the ingredients are poisonous. This is the stage of the machine learning model development, where I give you the permission, and you should give yourself a permission to go completely crazy. We want to see what happens on the edge cases, outliers, when we give inputs to the system. In our case, we can provide no ingredients or just several metric tons of sugar and see what's going to happen in those cases. For example, if your algorithm is detecting if there is a dog or cat on picture, try giving it a picture of a giraffe or a wolf, or even better, a picture that has cats and dogs. Rainbow picture of just single color. Create your outliers. Once you know this limitation, engineers can incorporate them into pre-processing system and add some rules for handling them. And don't worry if you can't think of enough crazy stuff. Your users will soon do that job for you. Once again, don't forget to check the accuracy in the different segment. You need to know if your model has any biases. In our case, current system is biased against non-rainbow eating unicorns, since Grandma Unicorn doesn't have any recipes without it. This is something we will have to address in the future and keep a close eye on it, in other words monitor it to ensure fairness. So this is where you want to detect all the biases of your model. And now we're ready for the deployment. We might just wish to deploy machine learning model in production. And one very good tactic is to deploy it as a shadow model. Basically, anytime you have drastically different model, you want to use this tactic. In our case, we can have model doing prediction during the day with a Grandma Unicorn. At the end of the day, she, the domain expert, can analyze the model outputs and decide if the model is ready for deployment. You're going to have to make multiple iterations, it's going to be frustrating. But it's not scary, since we already have a working model that's providing the value. Name of the game is iterate, iterate, iterate. Now, important stuff about shadow model. It uses the same inputs as production model, it's deploying the production along the existing model. However, its outputs are not served to the user, but stored in the data store, so we can take a look at them and see what's different between them. And then we can decide, as I mentioned with our domain expert, if this is something we wanna proceed with. Bear in mind, there are costs associated with this. Since you are using two models, your pricing is going to be at least 2 times as the usual. However, here, in many cases, benefits outweigh the faults or the costs. And here is our architecture so far. It's quite simple and also quite complex. As I mentioned during this talk, I'm going to try to give you as much as possible of the overview of everything at a high level, because actual implementation is going to differ from domain to domain, and it's going to require quite a lot of usage of common sense. So brace yourself. Here's how we're going to proceed. They are pretty standard, and as I mentioned, with the deployment, we already know about shadow deployment. There are a couple of other deployments about which I'm going to talk in the next slide. So A/B deployment is quite interesting. Here we're going to serve our new model to a section of the users, then compare that with the results gotten from the user that were served results from the existing model. This is extremely useful when we are tracking other metrics and we want to eliminate the noise. For example, user click-through rate, time spent on the website, number of returning users, and a bunch of other business metrics that are quite subjective, can easily contain a bunch of noise. This way, by just changing the model, we'll keep the environment the same for them, and we can actually make good predictions between them. And direct deployment, that's something you're usually doing when you have pretty good picture of your domain and you just need to retrain it on the new data. In finance, this is usually the way you do it. just retrain the model every day, deploy it and see what happens. Usually it's gonna behave the same, but a little bit better. And our first model is now in production. It's been a long way, but we made it. However, our work is long from being done. We're going to talk about some difficulties of monitoring machine learning models. You see, when we are monitoring traditional code, it's quite easy. You basically can take a look of the web page, see if that's available, see if your code is throwing exceptions, errors, take a look at the log, and that's all. You're just monitoring your code. However, with machine learning models, due to their complexity, you're monitoring your code, machine learning model, and the data around it. Machine learning models are very flexible, and that's their greatest strength and weakness, because they're going to take all sorts of crazy inputs and they're gonna give you outputs. If you give, for example, to a SQL database invalid query, it's gonna report an error. Here, as long as it's nicely formatted, your machine learning model will produce outputs. So we are going to outline a couple of common techniques that we can use to solve those issues and detect them. Well, first of all, we have model decay. As Heraclitus said, only constantly life is change. How fast you will need to retrain your model or replace it with a completely new model depends entirely on your domain. If you are working with weather models, you can probably go away with few months or years without changing them. However, with climate change, that's also very acceptable to quick changes as well. There used to be a very good opinion that models related to physical properties are almost set in stone. Well, there's exception to everything. For example, a model for detecting faces worked quite fine, but with the recent pandemic and face masks, those models need to be changed and fixed to accommodate changes. On the other hand, we have some domains that are highly changeable. Financial markets are unicorns. As we're going to find out, their tastes are going to change quite often, and we're going to have to retrain a bunch of models to accommodate them. Now, how we detect problems with our model and decide when we need to retrain them, that's using drifts. Drifts represent the difference between statistical distribution of the trained data and the data we encounter in production. Main disadvantage compared to the quality metric is since they are statistical distribution, it takes time to gather the data. So we can have enough to make a judgment or detect any problems. However, they are quite good at detecting subtle changes and various other problems that include time dimensions. Don't think of them as a replacement to your quality metric, but as another tool in your arsenals. There are three main drifts. We have data drift, that's the input distribution difference. We have label drift, that's the output distribution difference. And we have concept drift, changing the relation between outputs and inputs. Let's go over this. Data drift. Well, if you need to pick one drift to monitor, this is the one. It will help you catch majority of the errors and situations that require your attention. Also, here's where you're gonna catch outliers, aka crazy stuff that you never thought of, which you can add to a training set or add rules for handling those sort of cases. If anything starts going wrong, this is the drift that you usually going to notice it first. If there are problems with the pre-processing pipeline, stuff is going to be shown here. If something is changing in the real world and your model needs to be updated, you're going to detect it here. Also, be aware that usually your models have time dimension in them, even if you don't think of it that way. For example, in our bakery, distribution of input is going to be quite different during the workdays and completely different during the weekends. So we need to factor that in. We also want to do some slicing of the data in order to monitor is there any input drift on specific segments of our inputs. As I mentioned before, on unicorns they do not like rainbows in their cupcakes. In fact, this sort of monitoring important and frequent that usually people call all the drifts data drifts, and then name this one input data drift. But when talking about data drift, this is the one that's usually mentioned, so bear that in mind. Output drift. This one is debatable. Some people would say it's not required to monitor. However, with the output drifts, this is a very good metric to measure if your model is going crazy. Since if there is no drift in your input data, but your output is behaving quite different, for example, outputting the same value all the time, that means usually that something went wrong with your model. And you need to redeploy the old one or see what happened there. So these are very good for detecting problems with the model. Otherwise, it's quite hard without this metric to see if everything is working correctly. Since as you make your way through the machine learning, your model is going to grow more and more complex. And this is a good way to keep a tab on it to see if it's behaving as it should. Concept drift is quite interesting. It usually happens when you get a new batch of training data or when you have to relabel the older samples. As your training data grows, this metric will ensure that your model is up to date with it. In an ideal case, this is the drift that's going to display the difference between your model and the real world inside of which it's operating. However, there is a problem here, and that's what makes this drift so slow and hard to detect. That is the existence of the lag between your training dataset and your real world. You're going to get a ground truth or the actuals with a significant lag. So determining this drift is hard, and doing it fast is very hard as well. Here are a couple of types of concept drifts. They can be sudden, gradual, incremental, recurring, or blips. Now, blips are interesting because those are the outliers that you want to incorporate into your model or can add some rules. But the first four types of actual concept drift, those are scary, especially the sudden concept drift. You need to have very good domain knowledge in order to predict those. And they are usually quite costly when they happen, because your model is going to start producing completely wrong predictions. And it takes a while to realize this, because there is no input drift, there is no output drift. But since the ground truth changed, until we get those into the training data, we're not going to detect this. This could be introduction of some sort of new regulation into our industry, something that went completely crazy, for example with the pandemic and how the finance systems were working, and almost any type of system that was working completely fine in 2019 and was not working in 2020. For this, we need to monitor the real world and our model in order to get it fast, because late detection here is expensive and very risky depending on your domain. There are a couple of common mistakes that we can do. Usually we can cache certain types of inputs, so when our model is doing analysis, it will not include those inputs, and it will detect an input data drift. So we want to include those as well into statistics. We can do multiple prediction nodes, but here we need to remember to aggregate statistical diagnostics instead of doing it per node basis. We can include user feedback, and that introduces a bunch of noise. So as mentioned before, use A/B testing for our models instead of including user feedback directly. We can have biased data. And this is something we need to be aware of from early on. As I mentioned, test your model and know their limits. Not taking time into consideration. As mentioned before, our distribution of the inputs output is going to change depending of the day of the week, months, holiday season, bunch of other stuff. So that's something we have to keep in mind, even if your model is not taking time dimension when considering appropriate features for predicting values. And with that, we can start with new steps. Training new model, deploying it to production, keep on monitoring, repeat, and repeat, and repeat. At the start of this, I promise you a happy ending or tragic ending. Well, plot twist. This is a never-ending story. If you have made it this far, and you have a very good monitoring procedure, and also procedure for quickly iterating and deploying models, this is not going to end. There is no point in which you can walk away and say, okay, this model is perfectly fine, let's ignore it for a couple of months. You're always going to be working on improving it, adding new features, or deploying other models that will depend on it, or even provide inputs for it. Things are going to evolve, but as they evolve, don't be afraid. Just keep on monitoring stuff. Thank you all for your time and for watching this presentation. You can always connect with me on LinkedIn. I love talking with people, discussing all the machine learning and engineering stuff. See you out there! And also, another bonus, I'm organizing a workshop on this very young conference. We're gonna take a pre-trained model, set up some API for it, deploy it in AWS, do some monitoring, very basic monitoring, nothing of the fancy stuff we discussed here, basically health checks and stuff like that. And we're going to do microservice architecture and how to break monoliths into it, because at the end of the day you want to be using microsystems and asynchronous predictions in order to achieve scalability for your system. Thank you.
It was a great talk by Bojan. I hope everyone has their questions noted down for Bojan, who will be joining us during the Q&A session. So before I introduce the next speaker, I would like to ask everyone, do not hesitate to share your opinion and questions in the chat. And also stay tuned for giveaways and exciting announcements. And the active participants will have the possibility to win 3 tickets to any of our upcoming events. So keep asking questions and leave your comments. Moving on to our next speaker, Masa, who will be talking about exploring AI pipelines with Elyra and Kubeflow. Just a brief introduction about Masa. She is a developer advocate at IBM, focusing on the AI and microservices. She works with variety of AI and cloud native technologies. She usually works on building solution, writing new content, and engaging with the developer community. Due to the time zone of the speaker, the next talk is going to be pre-recorded. However, the speaker is also joining us at Q&A, so please prepare all your questions in the chat, and I will announce them during our Q&A session. So I'll just add the video for Masa. 1 second. That just a second. Trying to pull up the video for Masa. Mm, So here we go.
Hi there. My name is Masa Abu Shamleh, and I'm a developer advocate at IBM, and I'm so excited today to be speaking at the conference in which I will be talking about Elyra. So I'm based in Dubai. I focus in cloud native, AI, and DevOps. You would usually see me working with technologies like OpenShift, Kubernetes, Watson, and much more. And I'm really passionate about women empowerment, sharing knowledge, innovation, diversity, and inclusion. If you have any questions about today's session, or if you have any questions about the technologies that I work with, just feel free to reach out to me on my social media, on LinkedIn, or on Twitter, or even on my email. So before talking about Elyra, I would like to actually introduce to you the team that have worked on it. Codate, Center for Open Source Data and AI Technologies at IBM. This team aims to make AI solutions dramatically easier to create, deploy, and manage in the enterprise. They are made of over 40 developers and data scientists who contribute and advocate for the open source technologies in the AI offerings. And you can see so many of their projects around data asset exchange, model asset exchange, AI Furnace 360, and much more, including Elyra. Now, first, let's talk about data science pipelines or machine learning workflows. As data scientists, we usually follow a specific pipeline in which we work with our data all the way to deploying the model and maintaining it. So first we acquire the data, then we analyze it and pre-process it, then we train the model based on our data and deploy it, and then we keep on maintaining the model. This is a very repetitive pipeline because you just want to keep on improving your pipeline, your model, and so on. In addition to that, we all know that many of the projects can actually have over 80%, around 80% of it takes around 80% of the pipeline work. So many of these tasks are performed iteratively. For example, when you want to use a specific data set for multiple projects, so you're just reusing the steps of acquiring the data, analyzing it, and maybe cleaning the data in different projects. Now, there are two ways in which you can build your data science pipelines, like the monolithic pipelines and the monolithic notebooks and the modular notebooks. In the monolithic notebooks, this is where you would have the entire pipeline in one place, in one notebook, starting from acquiring the data all the way to the end. While for the modular, this is where you would just divide this monolithic notebook into multiple ones in which each notebook focuses on one task. For example, you would have a notebook for acquiring the data, another one for analyzing the data, another one for pre-processing the data, and so on. This way, it helps you to make use of code reusability and much more, which makes it easier for you to build and your pipeline and save up some work. This is where Elyra comes in handy, in which you would make use of reusability of code by just having code snippets in each notebook. And you can also integrate it with Git to control your source code. In addition to that, you have the Python editor, so you can edit and debug while you're building your pipeline. You can also run these batch jobs in your notebooks, similarly when you're just working in any Jupyter Lab notebook. And finally, you can just simply build your machine learning workflow using pipelines. So Elyra 2.0 is built on Jupyter Lab 3.0, which has so many feature highlights like visual debugger for front end and Python editors to support auto-completion, find references, linting, and so on, in addition to improved code snippet handling. This is a very nice example of the pipeline that we will be demoing today. So when you want to implement machine learning workflows, you would just be working with modular notebooks to make reusability in other projects. For example, in this pipeline, we're actually working with loading the data and then pre-processing the data. These are working in consecutively, so starting with the first one and then the next one, and then we're just connecting this pre-processing data step with two different steps that work in parallel. you can combine your tasks in the pipeline to automate the execution. In this way, you can design your pipeline however you like. There is no scope to however you want to build your pipeline. You can just build it in the way you want it to work. So next thing is I want to actually introduce Kubeflow. Kubeflow, by definition, is a scalable, portable, distributed machine learning platform that runs on Kubernetes. You can run it anywhere, like on premises, on hybrid cloud, and public cloud. Now, why should you go with the Kubeflow? There are so many reasons. For example, if you are working in a team with the other data scientists on your team, each one of you is tackling a specific task. This is where Kubeflow comes in handy. You do not have to worry about working on the same machine or not having the right version of your notebook. So it's all in the cloud. You have the same place to work together on. In addition to that, the use of resources. You might not have enough resources on your local machine, and this is where you're going to need to use resources by a cloud provider, such as IBM, in which you're going to consume GPU, in addition to, for example, if you have data sets that take up so much space, like in gigabytes and terabytes. There are so many examples, but of why should you go with the Kubeflow, but these are just a few. So talking about pipelines, there's a Kubeflow pipelines and there is Elyra pipelines, and you can notice the huge difference in these pipelines, and we'll explain them now. So with the Kubeflow pipelines, it actually starts with defining the pipeline artifacts, and then you would compile them into a workflow specification, which is then uploaded into a pipeline on Kubeflow, and then you're going to run it as a pipeline run. While on the other hand, when you're working with Elyra, you just simply assemble your pipeline, and then you're going to make a pipeline run. You can run your Elyra pipeline locally on Jupyter Lab or on Kubeflow pipelines. So in this case, when you're going to assemble your Elyra pipeline locally, and then you're going to ask for it to generate your pipeline on Kubeflow, it will just automatically do all of the steps for you, from generating the pipeline artifacts to uploading them and running them. We'll just have to build them on Elyra. Now moving on, I will be showcasing the demo, how you're going to work with Elyra and how you're going to build your pipeline. So first of all, I would like to actually take you to the documentation of Elyra. This is where you can also take a look at it. Like, it has all of the resources you're going to need for your data science pipelines and so on. In this case, in this page, I'm showing you that you can install Elyra locally. You can run it locally using pip, using Conda, even using Docker, for example. And I personally use Docker. I'm used to it much more. You can just simply run the Docker pull command if you want to pull the image locally, and then you can just run using Docker run. So you just go to your command line and just run it. Make sure that you have Docker desktop, running on your machine. And then you're just going to wait for it till it runs. You can see it has executed them for you. And you can just copy this link here in your browser, and it will open for you the Jupyter Lab on your local machine. Now, let's take a look at the GitHub repository for this one. This is where you're going to need all of the resources when you want to work with Elyra pipelines. Just go to Elyra AI examples, and you will see everything you need, from tutorials to documentations and so on. And we will be actually using this GitHub repository in our demo. This is where you're going to have the pipelines, for example. The pipeline here we'll be using is Hello World. You can actually run Elyra pipelines also on Apache Airflow, in addition to Kubeflow pipelines, and on your local machine. So this is like how it's going to look like once you're going to run your Docker container, for example, in which uses Elyra image. And as you can clearly see, you have the Elyra components here. there's the Python editor. Once you click on it, it will open a new page for you in which you have to just drag and drop. Now you can just simply write your own Python files or notebooks, I mean, to just create your pipeline. But you can also integrate it with Git repository. You can just go clone a repository and paste your GitHub repository here, and just it will clone it for you. So it might take some time till it clones it, and then we actually can see that it has created an examples directory for us. In this examples directory, we can see that we have the pipelines that we were going to use. So we're going to go to the hello world because we're going to run it locally. We're going to open pipeline editor, and we can just simply drag and drop our nodes or our modular notebooks here. So as you can see, this is a really nice GUI in which you can just, just add your nodes wherever you want. And so to connect them, you just simply click on the circle here, and we're going to connect them like that. Now this pipeline actually shows us the weather stats and data of JFK weather data, and we'll take a look at them in a bit. Now, if you try to save and run the pipeline, you will notice that it is in error state. And that is because we have to define a few properties. If you actually hover over it, you will see that it's telling you what kind of error you have. There is no runtime image, and it's pretty much the same error in all of the nodes. And this is the first thing that you have to do, which is you're going to have to go to properties. And as you can see, there are several things that you can add, like runtime image, CPU, GPU, and RAM. You can also add the file dependencies, environment variables, and output files. So in our case, in this pipeline, we're going with the pandas, runtime image, and we're going to do the same for all of our nodes. Now, but we have to also keep in mind that there are a few things that we have to do as well. So because we need to add an input to our pipeline, so the first node will have to add where the environment variables for it. So if you actually take a look at the notebook for this one, you will notice that it takes a data file, a dataset URL as an environment variable. And if that environment variable is not available, it will give us an error. If we try to run it again, we will get an error. So we will get an error if we actually try to do it, and that's why we have to provide it. So you can find the environment variables in the Git repository. If you just go to pipelines, hello world, and then you will find the tutorial here for it. If you scroll down all the way to this section, you will find the value of your dataset URL, environment variable. Just copy this link here. So make sure, okay, and it's called dataset URL in caps lock. And we also have to provide an output file for this one, because this is in case if you want a specific output to be injected into the next node. And in this case, we're going to go with the data. This is when it's going to generate for us these files. So it will generate a directory for us. And we're going to save it. And we're going to run it. We can give it entitled 1, for example. And it's going to show us that it's in packaging and submitting pipeline. So this might take some time. If you go to your command line, you will see that it is executing. Yeah, So see, because I was running the pipeline and I did some overwriting, it showed me that there were some changes to it. So we're just going to try to run it again. Okay, this is because see these errors are happening because of the previous pipeline I have run. So it's, as you can see, like the previous pipeline has been executing. So if you go to the new directory here, like that has been, so you will get a job execution succeeded. This is where you can be sure that your pipeline has been successfully created and run. If you go to data, this is where you can see the data that has been generated for you. For example, the JFK weather.csv, this is one of the outputs that we got from this one. If you actually go back here and scroll all the way till the end, not this one, we'll just have to go back to here. As you can see, it has given us this outputs in the directory. We have seen some changes in our notebooks, and in one of them is the first one that it has created these directories, which we will be using one of them in the output as an output from this node and an input to the next one. So we have the JFK weather, the CSV file, the JFK weather cleaned, and so on. And similarly, if you try to view the next notebooks, the other notebooks, you will see that they were run, and you can see the output of them. You can take a look at them. Feel free to spend some time reading them. And if you actually go here, you will see also your pipeline for the last two steps for analyzing the data also have been successfully executed. So this is pretty much it. Like, this is just a small demo of how Elyra works, but feel free to explore it as much as you want. It's really nice, especially if you like to play around with data science tools, and if you would like to make, you know, to see how it makes a data scientist work easier. You can also do it on Kubeflow if you would like. Feel free to do so. So in the end, I would like to actually just, okay, so this marks the end of my session for today, and I hope that you found it useful and informative. Just feel free to play around with Elyra, learn more about Elyra. There are actually a few examples of using Elyra for real use case scenarios. And next thing is, you can also find these resources. I will make sure to share them with you. You can also try out IBM Cloud account for free using this link that we have for you, ibm.biz//PyGeekle. You can see so many of data science and AI tools. If you're interested in any specific technologies, I would be really happy to share with you, like NLP, AI, data science, making chatbots if you'd like, or you can do so many things, and all of that for free. In addition to that, you can also join Elyra community through the forum, chat room, GitHub, in addition to more examples on Elyra. And last thing, before we leave, I would like to share with you an important announcement, which is Call for Code. Call for Code is an initiative that I'm really passionate about. It aims to come up with solutions for the communities that need it the most. This year, we're focusing on climate change, focusing on the 3 themes: zero hunger, clean water and sanitization, and responsible production and green consumption. This is a good opportunity for you to showcase your work, to build solutions for the communities that need it the most and have an opportunity to win $200,000 in grand prize. In addition, for your for your project to become an actual working product for the communities that need it the most, using open source technologies, the challenge has started. So if you actually are interested, just visit developer.ibm.com/forward, call for code for more information. If you have any questions about the challenge or today's session, just feel free to reach out to me, and hope you have a good day.
So it was an amazing talk by Masa. I hope everyone has their questions noted down for Masa, who will be joining us during the Q&A sessions in a couple of minutes. So before I move on to Q&A session, we have one more announcement for all of you. Our speakers prepared for you a pool of private workshops where you can get much more information on the topics. I'll put the link on the chat where you can check it out. The link is pythongeekly.us/workshop python. So I've added the link on the chat. And now for our Q&A session, let me invite our first speaker, Bojan. Hello,
Hello,
Bojan. How are you?
everybody. I'm fine. How are you?
I'm good too. So I'll just start with the question. Now, so here is our first question. You said that instead of using ML algorithm every time, we can use simple if-else loops. How well do you think replacing ML algorithm will improve the interpretability of the model?
Uh, First of all, the main point I want to say is that instead of starting with a machine learning algorithm, we can start with if-else loops and then further extend it. So I'm not saying you can replace every machine learning model with if-else loops. However, what I wanna, yeah, definitely it's gonna suffer a bit, but there are ways you can work around it. If you build a decision tree model, it's very easy to understand. Logistical regression, super easy to understand. For deep learning, there are already some tools out there. One of the other speakers in the senior track has a great book, Explainable AI in Action. I'm not sure if I got the name correctly, but that goes very deeply into the topic of how you can make your model as easy to understand as possible.
Okay. Thank you for thank you for your answer. Moving on to our next question. So how can we counter concept drift using different knowledge bases?
Hmm. Plan in advance. It's it depends very much on your domain.
Mhm.
And if you can plan it in advance, make some predictions, you can probably train your model. I mean, the greatest problem with the concept drift is how fast you can detect it. Because concept drift is going to happen. But with knowledge base, you can at least know when it's going to happen and plan in advance around that.
Okay, means but uh,
Yeah, feel free to ask me.
yeah, I have this question. So I guess this question actually asked what I wanted to ask. Consider a scenario where we have a same word used in different contexts, right?
Mhm.
There are a lot of words like that. So one of the easiest example can be apple. So it can be so in one particular context it's a fruit, another particular context it's a company, right?
Mhm.
Now, so during your talk you mentioned about concept drift. I guess this can be a good example of concept drift. Now, how will you think we can employ this knowledge bases such as like we have dbpedia, we have wikidata, which are which has a lot of relationships and a lot of entities related to most of the domains, which are basically trained over the Wikipedia database which we have. So how do you think using that's gonna be useful and that's gonna help us encounter this problem?
Hmm. Honestly, I haven't really thought about that because when concept drift happens, it's usually panic, and you use data drift to detect it in advance. So that could be a very interesting idea, but I haven't used it in practice, so I couldn't say more about that.
Oh, that's totally fine. So
No,
I'll move.
that's completely great. It gave me quite a good idea to try it later.
Oh, you're welcome. So I have another question. So what do you think? Which role will AI play in the Web 3.0?
Honestly, I don't know, and I can't wait to be surprised because when Web 2.0 started, I don't think anybody could imagine what we have today with Twitter, social networks, and everything. We were moving that to a social network and more interoperability, but it's gonna be amazing, and nobody's gonna be able to predict it. That's all I can say in that regard.
Oh, thank you. I'll just pull off the next question.
Yeah,
So
if I'm not explaining something correctly, uh, feel free to stop me and let me explain it again, because if I'm trying to put up too much of jargon in there, I'm not understanding it right.
okay, I'll do that. So can you explain more about the qualitative evaluation about model performance in real time?
Yeah. As I mentioned during the talk, that's probably the hardest thing you can have figure out how to do, and the most amazing thing you can have in your system. And it's very hard to generalize. There are some of the basics stuff that your quality metric needs to have, but it's going to be completely different based on your company and your use case. It's something you really need to sit down with your stakeholders and figure out what's important for you for this model. Because as we all know, once model goes into production, you don't get access to the ground truth at the same time. There's always some lag, be it in hours, minutes, or even weeks and months. So you need something that's going to tell you, okay, this model is performing well, and that needs to be something that everybody can understand. In my case, I use leftover stuff from the recipes because we wanted to be eco-friendly and stuff like that. If you're using some recommendation system and you're implementing new model, there's probably some set of default recommendations that you're going to offer to a user and some of the customized recommendation. Then you're probably going to measure a number of customized recommendations delivered to a user. If you are working in the fintech, it's going to be completely different. Thing is, almost every other company is going to have something else that is important to them. And depending on that, things are going to change. So follow this couple of guidelines, but it's something you really need to figure out for yourself. Lena did excellent talk on MLOps regarding that, so I advise everybody to check it out. In my slides, I have a link towards the exact episode.
Okay, thank you. Now I have another question. So you talked about recommending recipes based on the ingredients we have, right? So I have this question. Consider you have 10 ingredients, and so there is a recipe which you can make out of those 10 ingredients. But one of the ingredients, you're missing just one of the ingredients which is present in the database. Okay, so consider the salt, right? So in the database, it's fresh salt, and what we have is black salt. For some of the cooking recipes, you can use black salt instead of the normal salt. So how do you think this? I guess this should again come under concept drift or data drift. So how do you think we can encounter this problem?
Okay, that is a very, very good question. Uh, when I talked about concept drift, I would basically put that down as blips. Basically, that's an outlier. First time we encounter it into system, and we want to mark it because we're probably not going to take that new ingredient into equation because we don't know how it behaves with everything.
Mhm.
But we want to use it to create some of the new stuff that's going to work with it, basically it into the recipe. So for that, I would just add it first as an outlier and then see, okay, more and more unicorns are coming up with black salt. Okay, we need to add this to training data and consult experts and do some more labeling of the data. But that's the very important stuff. You want to watch for that because when you get that, you need to know your response. Are we going to ignore it? Because then we can serve a cupcake without that ingredient. Or are we going to do something else? Maybe just directly contact the domain expert so he can deliver the result there. There's going to be multiple layers there. And as I mentioned, outliers are going to happen always. And you need to have some sort of plan how you're going to handle them.
Okay, I guess that makes a lot of sense. Thank you for your answer. So I'll move
Yeah,
on
it was a
to
very good question because in production, all sort of crazy stuff happens. You're gonna get things you never expect were possible.
yeah, I totally agree to that. I'll move on to the next question. Does there are any standards that should be agreed, accredited, or accommodated by the AI algorithm or AI system?
Uh, well, first of all, that would depend on your geographical location. Because for a bunch of countries in European Union, every model that's deployed in the production and working with something that's directly impacting people is required to have some explainability. Because, for example, if you reject a loan to some person based on your model, you're by law required to have explanation why you did that. Your system cannot be a black box. However, if you are in USA, some of those your regulation might be a bit lax. So first of all, you have regulations based on the country you live in. And second of all, which is a very active area today, is ethics of the AI and reducing biases. That's something we as researchers need to keep a watch on. Basically, we don't want to create biased data set on create models that discriminate against somebody.
Mhm.
And that's a very hard thing to do because it's very, very easy to create biased models, as we have seen with a bunch of examples in the past. So regarding some other broad standards, I don't think there are any at the moment. Feel free to correct me.
Means I guess I'll agree to that. So thank you for your answer. Now moving on to next question. So we have a question asking you to share your story about becoming CEO of Software Effect.
Oh, well, that's an interesting one. Basically, I was working for a Silicon Valley company, and
Mm-hmm.
it was going pretty great. And I worked with a bunch of interesting stuff. At one point, I spoke with my younger brother, and we decided, you know what we should do? We should start a company. So we had it was just two of us and a couple of our friends, and we started working. And it's pretty jumpy at the times. It's much more stressful than I originally thought bunch of other problems because once you start working as a CEO or in any management role, you realize that your programming skills are not as important as your soft skills. And once you develop that as your management skills, then you realize as a CEO, there's a whole new different stuff that you need to handle. There's also negotiational skills. There's also branding, marketing, bunch of other decisions. So yeah, it started as a fun idea, and then I realized it's actually a work. So I learned a lot of things in the past 3 or 4 years. I worked as a CEO of several other companies, but this is one I completely was founder and started it from the ground up. So it was the most difficult one to create and keep it running, and also the one that I learned the most.
And this is a question from my side. So, how do you think? Means what are the main differences you want to point out before COVID scenario and after COVID scenario while being a CEO and managing your company? How different it was?
It was extremely different. So basically, I'm quite open and transparent about things. So in February, we had 5 clients and 5 deals. And then in March, when whole COVID thing started, everybody put everything on the hold. I think it was until July that business started picking up, because first 3 months, everybody was like, let's wait until this goes away. Even though lots of businesses in that area, clients which we were negotiating at the moment were projects about bringing their entire business online. And they decided, this is the code, we don't want to bring our business online, which I realized later is not quite a good line of thinking. So it's definitely been much slower, and during the negotiation process, there is much more examination. It lasts much longer.
And
So it's been
please
hard.
go ahead. And I guess when you try to negotiate with the customers during this COVID period, I guess this time they have a upper hand because of all you have very less options of businesses. So
yeah, that's the strange change in dynamics, because before COVID there were much bigger demand, and now at the middle of the COVID there was a huge supply and very little demand, because everybody was just waiting out on COVID to go away. But now I think everybody's pretty used to the whole COVID situation, so things are developing normally. But it's been a hard year.
okay, thank you for your views on that. I'll move on to the next question. So here we have, how can a beginner get into a career with the machine learning, artificial intelligence, or data science?
Okay, here there are a bunch of advices that you can apply. First, you can start with statistics. There are a bunch of excellent courses on Coursera about that. You can grab a book. You can start with linear algebra, matrices, and everything. You can pick some of the frameworks such as TensorFlow and PyCharm. Not PyCharm. Okay, my mind is blocked. TensorFlow and PyTorch.
Yes.
And you can do it like that, or you can do it the fun way. Just grab scikit-learn, which is going to provide you with a bunch of easy models. Find some interesting data set and just create something. With scikit-learn, you can do it in 15 minutes. It's 10 lines of code, and you instantly get something that you can use. That's what I love when starting out. I love to see, okay, I'm going to use machine learning. Let me see what I can create with this, because like every career, if you go into machine learning or AI because that's the hot thing at the moment and you want to make money, you're not going to last a long time. You need to find something that you love doing into that. And the first step in that is finding what's fun for you. There are a bunch of data sets on Kaggle. You can look at them and see, I can, from this data set, I can make this prediction or something like that. And just play around with that. Get used to exploring concepts. And after that, you can go more in depth once you try to realize how everything works. Also, one good advice that Masa have gave me during our previous Q&A is learn in public. Basically, create your blog post, write about your learning process, difficulties you're having. People will be able to help you, tweet about that. And when you're applying for a job as a junior, somebody who has entry-level position, people are going to be most interested in your capability to learn, which you're going to be able to demonstrate using your blogging, tweeting skills, your ability to admit mistakes, because we all make mistakes. I make mistakes every single day. I made several mistakes during the last 5 minutes. So what's important is ability to admit that, showing that vulnerability, and also your communicational skills. Because knowledge, you can acquire that while you're working, and any decent company is going to provide you with a mentor that's going to help you grow in your company. But your attitude is what's most evaluated at a junior position. Nobody expects you to know everything and a bunch of different mathematical formulas. I personally absolutely hate the whiteboard programming, because that way you're going to learn how to solve problems for interview, and then when you get to a job, it's completely different. So just learn, find your fun and talk about it. Do not be afraid. Python community is very, very friendly, and there are a bunch of people wanting to help out. I'm also offering on LinkedIn virtual coffee. I'm not a data scientist. I'm the person, basically other people create models, they make them super great, then I take them apart, make them production ready, that run super fast, make them reusable, all that stuff. I leave the magic to the others. But I can give some advice and the guidance on how to do that. I do this for free. I love talking with people. So just connect with me on LinkedIn and I can talk with you and let you know, okay, you can go this way, this way. Maybe I can help in that regard. But it's a very individual journey.
I guess after you have said that you're going to receive a lot of connection requests on LinkedIn, because people mostly wanna. That's really great. I'll move on to next question.
Just to circle back as much as possible here. When I was starting, I was completely lost, especially my first company. I was doing PHP development directly on the production server by using Vim as an editor there. So in case you don't know, you never want to directly develop on production server and debug stuff there. And I really wish somebody at that moment would spend half an hour and tell me you need to have testing, deployment, you need to use Git, because I didn't even use Git at the time. So I know how important talking with somebody who has more experience in that area can accelerate somebody and help them avoid some pitfalls. I wish I had somebody at that point. So that's my way of trying to give back to the community.
That's really great. So I'll move on to next question. How can we avoid the overfitting in our model? How useful can qualitative metric prove when encountering this problem?
Yes. Well, overfitting is hard. because there are some models that are going to be very, very dependent on your data and how it's structured. For example, with random forest, it's very hard to overfit stuff, especially with ensemble methods. However, neural networks love overfitting because they love creating the most difficult decisions possible. So my advice is usually grab 30% of the data, hide it away, don't let your model ever see them, and use do validation and training on the rest of it. Then once your model is ready and you think it's going to be super good in the production, write on that 30% of the data, and that will give you some sort of the picture. Other stuff I advise is also do a shadow deployment. Put some real user inputs into it, and get somebody who's the domain expert to take a look at the model and see if that is producing any nonsense or if it's working correctly. There are multiple steps to test it, but usually just taking part of your training the dataset and using it for verification, that's going to work quite fine. However, there are cases when that doesn't work because usually you don't have enough data, especially for deep neural networks. There's never enough data. So in that case, you probably want to do some testing yourself and see how it's behaving.
Yes, I guess that makes a lot of sense. Thank you for your answer.
Yeah. Feel free to ask me sub questions, anything, because I love explaining stuff. And if I cannot explain it clearly, I do not understand it.
I'll move on to our next question. So you mentioned deep learning. We have a question on deep learning. What are your views on deep learning models mimicking human brain?
Well, currently, I think we're still far from that because as we learned with the latest developments in neurology and cognitive stuff, our neurons are much more complex than the ones we use in neural networks. And there's a bunch of stuff that we still have to add to the neural networks and deep learning models so they can be something close approximation of our models, of our brains.
Yeah.
So in that regard, it's a very rough sketch, but I don't think that's my humble opinion. It's not going to get us to the true general AI. The same as Brothers Wright when they created the first airplane. They didn't mimic the birds. They created their own thing. So I think something like that is going to happen with the AI. My opinion. I'm not the expert.
Thank you for your... Yes. Please go ahead.
What's your opinion how AI is going to come? Will it be an extension of deep learning or something completely else?
Means, so there are two aspects of it as I see it. So there has been a lot of means the deep learning algorithms, the new algorithms have been evolved a lot. They have been using reasoning, they have been doing reasoning, they have been using causality and the domain specific knowledge bases to improve their means to mimic or be more like a human brain. And then there is another aspect where we see the old type of AI or the traditional AI, which we used to call it the neurosymbolic AI, which is also emerging now. So people have started working more and more on it as it can be easily used to create more interpretable models, more explainable models. And instead of using the black box algorithms, which we call the deep learning algorithms, it can be used. It means these neurosymbolic AI says that it is much more simpler. The model can be easily understood by a human. So I'm guessing these are two different aspects, but that's what I think. That's where AI can be. So it can be either of it.
Hmm. I prefer your answer to mine.
Thank you. Thank you for that. Uh, I'll move on to next question. So, what are your views on data privacy and home automation IoT systems?
Well, I haven't worked with Internet of Things that much. I know that privacy, security in them is a nightmare. I worked with a couple of companies where we were using Internet of Things for sensor data and collecting stuff. And since we are in European Union, it's very strict regulation because you cannot store any of the personal data. You need to ensure your system gets anonymized data at all times. So in European Union text to regulation, you have to really, really be careful about that. As a company which is working with any sort of private data, you don't want to have them in the system because especially if you're using some learning techniques and customer wants to retrieve all his data or delete it, going and deleting everything into your database is going to be super hard. So you want to anonymize data as much as possible. Plus, on the bright side, that gives you more unbiased data set, which is what you actually want to use. So from the company perspective, I think in European Union text to regulations, it's pretty good. Now, from the security perspective and how that impacts data privacy, from what I hear, it's pretty not so great. It's something that still needs to be developed. Now, I don't know how it's in other regulated countries and systems.
Thank you for your
Your
answer.
opinion?
Uh, so I have worked on for quite some time on IoT systems, not specific to home automation, but I worked on it. And one of the major concern, which I think related to data privacy, is how nowadays these home assistants and home automation systems have been started personalizing with the user. They have been means I'm not sure if it was from the start like this, but nowadays it's more like they track each and every move you make inside the house, online shoppings, and places where you visit, how health conscious you are, and all those things to track and more personalize more to the user to give much better results and much better what should I say, to automate things based on users preferences, to be more precise on that. But as soon as it does that, it allows another person, let's say a hacker, to breach into the privacy of somebody else and get all the data and all the preferences of that particular user, which can be dangerous sometimes. So I guess that's a pretty important concern in these home automation systems.
Yeah. Also, uh, continuing the stuff you said, very big concern is the feedback loop, because model has something that's optimizing for. Basically, was it increasing stuff you're going to buy from Amazon, or amount of time you spend on the website? And the more you spend it, the more it's going to move your behavior towards that. So it's not just that model is learning from you, you're also being influenced by the model to move towards that point. And that is something that's particularly scary to me in that regard.
Yes, I guess yes, that's another important point.
Yeah.
So I'll
You
move on
are,
to a yes,
you're a
please.
really good co-speaker.
Oh, thanks a lot. Thank you so much. I'll move on to a next question, which is actually related to what you do. What are the processes to implement and to deploy an artificial intelligence algorithm? So you said you work on deployments. I guess
Yeah.
we can have a much better insight on that.
Yeah. So basically, what you want to do is see what's already deployed, because usually there have been some attempts to deploy stuff. And then you want to identify how is it working. Because in some cases it might be a horrible solution, but it's working and there's no need to change it, and then you don't have to do it. Yes, there are a bunch of best practices, but sometimes common sense prevails. If it's going to cost company hundreds of thousands of dollars to rewrite a system that's perfectly fine and working just to be aligned with best practices, then that's not an acceptable option. But usually how I do it is I get researchers and see what they were working on, get Jupyter Notebooks, then extract that into smaller parts that they can reuse. Usually a bunch of researchers working on the problem have their own notebooks, and they're reusing the same parts of the code. So I reduce the code base there. Then their trained models are deployed into a system. I also set up monitoring around that, because you always need to monitor stuff and you always need to test it. And then I speak with them regarding performances, because usually people are used to, oh, we got a bunch of AWS credits, and that means we can run everything on GPU. And I try to make it run on CPU with some acceptable performances. As I mentioned during my talk, accuracy is not everything. If you can lose 1% of accuracy in some cases and get a CPU instance instead of a GPU, you have just reduced your cost by 90%. So I work with startups also. So my main job is also, since I work a bunch of other stuff related to AWS and DevOps, is to make sure that the moment their credits run out, they don't get five number bill or something like that.
I guess that's an important point to consider.
Yeah, I mean, at the end of the day, very hard thing to understand, and the most important thing is to evaluate what is the return of investment on your algorithm, because once you know that, you can make decisions, and that's very hard to evaluate, but it is the most important thing, because if you have a model that is generating $10,000s of value per prediction, for example, but it costs $9,000s to run, that's perfectly fine. And if you have a model that costs 50 cents to make a prediction, but brings you 0.1 cent, that's horrible. Yeah, so first of all, it's getting the big picture, seeing how that solution works inside the current business and see what needs to be changed there, and then getting into working order. I mean, fully deployed and super nice solution is basically monitoring for data drift, using qualitative metrics, using a feature store, versioning your database, doing all that nice stuff. But that takes time, and you don't have the time when you start with a project.
Yes, I totally agree to that. So along this line, I would ask a question. So, like in your talk, again, you discuss. This was one important point which I really liked during your talk was instead of using ML models, we can go with easier algorithms, easier heuristics such as FL loops. So how do you think, what difference or how big a difference does it make when you deploy a black box ML model and when you deploy a simpler if else looped algorithm? How big
Oh,
difference do you think it makes?
usually, when people are starting to go into machine learning, it's because of the hype. And the first thing you want to ask the stakeholder is, okay, what value is this going to bring us? and you don't want to start with data scientists there, which is why I say do some heuristic, anything else to see if that's actually going to bring you that value back. First of all, find a product market fit, and then start searching for your model, because the first iteration of that solution is what's going to bring you the most value. Because that's going to bring the users and everything. Everything else is just going to be incremental improvements. Even if you take your logistical regression, for example, that's 80% correct, and replace it with some deep neural network that's 90% correct. That's going to bring you less value than you had when you implemented that first logistic regression, when you went from 0 to 80%. And in some cases, you can run into uncanny value. There's a very good paper from booking.com where they created super accurate model that freaked out their users, because they were able to predict all the routes where user is going to be, even if he wasn't, even if he didn't type that. And they were spooked by that. How did they know that stuff? So too much accuracy can be bad, and usually with black box models such as deep learning, you need a bunch of data. So in most companies, the data is going to be completely dirty. It's going to require time to prepare. Or in other cases, you don't even have the data and you have to label it. And labeling is slow and expensive. So it's going to be very expensive to start straight away with a black box model. And it's much easier to fine tune the stuff on your much more easier to understand model. It's faster to develop, and you can bring some expert to take a look at it and see if it makes sense.
I guess that covered a lot of important points.
Yeah, if I miss something, ask me.
No, I guess the answer was really good. Thank you for that. I'll move on to our next question. How do you think artificial intelligence can be applied to social entrepreneurship?
Okay, here is where I have to share my own ignorance. What is the social entrepreneurship?
So, a company that maybe I guess a entrepreneurship, social entrepreneurship basically refers to a company that is solving a social problem, such as, let's say, we know that garbage was a big issue, right? The plastic bags. So a solution to that was paper bags that can be that can be called as a social entrepreneurship. So
Oh,
in that sense, what do you think? How can artificial intelligence be used to solve some social problem, or solve a problem which is I should say solve a critical problem which is affecting a lot of people? How do you think it can be used? Any use case or any example that comes to your mind? That
oh,
would be great.
it can be used in a bunch of ways. One of the organizers of this conference, I was talking with her several months ago, and she was using to track the impact of COVID on global CO2 and green gas emissions, which was pretty amazing, and identifying which is the main causes of that. Another cool stuff that I saw is company that was working on vertical farming, and they were using machine learning to optimize plant growth and everything in that. They even brought one of those racks, and it was super amazing because you get everything in one rack, so you can just build on top of it. And machine learning was handling everything from growing dead plants and stuff. Also, we saw some pretty good breakthroughs with protein folding from Google recently, which is probably going to help a lot with developing new medicine and stuff. But as I mentioned in my talk, we can say a lot of things about human history, but one thing that we cannot say is that people are rational. true problems that we are facing today, they are social in their cause. And as such, I don't think AI is still smart enough to deal with our insanity. Because you can solve technical problems, but at the root of it, there's a person or people. And dealing with that as an engineer, so you'll have to think, oh, I'm going to find a tech solution for that. No, you're going to need somebody from humanities to help you with that stuff, because usually those problems are super hard. So it can be applied to a bunch of things, but there are certain limitations. We still need the human touch in that.
Okay. Thank you for the answer. I guess that was a really good answer.
What do you think
Moving.
about that? I'm
Yes.
really interested about that.
What do I think about that?
Yeah, impact of AI on social entrepreneurship. How can
Uh,
AI make work better?
well, one of the most important use cases, I guess, which is emerging during this pandemic is mental health. So I guess one of the important and most concerning and most of the countries in the world is mental health issue. So I guess AI can be definitely used to help some people. So let's say if somebody has suicidal instinct, so there can be a bot which can mimic human and support and try to build a conversation along with the person and bring him back to a normal stage from where he had suicidal instinct. So I guess that's one of the important and major area where I see AI being used for a social entrepreneurship. That's my
Mhm.
view.
Yeah, I love it.
Thank you. So my next question is how to measure the success ratio of a tested artificial intelligence algorithm.
Oh, that's super easy. How much money does it make? Yeah, it at the end of the day, it boils down to that. Because most companies, I'm talking about companies, not for non-profits,
Mhm.
they're going to be interested if not in your code, not how well it's written, but best practices, but how much value is this bringing back to the company? How much is it earning us the money? You can use, I have seen Excel used as a machine learning environment, and it brought companies that were using it hundreds of thousands of dollars. So that was perfectly successful solution for them. Uh, would something else be better? Maybe, definitely, but it created value for them. For nonprofits, it's a bit harder to measure it directly. But for example, if you're helping in health tech to deliver medicine, to optimize the routes and something like that, you're doing that to help people. It's very easy. You can compare yourself toward the conventional way of delivery and yours and see, okay, we delivered the medicine to 10,000 more people. We saved 10,000 lives today. That's your metric. It's you don't measure the success of your algorithm by measuring your algorithm. You measure the impact it has on the world at large, or your company, or anything else. You want to create solutions that change the world, even if it's a tiny, tiny, tiny bit.
Yeah, I guess that was a really good answer. That was a really good answer. I actually never
What's your
thought of.
opinion?
Yeah, so the metric which you said, I never thought of it, but yeah, that was a quite well explained answer. And from my opinion, I guess it depends on the sector you're using your AI algorithm. Again, coming to healthcare sector, it's completely accuracy because if if it detects a false positive, or if it goes for a false negative, it can be disastrous. So that's one thing I'll go with. And let's say, considering at the sports sector, where let's say for football they use AI algorithm to track back the balls and all that. So again, in that, I'll say how precisely it can track back the ball, how precisely it can detect the speed, and all those things can be used to measure the success ratio. So from my opinion, I think it along with what you said, along with how much money it makes, with different contexts where this AI algorithm is used, the success ratio changes a bit.
Absolutely. I mean, different industries, different stuff. I spoke earlier about how 80% of accuracy is completely acceptable. I was talking about web application. If you're working in health tech or air industry or anything related to human lives, everything below 100% is unacceptable. And your model is going to be below 100%. So it's always going to be unacceptable. And you need to have a bunch of stuff in there to make sure that nothing goes wrong. Because it's one thing to have a bug, and it's another thing to have a dead person in your conscience. So
Yes.
your domain is going to dictate your development and your procedures drastically.
I guess there has been a bit of spike in researchers targeting the domain of healthcare mainly. So one of the domains which I remember last year, I don't remember the company. So they made an algorithm which can actually read the X-ray and interpret. So like how a doctor would read an X-ray and tell, yeah, you have X disease and you have Y disease. So they actually created an algorithm for that. It still needs a human in loop, the algorithm, but I guess that's a good start. And now there has been quite a big spike on this particular domain of research, because again it's offering a lot of money, along with I guess improvement in or fastening the process of recognizing the disease or diagnosing the disease.
Yeah, and that's the other stuff I would like to point out. In those models, you always want to have a person at the end. Your model is there to help doctor to reduce the work they need to do. So instead of going over 10,000 of images, they need to look at the 10. And they're going to be super focused on those, and they're going to deliver better results. But you don't want your model to decide if a person needs to go to a surgery or chemotherapy or something else. You need to have a person there to check everything at the end. And yeah, I mean, lots of people are now going into med tech because of corona and pandemic and stuff like that. But in the end of the day, it has accelerated quite a lot medicine.
Yes. I guess that's a really good answer. I'll go on to last question for this Q&A session.
Mm-hmm.
Can humans coexist with AI currently or potentially in the future?
Oh, that's a very easy question for me to answer. In the previous Q&A talk, I already gave my answer. As long as AI provides me with cookies and ice cream, I can live with it completely peacefully. It's very easy to lure me somewhere. So it's a super evil AI. As long as it gives me cookies, I'm just gonna completely ignore the Skynet and all the robots from the future. And currently, as much as we love talking about AI and stuff, we don't have AI. We have machine learning, and we have a bunch of mathematical formulas thrown into a big bag of something. So we're still far from AI, and we do need to think about what's going to happen when we get there, because I think we are going to get there. But when, that's the matter of discussion for somebody who's way, way smarter than me. I just like cookies and ice cream.
Thank you, Boyan. Thank you for an amazing Q&A session. It was really fun, and thank you for sharing your content with us. It was really great.
Thank you. I absolutely loved you as a co-host, and I learned a bunch of things from you as well.
Oh, thanks a lot. It's my pleasure. Thank you.
Anytime.
Okay. Thanks a lot, everybody, for an amazing Q&A session. Those who have any more questions can connect with our speakers through various handles and contact them via their email. Now, once again, thank you for commenting in YouTube and Pine that you like the talks. We really value that because all our speakers and team worked really hard to make this event happen. We are having a giveaway for our events among those who will post on Twitter and tag our official account of geekly.us, which goes by Geekly Official, and write what you liked most in event, topic, or about any speaker. There will be 5 winners and they'll get 3 free tickets for the event. Now we are half a day through our event and now it's time for more front-end goodness. Our next fresh prize is for Angular.js Global Summit 21. Angular has changed, so what's new? Angular 9 Plus is a hot subject of discussion in professional communities. What's the migration process? Are there reasons to move the non-Angular project to Angular 9 Plus? There are a lots of questions, and we want to help you find answers. To bring the discussions to a next level, we have gathered the world's most powerful Angular specialists, speakers from Microsoft, Google, Samsung, Forbes, Vermeg, Gorilla Logic, and other companies are ready to share their special tips and tricks and their knowledge about the new Angular 9 Plus version. 20 tickets are available at $79. It's first come, first serve basis. So don't miss your chance to get this best price, and more flash prizes are coming soon. So my moderation block is coming to an end now. And as much as I would like to stay here with you guys and listen to the next speaker, it's time to return to preparation of the next events. I want to introduce to my colleague Mohammed Adel, and Mohammed is going to be the moderator for the next few hours. I'll so our previous speaker has shared his LinkedIn profile here. I'm gonna put that in the chat. So anybody who had any more questions or want to connect with him, they can send him a request on LinkedIn, and he'll be happy to help you out. So here we have Mohammed who will be moderating further. So Mohammed, where are you now? How are you feeling?
I am fine now. I am in Egypt.
Oh, that's great. How's the weather there?
Everything is good here. Yeah.
Okay, so we had a great session. The chat is a bit not so active, but I guess it's gonna get better now. So I'll give it to you. Thanks
It's a
for
great
your
one.
time and attention.
Thank you. Okay, good morning, good afternoon, good evening, everyone. Welcome to Python for ML and AI Global Summit 21 by Geekle. My name is Mohammed Adel from the Ocean Science and Technique Academy, and I will be moderating the session today. We have around 7,000 registrations from every country in the world, so welcome everyone. Today we have great session. So let's start with Albert DeFusco from Anaconda. He is a data scientist and will be talking about Tranquilizer. Albert, floor is yours.
Oh, thank you, Mohammed. Right. Is audio working okay?
Yeah, everything is
Great.
okay.
Share my screen here. And I think we are good. Right, so I'm going to talk to you about a tool that I've been developing and working on for a few years now called Tranquilizer. And the tagline I like to say is, put your Python functions to rest. And we'll explore a bit deeper about what this little pun means. So my agenda here is to talk at a high level about what it means to productionalize an ML or AI model. And you may have heard this word. It gets used a lot these days, or deploy or operationalize. And I'm not going to try to go through every one of those buzzwords, but I'm going to give you an overview of what that means and how people do that. And they generally do that by creating what's called a REST API, a little web server microservice way of inputting data and receiving a prediction. And then we'll wrap up with an example of how we can use Tranquilizer to go directly from our Jupyter Notebooks to a serving REST API. And you can take that then to any number of cloud services. And so let's start with this productionize. And I think I've changed my spelling here. You can say productionize or productionalize. It's fairly open how people sort of interpret this. But in a general sense, I want to be able to create a prediction service. I've got my Jupyter notebook that has my model code and everything's all wrapped up there. And it can be challenging for other people to utilize that, especially people who are not seasoned data scientists. And there are some people who really don't like Jupyter notebooks for a number of reasons, some of which are more valid than others. And to be able to create a prediction service means that I can use the power of my machine learning model in an application, maybe a phone app, or some other way of getting this information. And the real goal is to be able to enable non-experts, non-data scientists, to be able to interact with my model. And in general, the word people use is somewhat more often as deploy. I've got a machine learning model, I want to deploy it, make it available as a service. And you'll find dozens of articles all over the web about how people are doing this. And in general, they're commonly sort of aligning around using a microservice approach, a little web server with a particular structure to the way that it accepts and sends information called the REST API. And so here's a little graphic to kind of put this all together. And in reality, everybody has already been using something really close to a REST API. Every website you visit has most likely got a back-end service to feed the data into the thing that you see on the front. So the client here is my desktop computer, and I'm sending requests back and forth to an API. That API is maybe connecting to a relational database in the background. You know what? I'm really sorry here. I think there's something happening. I think there's an emergency. I have to step away for a minute. All right, I'm sorry to have stepped away. I think everything's okay, but we'll check on that in a little bit. And so just like a website that you put in your URL bar in your browser, we're going to talk about programmatically accessing data from the web, where we're going to have the same sort of structure with a domain name. Here's some website.com, some path, some way of identifying, the kind of information I want and how it's laid out. And in the end, this endpoint. You might think of the endpoint as a function, and that's going to be a very useful abstraction for us a little bit later. And in reality, microservices are now the building block of modern web scale applications. You can think of something like GitHub, that I'm sure many of you have used. The GitHub front end, what you see on the website, is all powered by requests to some REST API to retrieve information about a user, about a repository, say about issues. And this is a very powerful abstraction that allows developers to separate their application into multiple smaller components, say the interface, this backend service, and now adding in these ML AI prediction models or recommendation engines. And all of this can be written in different languages, controlled by different teams. And all they need to make sure they do is align on how these HTTP requests are being made, what information comes in, what it looks like coming out. And it makes it very easy to scale the components that need to scale. If the database needs to be a little bit bigger, or if you need more CPU and RAM for the prediction engine, you can scale those components individually. And you could even swap them out. And that's something else that you may have heard about in the news with, say, your news feeds on some social media, is that you get in little experiments. The companies are going to test out a different prediction model, and they can do that very rapidly with microservices and REST APIs. So let's see a quick example and something that maybe you're not so aware of. I'm going to go and work with a REST API right here from my browser. I'm going to look at the GitHub API. And so I'm going to visit api.github.com/users and my name, Albert DeFusco. And instead of seeing a nice web page with graphics and buttons, I'm just looking at the raw data. And this is coming back to me in a JSON format, the most common way of sharing information on the web. And this is the nuts and bolts of working with a REST API. It's all the same kind of things that happen on the web, just without all the JavaScript and the nice graphics. Going to my terminal here, I can work with this REST API in a programmatic way, say using the curl, make a request to the site and get back this information. And I can use it programmatically, for example, in Python. And I do that with the request package. And here I'm doing a couple of things at once. I'm saving all of that information here in a response object. The response is telling me I didn't have any error codes. And I can convert that into Python objects like dictionaries and lists by parsing the JSON. And so I can extract individual pieces. And these are just sort of the basic ways that we can interact with these REST APIs, again, served by any number of mechanisms. We're going to talk about how we can build these REST APIs in Python. And before we get too deep in there, we're going to go talk a little bit more about why this REST API is so useful and important. And I see it as a way of piggybacking on mature technologies that have been around since the dawn of the internet to enable these very new cutting edge machine learning services and capabilities. We can piggyback on technology that already knows how to do authentication and authorization, that already knows how to think about scaling up these services, and then becomes broadly compatible. I was using this thing with my web browser. I was using it with my Unix command line and with Python. People know how to work with HTTP requests, and it becomes very easy for them to work with your machine learning model. And so REST here stands for Representational State Transfer, and it's a specification for sending and receiving information over the web, over HTTP protocol. And there are a number of common commands that we use to retrieve and send information. In the examples I was showing up till now, we were using the GET request, which is your way to retrieve information. And that's what your web browser already does. Every time you visit a HTTP website, you're performing a GET request and receiving back information. Your browser is receiving HTML and JavaScript, and it uses that to render the website. When we start doing programmatic REST API calls, we'll be able to post and update and put new information into the service. So you might use the post to create some new record, or the put an update to update that later on and be able to delete from it. And this is all sort of been built up on a sort of database-like model. So it all looks like selects and inserts and updates and deletes. And we see that the post request command is the one most commonly used for ML and AI models. Now let's see another example of this post before we continue on here. And I'm going to again use Python. And what I want to do is send data to GitHub. So I've got here the URL for the issues on my GitHub repository for Tranquilizer, and we'll just open this up right here as well. And what I want to do is programmatically create a new issue. And so I'm going to send it some bit of information. I'm sending it a new title and a body. I'm so sorry again. Okay. Working from home has new challenges, and we all work hard to meet them every day. Right, so I'm going to send this new bit of information. So the data here is now a JSON encoded string, and I'm going to use the requests library with that URL. I'm not showing you my headers because that has my secret token authentication information in there. It should have it in there somewhere. Probably doesn't have the S on it. I get back a 404, so that means I didn't, must have misspelled something here. Did I misspell something? Huh. Well, this is a good example here showing that it's possible that I've not quite put my request together correctly, and I may have to revisit that if I can identify what I did wrong here. All right. I was hoping to have demonstrated that I can programmatically create a new issue and have it appear on the site. That's not really the point of our talk. We want to get into ML and REST APIs. And to do this in Python, there are a number of tools and frameworks. The leading tools are things like Flask and Tornado and Django, and emerging a tool called Fast API that I really like and find very interesting. But the problem for us as junior data scientists or even seasoned data scientists is that this requires a lot of code. It requires sometimes a lot of knowledge that a more software engineer background may have, people with a history of web programming in Python. And so it can take a lot of effort, and it feels overwhelming to try to learn how to do this, especially if you spend a lot of your time in Jupyter Notebooks, because these tools don't natively support Jupyter Notebooks. But every time you go out to the web and say, how do I productionalize my model? The first thing they say is, we're going to need to make a REST API. And sometimes they'll show you all of the code it might take in some of these other tools to get there. Now, along the way, you're probably aware that several cloud vendors have developed these end-to-end machine learning platforms that can take you from data exploration to a deployed model being used in production. Things like SageMaker or Seldon, IBM, and many others provide a service that can help you get all the way to a REST API. And those are really powerful and very valuable products, but not everybody uses them. And the tool that I'm going to talk about today, Tranquilizer, is somewhere in the middle. It's not going to be as much code as it takes to use Flask or Tornado, but we're also not tied to a cloud vendor. We're going to be able to create our own REST APIs in Python and be able to take them wherever we need to. And we're also not pinned to machine learning and AI. We'll be able to write REST APIs for anything that we can do in Python. And so really the dream is to change this graphic a little bit and to say, I want to develop my API using Jupyter and be able to have it interact with the client just like any other API that we can interact with out on the web today. So it would be great if I could take this little function. This is a function that's converting Fahrenheit to Celsius, and be able to serve it as a REST API. What we're looking at the right here is a standard documentation style presentation of a REST API that's called Swagger. And we can see here that there's an indication of a HTTP GET with an endpoint called toCelsius. That's the same function name as in my notebook here. And it takes an input, a number, the value in Fahrenheit. And with this Swagger view that we can open up in our web browser, we can practice with a REST API. And many of the REST APIs out there on the web also have this Swagger documentation that you can visit. And it's something that is pretty common. So this is our dream. We want to go from notebook to served REST API with as little work as possible. And so Tranquilizer lets us do that in as little as one line of code. And with a simple command line function to run. And as I said, it's not just for ML and AI models. So here's my function again, toCelsius. There's a couple of things going on here that you may not be really familiar with. Firstly, I'm using what's called type hints. I'm telling the person reading the source code that Fahrenheit really should be a float, even though Python won't enforce that. Python doesn't care whether I use a float or a string to call this function, but by using type hints, I'm informing the person reading the code that you should really use a float here. This is what I intended to. I intend it to return a float back, but it could as easily return an integer, unlikely with the division. But these type hints are not currently used by the standard Python interpreter to sort of error or block your code from running if some of these things don't match. But they're going to be really helpful in generating our documentation with Tranquilizer. And so to enable Tranquilizer for a function, I just add the tranquilize decorator. And the key skill here is to be able to write good functions. Type hints go a long way and they're very powerful. And as we'll see in the example a little later on, if you write good doc strings, we'll be able to add even more documentation to our REST APIs. And you can get access to the Tranquilizer package here at the source at GitHub. It is an open source BSD licensed package where you can install it with pip or conda. And so we want to be able to create these REST APIs from any Python function. We can have as many Python functions as we wish within a Jupyter notebook or within a Python script file. Tranquilizer will automatically create this Swagger documentation for you, with a few caveats on the way that you write these functions. It works really well when the inputs can be JSON serialized. And we don't need to belabor that point too much right here in this talk, but things like strings, numbers, lists, and dictionaries are the most commonly used arguments in your function. Tranquilizer goes a little further and tries to help you out with something more sophisticated, like having date time variables. You can pass NumPy arrays, you can create REST APIs that receive image files or text and binary files. Something that, again, is a bit harder to do with Flask and Tornado, but still possible. And finally, we'll demonstrate that Tranquilizer is easily integrated with Docker so that you can take it to a larger service. You can use things like Nginx for reverse proxies, SSL encryption, and all sorts of other web technologies. And it becomes very easy to integrate this into larger ecosystems. And so to install Tranquilizer, you can get it from pip or conda. It's a good point to also make sure you add the nv-convert package if you're using Tranquilizer with the Jupyter Notebook so that it knows how to read that notebook correctly. The second step is to decorate whatever functions you need to in your Python code. And then finally, to run the Tranquilizer server. Here we're using the command line tool Tranquilizer that works on Linux and Windows and Mac. We give it the notebook or script file, and it will run the server here on our desktop. And at the end, we'll show an example using Docker. So let's take a look at how we put together a REST API from a machine learning model using Tranquilizer. And you'll see here at the bottom is a link to the project that I've prepared for this talk. Let's go take a look at that. Stories, Python Summit. So here in this GitHub repo, I have two notebooks, one to train the model, one that we'll use to serve the prediction functions. I've got all the data that I need here and the packages that need to be installed in an environment.yml file compatible with Conda. So I'm using Python 3.8. Because I'm going to be developing in a Jupyter Notebook, I'm using the notebook package. I'm reading data with Matplotlib, or with pandas, doing some plotting, and I'm going to create a machine learning model with scikit-learn and serve it with Tranquilizer. So I've downloaded the repository to my desktop. I've created the Conda environment, and now I can run Jupyter Notebook and get started. And so we'll start with the train notebook. And here's my task. My job is to predict the total number of bike rides for the local Pittsburgh bike share system for any given day. And things I know today are the forecasted maximum temperature, the month, and two Boolean flags: is today a weekend or a holiday? And so I've prepared some training data to support making a model that accepts these inputs. And I've gathered training data for several years worth of bike rides within the city. So for every day over the last several years, I know the maximum temperature as recorded. I have the month, whether that day was a holiday or a weekend, and I've gathered the total number of bike share rides. The bike data is all public information in here, and I think I'll upload the data processing notebooks as well to this repo a little bit later after this talk. So I've got all of my data here, and to sort of indicate that I may be able to make a reasonable model, I can see that there is some correlation between the maximum temperature and the number of rides. Certainly, it's not very popular to go take a ride when it's below freezing. But there is some nonlinear trend here. I feel like I could probably make a reasonable enough machine learning model. So I'll begin by splitting my data into train and test and making sure that I I stratify across something like weekend, or you can stratify across month to make sure that you put enough data and you don't sort of miss something important between training and testing. And I'm going to go ahead and use a gradient boosting model here to build my regressor, because I have this nonlinear trend. A simple logistic regression wouldn't work as well here. And I need to do a little bit of processing on this raw data. And I'm going to do that, use the column transformer so that I can put together a number of different pre-processing tools all at once to operate on the input data. I need to do a one-hot encoding on this month column, because that's a string and our machine learning models can't really deal with strings natively. I need to scale the maximum temperature between 0 and 1, and I'll use the min-max scaler. And then I'm just going to pass through the two Boolean columns, weekend and holiday. And I've chosen a couple of hyperparameter values here for the estimators and the validation fraction and the tolerance here on my gradient boosting regressor. And I put all of this together in a pipeline. And the reason why I'm using a pipeline here is very important, because I want to be able to accurately reproduce all of these data processing steps on new data when I create my prediction engine. My prediction engine is only going to receive the maximum daily temperature as a number between, say, 0 and 120 or so. Well, probably like -10 or so. And I'm going to have to let the pipeline scale it for me as it's making a new prediction. And that's pretty easy to do by putting everything in a scikit-learn pipeline. So we'll fit the model, and we'll see if it's pretty good. So we get a decent balance between the train and the test score. Maybe it could be improved a little bit. So I've got my model ready. And to think about the next steps in productionalizing it, it's important to think about saving the model or persisting the model. I need to save the model as it is right now, because I don't want to go and retrain it. This was a pretty quick model, but in reality, models can take a long time to train, and just to use them in a REST API, I shouldn't have to retrain them. I should use them as is. So I'm going to create a pickle file. And in the next step, when we create our prediction engine, we're going to read that back in. So moving over to the next notebook, let's form the prediction functionality, and we'll start to serve that as a REST API. And so to do this, because I'm using the model pickle file, I don't even have to import scikit-learn. I need to have it installed, but I use joblib to load the model into memory. Then I can use that anywhere I need to inspect the model or to create predictions. And I've put together a couple of functions here. The first function is going to give me a way to report on the hyperparameters used to train the model. And I'm going to prepare that and serve that as a GET request in Tranquilizer. The function here is called params, so I'll look for a params endpoint later on. And this is going to return for me a dictionary. So by decorating a function here in the notebook with Tranquilizer, it doesn't change how the function works. I can still use the function without any modification or notice that anything's different in my notebook. But when I go and serve the Tranquilizer model, because this function has been decorated, Tranquilizer will go and pick that out from all the other code in this notebook and make sure that that gets served. And now on to the prediction function. As we know, the prediction function needs to accept maximum temperature as a float, month as a string, weekend and holidays as Boolean values. And so I type hinted all of those things, because that's going to add that type hint to my documentation. It's also going to validate, so that when a user is trying to send a request to the REST API and they send a string instead of a float for max temp, they'll get an error telling them that that was the wrong thing to do. And now something new with this function is I'm using my docstring here to provide extra documentation. A docstring in Python has two main parts: a short description in one line, a blank line, and then a longer description of the function. Here I'm using what's called Sphinx style parameter identification. I'm identifying that max temp is a parameter input to the function, and I'm giving it a little bit of a description how to use it. All of this will be picked up by Tranquilizer and put into that online documentation. And so finally, I put all of my values together in a data frame, just like my original training data, and I can predict with it. It's going to do all of the pre-processing steps automatically for me because it's in that scikit-learn pipeline. And again, my Python function hasn't changed. It's still available, and I can still run it as is. So see, today is April, and it's pretty warm today, but it's not a weekend or a holiday, and I predict around 284 bike rides today. So I've got my notebook put together, and I'm going to serve this notebook as a whole REST API with those two endpoints. Now, normally you might do that in the command line, but I'm already here in the notebook, and I'm going to go and run the Tranquilizer right here from my notebook. And again, this works on Windows, Mac, and Linux. And that's going to start up the server, and I'll allow the connections. And right here, I can click on the link and visit the documentation and practice with my REST API. Again, I see I got my two endpoints, a params and a predict. And the good thing about Tranquilizer is it lets me practice, or the Swagger lets me practice with the endpoint. I can execute this endpoint, and I get back those values. It also gives me the curl command, as I showed earlier on the command line. Let's take a look at the prediction function as well. Notice here that that first line description from the docstring came right in this documentation here. And then because I added each of those parameters in the docstring, they also get added in here as a description. We see that the data type matches number and string and Boolean. Let's try this again. So 85.0, it's April, not a weekend, not a holiday. And again, I get 559. And that's all it takes to get into using REST APIs with Python, especially with Tranquilizer. I've imported the Tranquilize decorator, and I go and decorate any function I need. And I'm not changing anything about my functions. Their functions are still valid Python, and they would still work the same way even without the Tranquilizer decorator. So back to the slides. Let's talk about some best practices as we wrap up here. It's good to write fast functions. Users like it when their web sites load quickly. People like it when the REST APIs return data quickly. It's important to not mess with anything that you've got loaded into memory. And we call this changing the state of something like a global variable. You don't want to set some dictionary or some list and append to it, because then every time I run my REST API endpoint, it might give me a different value back, and that can be a bad thing. And this is generally a good practice for creating REST APIs. And something specific to Tranquilizer is you want to avoid unnecessary cells. And that's the reason why I put my predict function in a different notebook from my train, because I don't want to rerun all the training steps. I just want to use the model that I created, that I saved as a pickle file. And so it's a good idea in Tranquilizer to avoid loading data, or at least avoid setting up cells that take a long time to run, because all of them are executed when Tranquilizer starts. And then it may take a long time for it to warm up and be ready. And then you can have a large memory footprint for this model and this REST API. And something really important for TensorFlow is to make sure you load the model outside of those functions, because if you have the model load inside the function, it can easily consume all the memory. And that's just a standard best practice for TensorFlow, and a good idea for scikit-learn as well. And to finalize this, now that we've learned how to create a REST API, you can now take that with you. You can take that into a container and build a Docker image that contains your notebook and your model files. That Docker image can then be brought to a cloud hosting service, things like AWS and Azure, and Google Cloud, I'm sure all have ways of running a Docker image. They can then be put together with more sophisticated things like reverse proxies and other things like load balancers to make a really robust REST API. And to learn more about this thing, the best thing you can do is to identify that anything you can do in Flask, you can do with Tranquilizer. So if you were to just go find something on the web, how do I run Flask on AWS? You could think about just replacing all of that Flask code with Tranquilizer, replacing the sort of run app.py with the Tranquilizer command. And you should be able to make use of any of that information out there on the web. And to give you a little preview here, there's a Docker file in the repository, and it is a very short Docker file to base it on a mini conda base image. We copy in this project. It's going to have my notebooks, my data, my environment.yaml, which is then utilized in the run to create and install all the packages. And then finally, I'm using conda run, so I don't have to worry about activating my my environment to run the Tranquilizer command over the predict function. And again, that's going to serve it here on port 8080, which is somewhat common, I see, when people use Docker. And so that concludes my sort of overview of REST APIs, why they've become really important in machine learning and AI, and how Tranquilizer helps get you started on that, and is a great way to take your Jupyter Notebooks and to start to build REST APIs, to productionalize them, to deploy them. And so thank you for your attention today. And if you want to get in touch with me, you can find me on LinkedIn.
I think we still have around 4 minutes, and maybe you can share with us your story with Anaconda.
Sure. So
Yeah.
this is pretty interesting. People ask me about this a lot. I came to Anaconda as a data science instructor teaching Python about 5 years ago. And I had come right out of an academic career, and I had no experience with data science. I had been a programmer for a while. I've been using Python for a while. And I spent those 5 years learning about data science while I was teaching it. And that was a really good experience, and something that I think has worked out really well for me.
That's great. Thank you very much, Albert. And now we will move on to Tovio Roberts from Galvanizer. He is a data scientist instructor and will be talking about rethinking personas with LDA. Tovio's floor is yours.
Thanks so much, Mohammed. Give me a sec just to stage my screen. And there we go. Great. Thanks. And my name is Tovio Roberts. I'm a data science instructor at Galvanize. If you're watching this, you probably already heard or saw my bio. Just, quick cap. I have 15 plus years of software development experience, mostly as a contracted developer. And I did that because I was touring with bands and touring as a circus performer. I'm a professional juggler. And I transitioned out of that into special needs education for college students on the autism spectrum who were in STEM fields, mostly computer science and related fields. And I like to make art and music, and so I paint, and I also play around with generative models for music and art. And beyond that, I'm really fascinated by pedagogy and andragogy. So I spend a lot of time studying and thinking about better ways to teach and learn. So I work at Galvanize, and if you want to know more about them, Google us. And basically, we are a data science bootcamp. We have a data science bootcamp, and we also have a lot of other aspects of our company. So the crux of what I want to talk about is concerned with relational ethics, accuracy of perception, and some pitfalls of categorical and reductive thinking. I have two quotes here, and I want to use these quotes to frame everything I'm talking about. One is from Ababa Berhane. Relational ethics helps you leave whatever solution you have somewhat partially open so that you can reiterate, so that you can revise and change with whatever new evidence or new data comes up. Our solution now is only for now, within a limited context, within a limited environment. And I have a quote here from Dr. Robert Sapolsky, who's a professor of neurology and neurological sciences at Stanford. We take things that are continua and we break them into categories. When you're paying too much attention to categories, you can't differentiate two facts that fall within the same category. When you put up boundaries, you have trouble seeing how similar things are on either side of it. When you pay too much attention to boundaries, you don't see the big picture. All you see are categories. So what I'm talking about here will be partially about marketing and mostly about the efficacy and problems related to the use of personas within marketing. I'll be talking about an alternative to personas found in the continued simple utility of topic models like latent Dirichlet allocation. And at times I'm going to point out tendencies in business that reflect social systemic issues. I'm going to start with the story of a company. I went ahead and invented a company called Leash. I'm going to use Leash to contextualize how personas might be applied. Now, this is a totally made up scenario to serve as some archetype of a company that many of us have seen play out, okay? So Leash is a reasonably sized startup, or reasonably small, but reasonably sized, that specializes in providing crowdsourced dog walking, sort of like an Uber, but for booking a walk for your dog. We have this organizational structure. We have a CEO sitting in a relationship with marketing, human resources, a small legal team, and a sales team. We have a CTO who mostly works with the front and back end developers. Let's imagine there's somewhere around 150 people who work at Leash. Let's also consider that the data scientist might be contracted in, given that the revenue model is not necessarily centered around the value of the data. The value proposition of this company is really the service, which is pairing of gig economy dog walkers with the paying customers who want their dogs walked. And let's assume that there is a small design team and an analyst connected to the marketing team. Although the app designers and the marketing design team share aesthetics, they're mostly separated as they're working on different problems, but within the same brand. The app devs are concerned with delivery and functionality of the app, and marketing wants to acquire and sustain users. Let's say Leash is active in a few US metropolitan areas, including New York, Chicago, Denver, and let's just imagine a few others. The main idea here is the regions they serve are diverse in a number of ways. And let's say Leash gets the idea that they want to better know their customers. So this brings us to personas. Personas are a widely accepted method to approach building a customer-centered narrative by helping design teams empathize with users. More specifically, in this quote from Pruitt and Adlin, a persona represents an aggregate of target users who share common behavioral characteristics, in other words, a hypothetical archetype of real users. And the main pioneer of personas, Alan Cooper, states that real users are not elastic. Well, I don't think I agree with that, but let's go forward and talk about this a little bit more. So a key material aspect of the persona strategy is a persona description, which is a one-page sort of character sheet of a user. It's meant to give basis or descriptions of a made-up person's goals, motivations, and maybe their behaviors. There's often a stock photo, a name, age, story, and other things. These persona descriptions are intended to be resources for marketing, design, UX devs, sales teams, and they represent something like a quintessential customer. The hypothesis here is that if a designer considers a persona description as a real person with thoughts, feelings, a story, experiences, then the process of design will be a human-centered process. This is all part of human-centered design. Anyway, let's look at an example of a persona. That's actually, that's a joke. It's a character sheet from Dungeons & Dragons, but let's move on. Our company, Leash, decides that it's going to make 6 personas. 3 for the customers that are hiring dog walkers and 3 for the dog walkers themselves. They enlist the data analyst in marketing to perform a fairly extensive analysis of both of those user groups. Let's assume that the data includes people's addresses, as well as some volunteer demographic data, like age, gender. There's a discernible profile picture. There are extensive descriptions of the dogs. People love telling you about their dogs. The analyst pulls keywords from the descriptions, such as adopted from shelter, things like that. The data naturally contains number of walks requested by customers or performed by dog walkers. At the request of marketing and upper management, the analyst also scrapes people's social media for education and employment background. Addresses of customers are tied to median income and median house values of neighborhoods. And given the photos of customers, race is inferred in 3 categories: white, non-white, and black. So I think some of you might already be imagining some issues that might be emerging in our hypothetical persona process, but let's leave that for a little bit. The analyst finishes their analysis, hands off to the marketing director. All agents find the analysis to be validating, but not necessarily surprising. And to make the persona descriptions themselves, the analysis is handed off to a contracted individual who specializes in personas. That person mocks up 6 persona descriptions. Some poetic license is allowed in the design process, because that helps to create really relatable characters when you make personas. And I'm about to show you some mock-ups. I'm hoping that you'll be thinking about what might be sort of wrong with these and what might be wrong with this type of representation in general. So the personas are as follows. We have Karen Whitlock. She's 43. She's a woman. She's white. Her persona category is the Valkyrie, let's say. And this is common. People who design personas will name personas things like this oftentimes. She lives in the Wash Park neighborhood of Denver, makes about $200,000 a year. There's a goal here, that's expressed in a quote, like she's talking. The idea is you look at this and you imagine this person talking with you. And she primarily uses Leash because she has 2 dogs. One's older and one's younger, and the younger one's very excitable and needs to be walked more. And it looks like she hires Leash about 4 times a week. We also have things in here under the attributes, her attributes like wealthy. She's liberal. She's tech savvy. She's an extrovert. She's analytical more than creative. And she's active more than passive. And of course, she has these D&D specs that we can use to battle the personas against each other later if we want. Here's the bachelor, Ben Chaddington, lives in the uptown neighborhood of Chicago. He uses the app for walks about 2 times a week. Tends to be more conservative, an introvert, and more analytical. And his reason for using Leash is that he has strict work deadlines that prevent him from being able to walk his dog as often as he wants to. We have Alicia Montoya. She uses the app 5 times a week. She's in the first year of her master's degree, and she's also working, and she just can't make the time. She's more liberal, she's more creative, and And so those are the 3 personas for our customers. Let's get into the personas for the employees who are actually walking the dogs. We have Jared Whitby. He's 23, Caucasian, lives in the Lower Haight of San Francisco, and he's a dog walker, okay? So this is one of those things that happens in the creation of personas. We're really excited that this person's into our product. So he's a dog walker and makes around $23,000 a year. Leash gives Jared the freedom to pursue other activities. He even lets the more energetic dogs pull him on a skateboard with the owner's permission, of course. Okay. And more active, more liberal, and, et cetera, D&D. Okay. We have Syed Laskar, who lives in Los Angeles in the Panorama City neighborhood, makes around $42,000 a year, 18 Leash walks a week. He works at Leash because it gives him the opportunity to make a little extra money while he plans to open a business, which is described here. We have Desiree Fullerton, who is a woman. She's Black. She's got a kid. She lives in the Benteen Park neighborhood of Atlanta, Georgia. And in her story, it shows that she grew up there. And her reason here is she can make extra money for the household while caring for her son. Since she grew up and lives in the neighborhood, she personally knows many of the neighbors whose dogs that she walks. She's upper middle, like on the edge of being upper middle class, liberal, and more of an extrovert. Okay. So I'm going to point out some of the things that I see as wrong with these persona descriptions. The first thing is that personas are a reductive approach to understanding a population of people. In an effort to humanize design and development, there's been this invention of an imaginary cast of characters that fit with the predisposed worldview held by the individual creating the personas. So why is that a problem? For one thing, these stories, as humanizing as they are, they don't capture the wealth of stories that actually exist in the population. Imagine how difficult it is to write something like a median story. Any fabricated story here is a single individuated instance of an imaginary character. And I think that's a problem. Not a permanent, not a complete problem. There are ways to do this well, sure, but I think that's a problem. And I think it's dishonesty in this case through convenience and poetic license. And I think it's misleading within our hypothetical company. So I'm going to assume that the designer of these persona descriptions is white and that they're doing their best to enact diversity and inclusion. But there's still an experience of whiteness as being the common experience. The first persona is a white woman, the second a white man. The first dog walker is a white man. And this is reflective of what I've seen in personas in the real world. I'm not just making this up. These personas do not look unlike personas I've seen enacted at companies. And further, even if there is a reasonable amount of diversity in terms of employees working at Leash, the people who will be designing according to these persona descriptions will be asking themselves questions like, would Karen or Ben appreciate and respond to this ad campaign? Let's consider personas in another light as a segmentation strategy and consider this in terms of, say, real estate. Home buyers have different needs and different budgets, and channeling them toward specific facilitators of those needs at budget seems like a reasonable thing to do, right? Well, that really depends. If any of you are familiar with the history of redlining in the US, you might already be considering some potential deep issues with that kind of approach. If you aren't familiar with redlining, the short story is that federal agencies and real estate companies, they have a history of intentionally preventing people of color, and especially Black people, from moving into many neighborhoods in the US. So you can see that there is a conflation that occurs between economic class and race when segmentation occurs along income lines. Add to that discrimination based on race or ethnicity, and you can see how a persona segmentation approach in real estate, let's say specifically in real estate, can easily turn into a form of segregation. So we can expand this dilemma to, let's say, a school system that institutes a series of persona descriptions for students. And I think you can imagine why personas might have a strong potential to create institution around discriminatory practices. And the final thing I want to mention is there's a fundamental flaw from a business perspective in making this sort of normative assumption that underwrites personas. Few people actually resemble some archetype of normalcy, and people have a great variety of reasons to use a given product or service. Yes, we can often generalize, like a dog walker at Leash might want to work there because they get some extra exercise, or they want to make a little bit of extra money. And I think that's fair, intuitively fair, right? However, if we reduce to only a small handful of personas, then we potentially reduce ourselves to only a small set of customer motivations. And when we do that, I believe we narrow our view of the people who utilize our products, and we narrow our view of our own product's utility. Now, I could go further down this rabbit hole of everything that might be wrong with personas, but I'd rather propose a reasonably simple alternative approach. I want to suggest that topic modeling can give us better views into the stories and interests of people who use our products. Given that we have text data on our users, we can apply a topic model to discover hidden topical patterns, annotate the documents in the text corpus, and utilize the results. So the topic model that I'm going to focus on is latent Dirichlet allocation. It's well known, and it's been widely used since soon after its inception in 2003. So there's nothing revolutionary happening here. I'm not suggesting anything revolutionary, except can we maybe do this instead of personas in marketing? Can we build tools based on topic modeling? So I'm going to be somewhat surface level regarding the inner workings of LDA. If you want a deeper treatment, there are a number of links in the slide deck. There's a set of lectures linked here where it says topic models by David Bly. These are really great, and the math in them is really fun. And I also have a notebook here with a bunch of math. But the core premise here is that a document can be thought of as a probability distribution over some number of topics, and a topic can be considered as a probability distribution over a fixed vocabulary. So high-level view of LDA, it's a generative model in that it optimizes toward generating the words of a given document by way of that document's topic distribution. So if you think about it, that's a bit weird, right? Because when we write a document, we don't think in terms of, I want this to be 5% computer words, 10% phishing words, 35% horror movie related, and 50% words about cats. I mean, I want that document to exist, but I wouldn't know offhand how to write it. Essentially, LDA guesses at the document topic distributions, and it generates words for each document, compares the generated document to the specific document, and uses statistical inference to adjust the distributions of words within the given topics and adjust the topic distributions in each document. So why LDA? Although LDA is fairly old at this point, it's really easy. It's easy to implement. And more importantly, it's the interpretation of the results of LDA are really accessible or fairly accessible. Let me say fairly accessible. Also, there are quick and easy tools available to visualize LDA. There are actually more performant topic models out there that are pretty amazing. I link to a little Python library here called Tomotopy. I don't know how to pronounce that, but that said, I'm advocating here for LDA to be used specifically as an alternative strategy to personas because it's easy to use and describe. And some of these other models are more complex and they don't have necessarily as rich a set of tools for visualizing the results. I was actually hoping to throw together a caveat for this lecture, but I ran out of time. If I get that together in the next couple of weeks, I'll make sure to post it on my LinkedIn. So we have data. I made a quick toy data set for our hypothetical company, Leash, and I put that in a Google Colab, which I'll go ahead and share that link now in the chat. Okay. So I'll go ahead and open the Google Colab, and we'll take a look at this data. All right. So I'll go ahead and import a bunch of stuff, and there's a little installation that might have to happen here, but it'll be quick. And feel free to open this up and play around with it. If you haven't played around with LDA before, I think it's a great little model, and it's really fun, and it has a lot of depth to it actually. If you dig into it a little further, just because it's easy to implement and interpret, it's pretty hard to dig into. The literature on it is a bit terse, and but once you start getting it, you're like, oh, this is pretty cool. I'm going to import data from. I just have these little data sets up on GitHub, and the main thing we're going to be working with here is is this customer data that I made up. The profile descriptions are all just grabbed from the first few paragraphs of Wikipedia articles, and I kind of made these into classes where we have musicians, physicists, athletes, mathematicians, and actors. And the idea being that mathematicians and physicists are going to be tricky to discern, musicians and actors are going to be tricky to discern, and we'll see that. We're not going to use these dog descriptions, but there's a list of things to challenge you if you're so interested at the end of this notebook. So we'll just be using these profile descriptions. I also made a smaller data set with 50 rows. Sorry, this first data set, the customers, has 100 rows. And we have the dog walker data set that has 50 rows. And you can play around with that. Okay, so can see that there. Let's take a look at a couple of these descriptions. We have a professional footballer who plays for the France national team. And we have King Sunny Ade, who's a Nigerian juju singer. And so, if we run this again, we'll get other random articles. But these are going to be the things that we process to input to our LDA model. Okay, so now we'll prepare the text. LDA accepts a bag of words, and I broke out some steps here for the sake of learning, so that when you get to it, you can play around with it. And first we initialize a vectorizer, which will convert our rows of text into a sparse matrix of token counts. And it'll also drop common words in English, which we're calling stop words. And we initialize a lemmatizer down here that will reform variants of a word into a single form. And we then, we also end up tokenizing the documents. In other words, we represent each document as its own pouch of words within the greater corpus. And we'll take a look at that. We'll take a look at that right down here. So we'll look at a few documents and their actual tokens. Maybe I can make this a little bit bigger, a little nicer to look at. Bela Bartok, blah, blah, blah. And notice that this might be the original document, but our tokens have reduced this down to this collection of words. We don't include his name because it doesn't occur across enough documents, right? We don't include Franz Liszt for the same reason, although it would just be Franz and Liszt. So we also have this other one. We can see, well, this is Tom Morello, and it reduces down to this. So you can imagine there's a little bit of information loss that occurs when we do that. But in some ways, well, you can consider it to be maybe removing a little bit of noise from our data. So once we have those tokens, we can do a couple things. We can build a dictionary with the tokens, and then we can build this bag of words, which is named corpus here. So just pointing this out, there's around 6,000 words across all the documents and about 1,300 unique words. So let's take a look at that bag of words just to get a sense of what that is. We'll look at it in light of a token. So here we've got 28 tokens, 28 tokens and 27 entries in this bag of words in this term frequency. And notice that word ID 26 has two instances, which we can see here, degree and degree. So this is the form our data takes, and we're going to pass that into the LDA model down here. I'll start that running because it's going to take maybe 30, 40 seconds to run. So we pass in the bag of words named corpus, and I set our number of topics to 5. That's an arbitrary choice, okay? I chose 5. Because I have this assumption that maybe is unqualified, or we'll see, that there are 5 different classes of customer. And now that we have these topic outputs, right? Each of these is a topic. We can think about this. Okay, we can see that topic 0 has mathematician, year, university, mathematics, research, woman, degree, science. Maybe that topic has something to do with math. We want to be careful not to say it's a math topic, but it represents characteristics of documents or characteristics that are affiliated with our more mathematical classes, I'm assuming. And then we've got prize, physicist, physic, work, Nobel. Seems like that. Topic 1 has to do with physics. Film, actor, this probably has to do with actors. We've got player time record, professional team, probably sports. And then this one's a little weird. American-born known singer, musician, music, university, father. Okay, well, maybe that's musicians, but let's just take a look at this. So we can view the topic distributions for specific documents now that we have these. Also, the sum, this is very convenient in these topics. A topic is composed of all words in our vocabulary. And each of these is the probability of that word occurring. And that, I'm only showing here, I'm only showing 8 of the words affiliated with each topic, but we actually have 1,300 or so words affiliated with each topic. Each of those words has a probability of occurring in regard to that topic. So that's the way that you can interpret that. Okay, so I'm going to choose 2 random descriptions, and let's look at the topic distribution for those. So we've got Chauncey Billups, who played for the Detroit Pistons, amongst other teams. And it looks like his most prevalent topic is 3. So let's go ahead and reference 3 up here. Player, time, born, team, 1, professional, record, national. That makes sense, right? There's probably very little in here that's affiliated with the other classes that we use to generate our data. And then we've got this educator and mathematician, Etta Falconer. And if we look at her, she has topic 0, topic 2, and topic 4. So let's look at those. 0 is mathematicians. 2 looks like actors. And yeah, it's interesting, right? Actor, television award, maybe there's something in that document that's indicating that, but I doubt it. So, LDA here might be a little broken, or there might be something a little bit different about that document, okay? And 4, American-born, known singer, musician, university father. Okay, so I don't see anything in here except for possibly, it could be that we have a couple African musicians in our data set, and it might be using these words to identify the musician topic, for example. Note that we would do better if we had more documents here, and we would probably do better if our documents had more words in them. But this is purposeful to kind of observe a little bit of a failure in this approach. But I think it's informative of the utility of this model. So we can also view the topic distribution for a new or unseen document or a user. So I've got this physicist here, Jules Ahrens, and I just tokenize and create a bag of words out of this paragraph, do a little cleaning here, and I pass that in, and I get something, I won't call this a prediction necessarily, but I get something that is a statement of the topic distribution, okay? So we would expect topics 0 and 1, which are physics and math, to do relatively well, right? 37, 29. And then this topic 4 that's sort of mysterious that we don't really know how to describe yet is also showing up there. So I wanted to show you this tool, or I want to show you this tool, PyLDAViz, which I think is pretty amazing in a lot of ways. It's one of the reasons why I think that we can reframe the idea of personas. It's that we have intelligent ways of visualizing relevant words in relation to customers. So I think this is the most immediately beneficial thing to someone in marketing. What we're seeing here are topic bubbles, and these are projected into a 2-dimensional space. PCA for dimensional reduction, and then there's this intertopic distance that occurs through this multidimensional scaling. Oh, actually, no, that's right. And the distance is relative, and the x and y axis don't mean anything aside from creating a sense of the relative distance. So if I click on one of the topics, I see a list of words, and these are set in order of the topic frequency for the word frequency within that topic. We can see here that these words can possibly represent someone's interests, right? We see mathematician, year, university, mathematics, research, woman, degrees, science, study, etc. There's this nice tuner in here, the Lambda tuner, which has to do with a metric called relevance, which was proposed by the creators of this visualization, the creators of PyLDAViz. And it's pretty interesting. If lambda is closer to 1, it will essentially show the frequency count of the words for that topic, which is what we're seeing here. Now, if we set lambda close to 0, it will show more definitive terms for that topic. And if we do that, we start seeing degree, PhD, advanced geometry, supervision, bachelor, postdoctoral, etc. And if we look at different topics, we might start getting a sense like this obviously has to do with physics, right? Particle, quantum, scientific astronomer, etc. And this mysterious topic that we couldn't really place, the one that is so closely affiliated to math, it looks like, or something that looks a little bit more sciencey. We might actually just want 4 topics here. We might not want 5, given that these topics are so conflated in this instance. So there's a couple things that I'm putting here as challenges if anybody wants to do it. Try passing in a description of a political figure, right? We don't have that class in this presentation, so in this data. So we can pass that in, get a sense of the topic distribution in light of our fit LDA model. You can also perform LDA on customer descriptions with their dog descriptions, and you might see more emergent topics. Now, you don't want to equate class with topic. A topic can mean something that's hard to interpret, right? We have topics up here that aren't really about math. They're not really about physics. Well, one of them seems very much about physics, but there are a couple things getting mixed up there, and that doesn't mean it's wrong. It does mean that it's hard to interpret. And sometimes we want to maybe let go of hard to interpret topics, especially if we're thinking about this in light of discovering behaviors in customers. Also, perform LDA on just the dog descriptions. I think that'll be fun. And maybe we'll see how many different ideas that how many different topics there are around these dogs. Okay, so let's continue from there. There's a sore spot with topic modeling in regards to validating the model. And I think I just alluded to this. How do you know it's doing a good job? Well, a general approach is to put your eyes on it. There are validation metrics available for LDA. There are. But there's yet to be one metric to rule them all. And there's still this primary issue of deciding how many topics on which to train your model, okay? That's a much bigger discussion. But I kind of want to wrap up with some thoughts in regards to personas and alternative strategies for to personas. So I talked a lot about a lot of things that were faulty with the persona strategy. It's reductive and easily prone to cultural bias, which can have a number of consequences in terms of not recognizing the potential of a product or the use cases by a user, and also in terms of potential discrimination. I didn't say this before, but I do believe personas can be done well and in a way that's equitable. I also think it's rare, and I think we should consider other strategies first. Whatever the strategy, I think we should center the wealth of human experience and interests instead of centering contrived archetypes. My implication here is that we can consider topics as human interests, which can be updated, and they're flexible. These interests aren't affixed to a specific persona. Maybe a user can be thought of in terms of being a distribution of interests and experiences, which are also distributed across society. I think topic modeling has the potential to capture at least a little bit of that for the benefit of those providing services, as well as for those utilizing services. Thanks so much.
Thank you. I think you have 5 minutes to tell us about your story with Python, with ML.
Yeah, sure. So my story with Python. I started learning Python, I think, because I was doing Java and I was doing PHP, and there were things in those languages that I would look at Python longingly. And at that time, I was also working with students, college students on the autism spectrum. And so I would design curriculum for them. And in the design of that curriculum, I would just do Python honestly, because I was like, this is going to be the best ramp for almost anybody, especially somebody who's different cognitively. But yeah, I think I started programming right around 12 or 11, and first language was C, and got into C++ for a little bit, but then focused almost solely on PHP for a long time, and and Java. In school, I did Java, and then I did Python in school also. But yeah, my background is language studies, and I have a degree in machine learning, and those things kind of converged into working at Galvanize. I went through the actual boot camp, the data science boot camp that Galvanize has, and after that, I started doing kind of part-time presentations and things for them, and while still doing a lot of contract work on the side, and then that's kind of evolved into being a Python and stats instructor. So that's kind of the story in my tech space, if that makes sense.
Yeah, thank you. Thank you very much, Tovio. And now we will move on to Samaya Madhavan from IBM. She is an advisory software engineer and will be talking about an introduction to deep learning inspired by the human brain. Samaya, floor is yours.
All right, I hope you guys can hear me, and I'm going to start sharing my screen. All right, can you hear me?
Yes, we hear you. Yeah.
Okay, awesome. Okay. Hi, everybody. I'm Samaya Madhavan, and I'm a software engineer with IBM. I'm also a developer advocate, where my day job involves developing and publishing content around machine learning and deep learning. I am here today to be presenting about the fundamentals of deep learning and how artificial neural networks actually links with deep learning, and and also the talk is going to be around how artificial neural network is inspired by the human brain. To have a few disclaimers in this talk, I'm only going to give you a very high-level understanding of what deep learning is and artificial neural network is. So at the end of the talk, you'll be getting an end-to-end understanding of how an ANN is or an artificial neural network is developed, and also the key terminologies behind it. I will walk you also through a Python code on how the code is being developed. And hopefully just spark some interest in you all, so you can go in and learn much deeper about it. And also, I'm not going to be talking too much of math in this session, because one thing I've learned is when I start talking too much of math, people just start getting distracted and lose interest. But at the same time, I'll be talking a little bit of the formulas that come into play, but also at the same time I'll abstract the formulas. That way, you don't have to entirely understand the formula, even if you don't. So, okay, I think I need to start sharing again. Just give me 1 second. Share screen. Okay, so hopefully you guys have my screen again. So other thing that I do want to say is that I do not have a background on neurology. So everything that I'm going to be talking in this session is going to be very high level understanding of what a human brain works. And that's the extent of what you need to know to understand the session. So with that said, let me walk you guys through the agenda. I'll begin by introducing about deep learning and where this space fits within like, the realm of AI and data science and everything. And then I'll move on to discuss about why deep learning is popular today, more than before. And after we discuss about those points, I'll show an example. I'll show you the correlation between a neural network and the human brain. And as an example, I'll show you an example how a child learns its fundamentals and relate that to how a neural network can be trained. So I like to get the fundamentals out. So I do get a lot of questions around, if deep learning is a competitive technology to machine learning, if, deep learning has come into place to replace, machine learning, which is not true. Deep learning is a subset of machine learning, and I'll be discussing about why deep learning is being gaining immense popularity in the slide to come. But also there are use cases where you can still practice machine learning, and your model efficiencies are even defeating the metrics that a deep learning model can perform. So it's still deep learning is an additional option to the other algorithms that machine learning has to offer for us today. So we'll move on to discuss about why deep learning is popular today. Just give me 1 second. Yeah, we'll discuss about why deep learning is popular today. So the first reason being there is enormous of data today, more than before. So just when you wake up from your bed and you scroll your phone and you click on Amazon, and then you click on what products you like, you check WhatsApp, or every day-to-day activity of ours is producing more data that an organization can learn information from you. So and deep learning algorithms are data thirsty, so they need humongous data to unveil hidden patterns which was previously not available. The second reason why deep learning is popular today is the availability of the compute capabilities. So a typical deep learning model, if it were trained on just a CPU, would take days or weeks, versus today we have GPUs available to us so very easily, and with a GPU you can just train these models within minutes. So that's the range of enhancement that you get with using a GPU over a CPU, and these are very prevalent these days. But also, most importantly, there's a lot of algorithms that are within the realm of deep learning that are being built today. So that actually helps us, gives us a lot of option, and model performances defeat each other with the advent of each of these algorithms. So with that, I want to introduce to you the most fundamental architecture of deep learning, which is artificial neural network. And you'll see how in this picture over here, I just wanted to compare and correlate how in the bottom we have an artificial neural network, and in the top we have a snippet of our brain cell, which is a neuron. So to highlight some of the correlation is neurons are highly connected, and so are our neurons in our neural network. And then just like how our brains communicate these chemical signals through synapses, the neurons within a neural network also communicate with data, right? So these are some of the observations. Just wanted to throw a first look of what an artificial neural network looks like. So I don't intend for you guys to grasp a lot from this image, but we will be digging deeper into the functionality of an ANN in our future slides. So on to our next part. So right now I want to talk about think about how a child learns. So let's assume this is a child, and the child is learning some of the objects that it's presented to it. So for example, it learns about an apple. So it in the past it's probably held an apple, or it's seen images of apples in a chart or on the TV, and then it probably took a bite of an apple to know what the texture looks like, or like, what it tastes like or smells like. So it's got, various features through which it can understand what an apple looks like. And so suddenly one day we come and we present an apple to this child and like ask him, or her, like, do you recognize what this object is? So maybe it does some thinking, and then it probably says, I think it's a tomato. So what happens is it sees the apple, it does some processing in its mind, and then it makes a guess and it says, I think it's a tomato. So this person or the caretaker that asks this question comes back with a feedback. It does some, she or he does some error analysis and comes with the feedback and says, I probably understand why you thought it's a tomato, maybe because it's red and maybe because it's round. And good job that you think they're similar, but you're not quite there. So they calculate the error and they give them the feedback. So this child now takes this feedback and then goes back and thinks about it, and everything happens within the brain. And then goes back and takes a look at this apple probably and thinks, okay, so this is probably the difference. So it processes all that in its brain. And then again, it comes back and thinks about it, and then it probably guesses it right. So it comes back and says it's an apple, right? And this time, the person that asked this question comes and gives the child good feedback. Probably clap your hand and say, great job. So now this again is like taken back into the brain, and the child now processes it and it reinforces its thought. So do want you guys to observe that there was something first in the forward direction that went in wrong, and then took the feedback, came back, fixed it, and then took another pass and made the right guess, right? And in the next slide, I'm going to present to you a first look of how the neural network actually processes data. And I understand that this looks very overwhelming at this point, and really the only takeaway that you should be taking is that there is a forward pass, data is being processed, and there's like input over here, and there's like that it's trying to make predictions of what the output should look like, and then it's processed that output, and then it now sends some feedback, and then that's being fixed, right? So let's dig deeper into what happens within this neural network. So two steps, as we saw, is the forward pass and the backward pass. But before I get to that, let me explain to you what a shallow neural network is. So a neural network, like we saw, consists of three layers, which is the input layer, which is where your inputs are passed into the artificial neural network. And then the output layer, and in between is what you have, a hidden layer. If you just have one hidden layer, it's called a shallow neural network, and if you have multiple hidden layers, it's called a deep neural network. So that's for the basics of how you define a neural network. And in this forward pass, let's see how what happens within. To begin with, I just put this image back as a reference. So I'm going to tell you what happens within each of these individual neurons over here. So within every neuron, two things happen. First is how you calculate the weighted sum. So let's assume, if you want to go back to your predicting if it's an apple or a tomato, situation, let's assume we have three columns, right? And then we have the output column, which would predict if it's a tomato or an apple. And then the three columns, we can call it like color and, the shape, and then the texture, right? So we take one row at a time, and then the first row is now being passed in as input, which is x1, x2, and x3. So that's being sent over here. And you assign to these, inputs what's called weights. So let's assume that this particular neuron is thinking that I think the feature for color should carry more weight in me trying to predict if it's an apple or a tomato. So let's say it gives 0.8 as the weight, and then the other two is given like 0.1 as the weight. So in this example, this particular neuron considers that 0.8 has more. Color has more importance than the shape or the texture in trying to predict the fruit. So we calculate the weighted sum, which is the summation of the weights and the inputs multiplied, and then we add a term that's called the bias, right? And to this output, we apply what's called an activation function. So remember how I said these steps happen within each of these neurons? Let's assume that this particular activation function comes with outputs which are like, of the values 10,000 something, right? And then the next neuron comes with a value that's like 0.5. And for the next layer to, make sense of what comes out of this activation function, you see that these scales are very vastly different. Which is why you apply an activation function which would bring the outputs of the previous layer into the same scale. So, for example, the sigmoid function converts any value that you pass into it within a range of 0 and 1. So that's what you potentially do over here. So this computation happens for all neurons in the neural network, including the output layer. So eventually it's going to come up and guess and say, I think it's 0.1% probability that this is a tomato, and it's a 0.9% probability that it's an apple, right? For example. And also, what happened, like, for the sake of understanding, I'm telling you guys, how these neurons actually function, but really the insides of the values inside each of these neurons are not perceivable. So, so the next step is the backward propagation, similar to how we saw that, the child predicted a value that was wrong, and an error was analyzed, and then the feedback was sent back, and another set of processing happens in the brain, right? So let's assume that the inputs were processed, and then it came back and it said it's 0.9% a tomato. So the output of this one would be a tomato, but while in fact the input was probably a pineapple, right? So in this case, the actual value is a pineapple, but the prediction was a tomato is too far away. It's not very relevant. So what's going to happen is we're going to come with identify the loss, and we're going to say the loss value is too high between the actual and the real value. So something needs to be fixed, and what will be fixed over here are the weights. So it's going to at each level it's going to change the weights back, and to calculate these weights is what we use a gradient descent. So think of gradient descent as a marble that's put inside a funnel, and then you want to swirl it, and you want to and that there are several lower points. So you want this marble to get to the lowest point, which is the point of least loss, right? So at that point, your value is very close to the expected value. So you go back to the weights. So remember how the initial neuron assumed that the color was the most important aspect. So maybe it's going to go and fix that and say, I don't think the weights for the color should matter a lot in me trying to predict what type of fruit it is. So it's going to come back and adjust the weight and for this and say, I'm just going to give it 0.3 instead of 0.8 that I did previously. And this is going to happen in a cycle, right? So there's going to be a forward propagation where each of the neurons are going to try and predict the final output. And at the output cell, there's a loss, which is being calculated. And the feedback is sent, and it's sent back, and we apply gradient descent, and which is where, a lot of these calculus related mathematics come into place, where you calculate the derivative, and then you find out how much my weight needs to be adjusted to make the loss eventually smaller. So it happens in a cycle. So the backward propagation happens, and then you again the neural network again starts guessing the output. So it's a repetitive process. So there are more concepts and more like I said in the beginning, this is just a high level end-to-end understanding. There's something called learning rate, which will determine how much of the weight you want to change, based on when you've gotten the derivative of the weights, right? So there are a lot of pros and cons in using each of these values, and challenges. This session was intended to be covering the basics of it. So that said, I'm going to show you guys the basics of I'm sorry, I'm going to walk you guys through an example in Python that will tell us how to, that will actually give us an example of the neural network from start to end. And let me share my screen over here. In here, I'm using IBM's cloud environment. It's called Cloud Pak for Data, wherein I've imported a notebook that'll show you an example of how a neural network can be built from start to end. So there are several frameworks that help you in building a deep learning model. TensorFlow, which is right now integrated with Keras, is one of the popular framework that's out there. It's also in Python, and there's also PyTorch, which is super famous. But for this code walkthrough for us, I decided we'll do the NumPy way, because what happens with these famous libraries is a lot of these internals are abstracted, and so this whole process of understanding is masked for us, and the entire it's just going to be one line of code to implement what's in there. But I'd really, for beginners, encourage you all to just go to the basics and learn from there. So in here, let me start with saying that X is an input array that's going to be used for training per se. So we have 4 entries with 3 features each. And then Y is the output array, which is the actual value. And these are 2 helper functions. The sigmoid function, like I told you, helps you mask the outcomes of each neurons to between a value of 0 and 1. And the sigmoid derivative will be used in the backward pass to calculate how much these weights needs to be adjusted. That said, this is a definition of a neural network. We begin by initializing, so this is assuming that we have 2 layers. So we have weights 1 and weights 2. The input, which is X, and Y is the output. And the output over here is the output that the neural network is going to predict, right? So Y is the actual output, and output is the predicted output. So the shapes and sizes of these are initialized. So we begin by initializing it to a random number. If you remember how I said, I'm going to initialize the first weight to 0.8. So you could initialize it to a number of your choice, or you could randomize it, or you could set it to all zeros. But you'll see that if you actually chart out these weights, the model is learning and adjusting these weights to make the model perform well. So the first step is the feed forward, wherein the dot product, which is the the weighted sum, and then you apply the sigmoid, which is the activation function. You do that for the first layer, and then you instead of the input, you pass the output of the first layer for the second layer, and then that's your feed forward, and then your feedback, or back propagation. This formula is over here is a little involved. So it's basically expanding on the formula that I showed you guys on the presentation. So it uses this sigmoid derivative helper function that I showed you, and then you adjust the weights. And training is nothing but doing this, in a loop. So you first take the feedback, you just feed forward, you make the output, which is the predicted value, and then you apply back propagation to it. And then here's where the action happens. You just initialize this neural network, and then you do it about 1,000 to 1,500 times. to see if your error values, you want the error to be like close to zero. Zero value of error means that your model is predicting values the right way. But there are also, like, if your model has an error of zero, there's potentially a chance of overfitting. So there's like logistics like those involved. So in here, so every 100th iteration, you're going to print out what the value, what the input value is, what the actual output is, and what the predicted output is with the loss. And then we kick the training, which is going to happen for 1,500 times. So I'm going to let this run and show you guys what it looks like. So the first iteration, the actual output is, for this input, the output is 0, 1, 1, 0. But the predicted output is all a little over 6, which doesn't make a lot of sense, but the loss value is also relatively higher. And then if you keep, analyzing each of these iteration, you'll see that the loss value is reducing and the values are getting closer to the actual output. And so each of these runs will keep working towards attaining the global minimum, which is a terminology involved in calculating your back propagation. So at the end of 1,500 runs, you'll see that the final values are very close to the actual input. So in here it gets to 0, close to 1, close to 1, close to 0, and your loss is also at its lowest point. So that was everything I had in terms of my slides and my walkthrough. So hopefully you guys enjoyed this. Please do give me feedback, and I'm open to taking questions.
Thank you. I think we still have around 15 minutes. We can listen more about your story with IPM and how you starting Python.
Oh, yeah, sure. So I think I have a typical software developer turned into data scientist story. I started my career as a full stack software engineer within the Java realm. I used to work for an insurance company that did that, and then I shifted over to IBM, working with Watson Health for like close to 6 years before I shifted to this position. Where I'm a developer advocate. So I keep working on projects related to data science, present them to clients, try to sometimes convince them to use IBM products, sometimes not. We are big time into open source as well. So I really, thoroughly enjoy what I'm doing. The role is about, being out there, talking to people, giving presentations, all fits into my interest. But I think the biggest moot point is that there's no stopping to learning. I'm just constantly, learning and also relearning what I learned before. Coursera is my friend. I'm always on there trying to learn new courses and trying to find new ways of, understanding and making content that I keep constantly publishing out there. So yeah, that's pretty much me, Mohammed.
Okay, thank you.
Sure.
Thank you very much, Samaya. And now we will move on to Aaron Roy from Shala. He is a data scientist intern and was talking about the microservice of data science. Okay.
Hello, everyone. Thanks for joining my session on microservices and Docker for data science. I am Aaron Roy from India. Today, we will be discussing about how microservices and Docker are used in data science and what actually is microservice and Docker, right? Because before diving into the utilization of microservices and Docker for data science, we need to understand what these microservices and Docker means, right? So that everyone is on the same page and everyone can then understand what things are and how these things go ahead. So we would be discussing certain points which I have mentioned in this slide. So you can see that I have divided the entire session into 6 parts, starting with what is microservices, Then we will go towards understanding what is Docker. Then we will understand the key components of a data science process. And like, because this would be the flow. First, we will be understanding microservices separately, then Docker separately, and then just a high level overview about how the data science process looks like, what are the key components there, so that we can map those components, so that we can understand where microservices and Docker fits in. Because once we know the process, we would be at a better position to understand where these components fit in and how can these be useful for us. Then we will take an example like how we can use microservices for data science, and then we will be we will be moving towards the end of the session where we will discuss about using Docker for data science, like how you can also use Docker for data science and how these stuffs go. So starting with what is microservices, like from the word itself, you can understand that it's a combination of two words, micro and services. But what these services are, and like we can understand that micro is small, but what these services mean and what these services are all about, so that we can combine those two terms and can come to the conclusion that what we are actually talking about. So like when software industry started, we used to have a certain terminology called monolithic architecture or monolith. So you can see in this diagram that monolith is kind of a huge box, like a single huge box. And otherwise, like what we are discussing here is microservices. And here you can see that there are certain small components, like you can see different colored boxes here in place of a single box. And this is the shift from monolithic architecture to microservices architecture in today's world. But what these microservices are and how these things help, from the picture itself, we can tell that if anything goes wrong in any component of that huge box, we have to focus on how things are related, and it would decrease the performance of the entire box as a whole in monolithic, right? Because here all things are very tightly coupled and everything is into single box, and if anything goes wrong, you have to shut down the entire box to rectify the mistakes that you have did. But in microservices, let's say something goes wrong in certain components, but that component is into different singular box, so the entire operation would not go down. Only those components or only those things which are there in that single box needs to be rectified, while other functions are already running. So it's one of the major advantages that the entire operation doesn't goes down if anything goes wrong in microservices as compared to monolithic. So here you see a like kind of diagram so that you understand. In monolithic architecture, you see that user interface, business logic, data access layer, it's all coupled together. Like it's everything is in the single like I can say that single circle kind of stuff. And if anything goes wrong, the entire circle has to stop, the entire operation has to stop. But on the other side, if you see the microservice architecture, you will see that the user interface again is again distributed to certain other microservices, and each microservice is connected to database and something like that. So when we are talking about microservice, like might be like we will understand microservices better as we go ahead. But as of now, we need to understand that microservices is small components that are distributed, right? So that if anything goes wrong in microservice 1, the other microservices would not be affected, and that would not affect the business operations. But that's not the case in monolithic. Monolithic is kind of a huge singular box or singular circle. And like this is the definition that we usually read or usually see in the industry. So here you like one of the most important definition, it's like microservice architecture is an architectural style that structures an application as a collection of services. So like you can see here, like there are multiple microservices, like you can see that the variety of gears that you have, like there are multiple microservices that when come together brings the entire solution as a whole, right? But that's not the case in monolithic. So that's why we tell that microservices is a kind of architectural style that structures an application as a collection of services. And when it's a collection of services, it definitely becomes more maintainable, right? Because if anything goes wrong or if anything is not working or we're testing a certain component, the other components have to not wait until and unless the entire application starts running. So might be it becomes more easier for us to test, more easier for us to maintain certain components without affecting other components while the things are getting repaired or while the things are getting rectified in the backend. And these are loosely coupled. One service doesn't affect other services, and it's independently deployable. So let's say there are multiple services. One service is responsible for one task, another microservice is responsible for another task. So these are all independently deployable. Maybe you can deploy the microservice that's responsible for certain components. You can deploy those things and organized around business capabilities. So like might be with time your business operations might change, or you have to scale up and down. So microservice definitely comes very handy. And the biggest part is microservices, because these are a component of several services that builds a simple or the structured application. It's like owned by multiple small teams. Like a team of 3 or 4 is responsible for a certain service. A team of another 3-4 folks from the engineering team or another team might be responsible for another services. So it's like owned by small team, and like the responsibility is quite high on that specific team, and they take care about those things. And the risk of failure is kind of low here, because like everyone is getting specific responsibilities to do. And this microservice architecture has been in quite high prevalence in the industry as of now. This is just an example when we talk about microservice. So this is a e-commerce platform. You will see that our main focus should be on the right hand side. Like you see inventory microservice, accounting microservice, shipping microservice, store microservice. So what these things are, like in an e-commerce platform, you have all these functionalities like inventory, accounting, then shipping, then store management, right? But if these things would have been into a singular box, and if anything would have gone wrong, let's say inventory microservice, like inventory component might have gone down, so the entire e-commerce website would have gone down then, right? But in case of microservice, it's like while these things are getting rectified, maybe the users coming on the e-commerce platform can be shifted to other platforms or other services while the things is getting rectified there. So it becomes very much easier, and the downtime also decreases, right? And there are high chances that the user experience would not get hampered while the rectification or while the services are being rectified, right? So that's one of the major advantage that microservice provides to us as an industry, or as a software paradigm, as I can say. And then now we understand what is microservices. Now, like as we discussed in the agenda, so we will start firstly with what's microservice independently. Like now we have understood what microservices are. Now we are at a better position to understand what is Docker. So like Docker, you might have heard about this terminology a lot these days, because like a lot of companies are like utilizing the power of Docker, or multiple of the companies are using Docker in the production environment and stuff. So you might have heard that. And it's like why it's in so much prevalence and what it is all about, we will start. So Docker is an open source project for the automation of deployment of applications. So like we earlier, it used to be like if we have to deploy certain applications, we have like the entire teams would have to spend a huge amount of time into deploying of applications, and they have to take care about hell lot of stuffs, like lot of processes that would go into deploying and stuff. So Docker is an open source project that helps in automating those deployments of applications. And these deployments are made automated with the help of a portable self-sufficient containers. So like containers, when like we can just relate to the containers that you saw in an image in the microservices, in the microservice architecture. You saw that there are multiple small boxes. We can tell them as small containers. And while those microservices, or while those components are there in those containers, and we can deploy them, like we can use them directly. And what is there in that containers, it's like a full-fledged pipeline of how to deploy and what are the things that we need to take care about. So all those things goes into that. So it and because it's a container, it's packed into one, it's highly portable and it's highly sufficient. Like it can be run anywhere, provided that the environment is good, and provided that the required setup is there. So Docker helps us in automating those applications deployment, right? And why we need this so much is because the industry is changing super fast, and we have to deploy let's say a version of an application every week or every 15 days on stuff. So maybe certain organizations deploy daily, like multiple times. So like Docker comes as a rescue to them because it's portable and you do not have to take care about all those deployment pipelines each time you deploy, right? You just automate those things. You just set all those pipelines into one container, pack them, and it's now a portable, self-sufficient container which you can utilize anywhere you go, and on premise or on cloud. So that is one of the biggest advantage. But it's like automating the deployment of applications with the entire ecosystem that it would want to run. But how it's different from virtual machines? So you may also tell that virtual machines also help us in deploy, like virtual machines may also give us the environment that we would require to run certain deployment or to deploy certain applications. So Docker gives us gives us an advantage that in virtual machine you have to you again install a guest OS on the top of host OS, and like hell lot of things you do, right? And like might be the memory sharing is not that great, or sometimes the deployment process doesn't goes well so much. But Docker helps us in like you can have multiple applications running there, though the same thing can be running in virtual machine too. But you can see that in Docker it's like every application doesn't require to have a OS of its own, right? Like you can see that, and that's taken care by the Docker engine. So it's like a hell lot of stuff that goes into the Docker thing, and it's like a kind of super flexible kind of stuff that have been utilized in the industry. So you don't require to understand much of how these things work and like how to set up these things. Like Docker, once you utilize the concept, once you see how these things work, it would be really great for you to go ahead and to see. But as of now, Docker is like just a kind of easy and portable system for you. I hope that that gives us more advantage on top of virtual machines, and where you have to install guest OS on top of the host OS and stuff. Like it's kind of a resource intensive, and the resource sharing is not that great. But Docker gives us that advantage that you do not have to install again OS on top of that. So it's kind of a good ecosystem. And one of like a few major differences between them is like each virtual machine runs its own OS, right? Like you can see that every time you make a VM, so you have to run its own OS. But Docker, it's like all containers share the same kernel of the host. So like you can see in the image that like host OS is the common one, and every Docker system that you see, they utilize the kernel of the same host, so that goes very very easy, and it can be instantiated within seconds. So like instantiating Docker is super quick in terms of virtual machines, which takes a lot, like I would not say huge amount of time, but definitely takes up a few minutes to pick up. And is like you cannot run more than a couple of virtual machines on an average laptop, right? Because there is a certain amount of limit. Otherwise, though I would not say limit, but it's kind of when we cross that, the performance of the things decreases. But Docker is, on the other hand, it's like super flexible, and you can run as many Docker containers you would want. And like you can have multiple Docker containers can be started from one Docker image. So what we talk about these Docker image, Docker containers, though you can read about those things later, but I have tried to include them in the slides. Like I hope that this will give you an advantage. So like Docker file, you build that Docker file, and then you have a Docker image. Once you build the Docker file, you get a Docker image, which then you run, which helps you to make a Docker container, which can be utilized or which can be put up anywhere that you want. So like just an example, so like users make a request and response. So first of all, you have an Nginx container, then you have a WordPress container, then you have a MariaDB or a MySQL container. So this is like every component is separate, but they communicate with each other, and that's the power of Docker. So like you make every service as a like separate one, and they are communicating with each other, and anytime if anything goes wrong, the other things would not suffer completely. They can continue their operations in case they are not very tightly coupled with the other containers. So like we have to take care about those things. So just a heads up, like a Docker file is a text file written that includes the instruction to build a Docker image. We saw that in this image, like we have to build a Docker image, like we have to build a Docker file to make a Docker image. So a Docker file is mainly a text file written that includes the instructions to build a Docker image. That contains the languages, environment variables, file locations, network ports, and other things. So once you build the Docker file, you get a Docker image. So a Docker image is kind of a portable file containing the specifications for which software components the container will run and how. So it's kind of a portable file that contains the specifications mainly, like what would be the components that would be required to run and how. So once you have that, so now you run that, right? So Docker run utility is the command that actually launches a container. So like, because you make a container, or while we were talking about container, so these are small components as a whole. So these so Docker run utility is the command that actually launches a container, and you can utilize this container like multiple times if you want. And then you have Docker hub. It's a kind of a GitHub kind of stuff for Docker containers. Then you have Docker daemon, and like these are a few terminologies that you can refer to. A few Docker use cases, like maybe rapid deployment, app isolation, multi-tenancy, server consolidation, etc. But now we just get a high level overview about like the process of data science. So like, first of all, we obtain the data, then we scrub or we clean the data, that we call data pre-processing kind of stuff, data cleaning. And then once we do that, we then go towards exploration. What's the data, like how are there any patterns in that? And we use certain statistical methods to find the patterns. Then we make a model to predict and forecast, and then we put the results into good use, like maybe for customer use or stuff. So this is a high level overview about how a data science process looks like. And as we know that microservices and Docker, we understood, right? Microservices are kind of a small components that build up a like entire application, and Docker is kind of the containers that we talk about, right? Like multiple containers can be used, and then Docker and microservices are coupled with each other. Like these terminologies or these domains are coupled with each other. So like you make Docker containers, which then go ahead to make certain microservices which runs the application. So we now understand what microservices are, what Docker are, and now we also have a good idea about how the data science process looks like. But where does these microservices and Docker fits in? So you like this is again an image of how a microservice looks like microservice architecture looks like. So it's like, you can see that microservice web app, then you have an API gateway, which takes care about how the communication would be happening within the microservices. Then we discussed in the e-commerce platform, right? You have a accounting accounting microservice, inventory microservice, and then shipping microservice, all those stuff. So similarly here, microservices, like these are, you can see the boxes, and in boxes you have the Docker. So that's the kind of image that we usually use for Docker. So you can see that a fish-like structure. So that's a Docker. So like Docker containers combined together to come across making a microservice, and which can be used for a microservice architecture that we can focus upon. So this is how mainly like a data science utilization of Docker and microservice would look like. So you can see that an app developer makes an Android application, let's say. So he or she makes in IDE, then you have GitHub repos for that. Then he or she makes a Azure pipelines. And Azure pipelines is like here it's where the magic of machine learning and data science comes into picture. So similarly, you can see a data scientist utilizes a Jupyter notebook to make certain models or to make certain data science things, and then he or she makes puts those things into a blob or Azure machine learning service. And the Azure pipelines have a certain pipeline where you can fetch the latest model, and it's now a container, right? And you can build that container, you can utilize that container to do certain predictions, to do certain data science and machine learning things. So Azure container service, then you can deploy that, and let's say it's a kind of cat detection algorithm or a cat detection machine learning thing. So you can see that how a mobile application built by Android developer fetches latest models, and it's super easy. Like a data scientist can do certain changes, can do certain events, can do certain changes in the machine learning model, and there is a pipeline that helps us to fetch the latest model and to help us predict. So using microservices for data science, I will just give you an example. So like this is a very high level overview about how this is mainly for optical character recognition. So you can see that there are document servers. So document server is where you upload all your documents that goes into like a certain engine or a certain microservice where we see, or where the OCR things mainly runs, like analytical engine. Then we have decision execution and stuff. Like it's a high level overview about how microservices and Docker goes hand in hand in a data science ecosystem. But like each transaction arrives in a receiver service, like, right? So you can see that each transaction goes into a receiver service, and things go from there, right? Like we upload a document. Let's say we just want to do OCR, so we upload a document. So every transaction that we do, right, we want to or we want to recognize the text in that document. So we send that document into this receiver service. So receiver service, like we tell that as a transaction. So that's a receiver service. Then you have attachment processor service. Like, so you can check for an attachment. So like once there is an attachment, it sends to the OCR to check for the optical character recognition and to give back the responses. Then you have a context creator, which analyzes it, then associates it with any past transactions. And then you have a decision execution, right? Like this, which decides what thing to go as an output. So this is an example of how like Docker and microservices are used in data science. So maybe you can go to this website and can see how microservices and Docker are used for fraud detection. And using Docker for data science, I would say that data science is more into like mathematical and statistical knowledge with domain expertise, then how to combine this with Docker. So like with the help of Docker, definitely you can create ultra portable custom development workflows, right? And can use testing, staging, and production environment ecosystems in the Docker. And you can reproduce any Jupyter notebook, like you reproduce your Jupyter notebooks. Let's say like your Jupyter notebook uses certain version of Pandas, certain versions of NumPy. So you do not have to install everything, or you do not have to specify everything in hand. You just share the Docker container with the person with whom you want to share, and then he can directly run that Docker container, and he or she will get the entire setup that you have planned for yourself. So like it's a self-contained, like I will just give you a small example how a Docker container, or how you can also make a Docker file. So you can see that it's very easy. First of all, from Python, because we will be using Python, and then you can use a label. So who maintains this, maybe you can add it. Then you can add the working directory where this Docker container would run, and you can copy all the content. You can copy all the contents of the application file, because while you are putting certain workflows, or you are putting certain files for deployment, you would have files, right? So you want to copy all those files into the machine of others with whom you shared your Docker containers, right? So this component would do all the copying and pasting stuffs, and then it will run which libraries to install, like let's NumPy, Pandas, Cbond, scikit-learn. So you can all do all those things, and you can also mention the ports where this thing would work. So it's 888, so you can install any other things. And then whenever the like app.py container launches, so these things would be happening. So like these are the commands: Jupyter notebook IP, it would be running on port this, browser, and allow root, it would be giving root access. So this is how a Docker file looks like for data science. Maybe you can also play with these things. So data stored on local machine. So like there are multiple use cases that can go ahead, like similar from Python. Then you have a label, then you have work directory where the things would go and copy. And like then you can have a run command that which things to install. Maybe you can also make a requirements.txt file which includes the version of the libraries that we would be using, and you can install the entire list of the files or list of libraries mentioned in that requirements file in one go. Then which port to expose, 8050, then volume from where the data would be, and entry point, and then what would be the command we have to plot underscore time series.py. So this would be an entire workflow. So you do not have to tell someone that these are the things that you need to do, these are the things you need to install. Once he or she runs that Docker file, he or she will definitely get these things automatically there in his or her machine, and they would be good to go. So it's really easy to deploy, it's really easy to share your work. These are a few useful resources which you may use at a later point for focusing, and these are good systems. So like this was a high level overview about how data science uses microservices and Docker. I hope that this presentation would give you a kickstart to to launch your journey in this microservice and Docker for data science, because data science industry is definitely increasing day by day, but similarly the rise of deploying applications on Go. So it's very important that you go for it and try exploring microservices and Docker for data science. So yeah, if you have any questions, maybe you can put it down. I will be answering them at a later point of time, and you can definitely get in touch with me over my email ionwright2000@pm.me, or you can connect with me on my LinkedIn and GitHub. So yeah, good luck and thank you for being a patient listener. I hope that you love the talk, and if you have any feedback, do share it with me. Thank you. Stay safe. Bye.
Perfect presentation. Okay, our dear attendees, thank you for commenting in YouTube and Pine that you like the talks. We really appreciate that, because all our speakers and team worked really hard to make this event happen. We have a giveaway for our event among those who will post on Twitter and tag us at Geekle Official and write what you liked in event, topic, and or speaker. There will be 5 winners and they will get 3 free tickets for the event. Now I'd like to invite our speakers for Q&A session.
Hey.
Hey.
Hello.
Hello.
I'll keep the mic off, or I'll keep the camera off for a few minutes here.
She ready. Yeah. Okay, what we have now? Okay. I think this question from you, Samaya. What is the roadmap for learning data science?
I can take that. So I do see this as a recurring question. So when I started, learning about data science, I started with, just going out and doing some search and trying to understand, what all is in there. So there are different, like several personas within like data science. So I think the first thing to do is to understand, where your interest within data science lies. If you want to be like a model developer or data engineer, are there like several aspects to it. But also at the same time, I started with a few courses on like Coursera and Udemy that had like really good reviews. So yeah, so I'd recommend going out there and just searching for courses with good reviews. I do personally have, I can share my profile where I constantly, publish like, series on machine learning and series on deep learning. I encourage for, people to go in and take a look at that as well. So I'll be sure to post that in here.
Okay.
Yeah, so I think I spent a lot of my time in data processing and learning how to do the data manipulation first, and then doing small projects in data science with the simple algorithms first, and sort of learning how to apply the questions about the data with the algorithms.
Yeah, great. Next question. It's how can you avoid the overfitting your model?
Do you want to take that question?
Yeah, I'll start. It always depends on the method you're using, but in some cases, thinking about the data that you're using is really important, and making certain that you're splitting the train and test well. If you're not stratifying on a particular categorical column, you may overfit very easily. So you, along with adjusting your max depth or some other hyperparameter, it's always good to investigate the data set to make sure that it doesn't lead you to biases in your model, and that can be a good source of overfitting.
Okay, we have another. What is the best path for parsing ML as a beginner?
Go ahead.
Yeah, I was going to say, so like I said, like, we live in the world of data. Everything is just out there. I think, even if it were like, just 5 years before today, we had to be like, searching for knowledge and content in like the most expensive way, but we don't live in that time and age. So I encourage platforms like, Coursera or, Udemy, where, there are courses that you can audit even without, having to like pay for it. So so there are industry leaders in like ML, and you can like, pick up courses offered by them. I really found them to be very like, useful. And, as a beginner, there are ways for you to like, just be away from learning a lot of fundamentals, and you can actually start building. So we have AutoML, so IBM has Auto AI, which are all very like, very super cool tools for you to even not know the basics about ML, but still end up, building models just with click of buttons. While it's definitely, a good encouraging beginning, at some point, for us to fill the void, it's always good to like go back and, look at the code and understand what has actually gone into each of these like packages, because frameworks like TensorFlow and like PyTorch, like I said, are very like useful in giving us handy libraries, but also at the same time, we kind of get into a habit of not learning the basics of it, and that can come back as a moot point to us in the future. So I don't know if you had anything in addition to add, but yeah, like I said, I will be sure to add links to the content that I keep publishing to learn ML.
Yeah. I found it helpful to even implement some of the simpler algorithms by hand. You don't want to go and try to build too many crazy things, but just to learn a bit about how these programs were built, how a logistic regression works, to give you a little bit of inside knowledge, and to sort of, it helps you identify the pitfalls and work through some issues that you might have.
Okay, next one. How do you incorporate the difference between ANN and the human brain? I think Samaya.
Sure. So there are a lot of like, critiques around whether if, ANN is inspired by a human brain. Certain industry leaders tend to think there's no relevance between how a human brain works and, how, artificial neural networks are designed. But for me, I find it like, useful to learn. The logistics are like mapping one-on-one. So so for me, I'm all like up for comparing ANN with human brains. So different other algorithms like CNN and RNN. So they're like variations of ANN that are in fact compared to different like parts of your brain. So CNN is like the frontal cortex. So there's like different ways for you to like abstract and think about it. But except for the fundamental similarities between the human brain and how an artificial neural network is structured, there's not a whole lot of like relevance, similarity over there. So yeah.
Next. Okay, what is the difference between data science and big data? Albert?
Yeah, that one is tough. I kind of have to check, but I suspect that big data was more commonly used slightly earlier than data science, and still to this day, I think it's kind of fuzzy when you mean data science and when you mean big data, because the tools that we have available mean I can process gigabytes of data on my laptop without much effort these days. And I would say that big data is now sort of, it tends to mean that somebody's using particular infrastructure and tools. Say, you know, to put a point on it, to say Spark and Hadoop means big data to me. But it doesn't mean that when I do data science, I'm not processing gigabytes of data. I may be using other tools.
So maybe this is my take on it, and correct me if I'm wrong. So I want to say data science is like anything that you play with, like data. You know, it could be small scale or big scale. But big data in general, you know, refers to a set of tools and architectures that, you know, lets you process a humongous data. So that could be one way of looking at it. But there's like a significant overlap between, like, you know, data science and big data. So we do also see how like data comes in stream. You know, you have to process live data. They all typically fall under the big data realm, but also at the same time, you want to build like models within like the machine learning or the data science realm, where you are dealing with, you know, large scale data. So quite a bit of overlap, but I think data science is small data and big data, dealing with them. Yeah.
I agree with that. Yeah.
I have a great question. How machine learning tools identify fake news?
Do you want to take that?
Go ahead.
I was going to say, I think this came up in another session as well. So fake news, deep learning is one of the biggest contributor for fake news in, like, you know, even generating fake news. And deep learning is another tool in identifying fake news. So I think it's the maker and the breaker of good and bad. So there are algorithms that are very smart to, like, you know, take a news article and then identify, process them and identify if it's fake or real. And that's not just to do with like fake news, it's to do with anything fake. So yeah.
Yeah, they probably do embedding and other LSTM techniques to compare it against known fake news for some sort of signature.
Okay, now what are your view about on using ANN to create personas? I think for Samaya.
Sure. So this question is probably more close to, like, I don't know if Tovio is on the call as well. So he probably has a different opinion than what I do. So I think personas are around creating, you know, information about people that like don't even like exist, but you want to like mimic and understand a customer requirement. And so you can have, like, you know, ANNs generate you know, fake personas that like don't even exist. But it really depends on, like, you know, how you train the model to do that. So you would need a subject matter expert to sit with the model and then, you know, validate each of the outcomes that it comes with. So that would be my take on it. But Tovio is the best judge.
Yeah, he had much to say on that in the earlier Q&A, and it does seem relevant that, you know, you want to have at least some real persona and maybe some generated persona in your library.
Yeah, I think one more question here. Yeah. Okay, how can a voice beginner get into a career with ML and AI and DS?
Yeah, I've seen that. I've seen a few of these, and I see people say taking some online courses and then maybe struggling with applying for jobs and getting their first position. And I would say that if you have the opportunity, you might try and think about evolving some role you currently have. If you're maybe an analyst or a software engineer, you might try within your own organization ways by which you can apply little bits of data science techniques over time. And I find that to be a successful career path, rather than say like stopping everything, go take an online master's program and then try to get a job, can be a really hard task. And if you think about, maybe getting some buy-in from managers and other people within your company, you might get a chance to learn on the job, which I think is a much better way to go about it.
I agree. That's a good point. Yeah.
I think last question. What simulation tools do you use to stress test models?
Do you have a tool you like?
So when I think the question is a little involved, right? So when you say stress test a model, is it around submitting a lot of requests and then seeing if there's latency or if the model is down? So I'm not really familiar of ways to like handle it, but I think the session that the other person, I forget his name, he's probably the best judge for it. I think he spoke about how you can Dockerize and the models. Yeah, so I think there are like I forget the name of the tool where you could like do REST API submissions. You could like have a timer set, and you can submit requests. So typically, I imagine you can stress test or load test these. I'll put in the name in the chat once I figure out which one that is. Yeah.
So I think Postman, which is a pretty common REST API tool, does load testing. You could do distributed denial of service if you're testing a model like that. If you're thinking about testing the data science of the model, I think there are some services out there that can give you fake data similar to data you already have. You say, I've got this kind of distribution in this column, this kind of data in this column. And maybe you could make sort of similar enough data sets to mimic this, to try your prediction algorithm. Or you could try a different k-fold scenario. You could try leave one out, or doing more folds, doing less folds, and use a set of train test split scenarios and see if your model really behaves wildly as you move around these different techniques.
Do you have anything to add, Voib?
Oh, I don't think offhand. Well, I'd have to think about it for a little bit, because when I think of simulation tools, I think of sort of like a holistic environment within which a lot of things are happening. The mention of Postman, but like, what is our Postman in the data science space? It's sort of built into our methods of validation, or in some kind of synthetic data or derived data that we can find. So I don't really have much to add there.
Okay, I think we have a question for you. Okay.
Yeah. So the LDA topics have words associated with the decimal numbers. With decimal numbers, what are those numbers? So a topic can be represented as a distribution of words. And in LDA, it's really convenient because that distribution, the probability of a word occurring from that topic is all those probabilities add up to 1. So if you see 0.03, and that's the most probable word, then the idea is that that word shows up with a 0.03 frequency across the topics. And when you look at the documents are mixtures of topics, right? So all of those topics, the probability of the topics adds up to 1 as well. So it's really convenient. It's really kind kind of nice. Like this is 20% this and 30% this and 50% this other thing.
Okay, where can I find the code he's showing? I think this question is for Albert and Tovio. Yeah.
Okay.
In GitHub.
Yeah, my code, everything I showed was in the GitHub link at the bottom of my talk. And if I think I can, if I put in something in the chat here, will it appear for everybody?
Yes.
So I'll put the link to all the source code, including the link to the slides. It's here in the chat, and we can share that out with everybody. Certainly when you get recordings or any other information.
Yeah, and I also shared I have everything in a notebook, a Google Colab. So I just threw that in the chat as well.
Okay, I think we finish that. Thank you so much, Samaya, Albert, and Tovio. We hope everyone is enjoying the conference, and now it's time for our next announcement. Geekle has run a new education platform where we strive to build a strong software architecture, a great community, to deliver affordable and up-to-date content to our audience. Whatever, whether you are a developer or a CTO, the community fits everyone eager to discover the tech world. Now, what's waiting for you? Videos from the past summits, weekly meetups, speakers from NASA, Microsoft, Facebook, and other great teams share their cases on modern API and microservices architecture and eagerly methodology PCI compliant architecture on AWS and worldwide networking with a community of more than 80,000 developers. All attendees of the Python for ML and AI Global Summit 21 will receive 30 days free access to our platform. Don't miss out on the opportunity to join our community. Thank you and see you next session. Now it's break. Thank you.
All right, thank you.
Okay.
Good morning, good afternoon, and good evening, everyone, and welcome to Python for ML and AI Global Summit 21 by Geekle. My name is Muhammad Adel from the Ocean Science and Technique Academy, and I will be moderating the session today. We have 7,000 registrations from every country in the world. So, welcome everyone. Today we have another great session. So let's start with Laurent Beckard from Google. He is a developer advocate and will be talking about how to build smarter solutions with new expertise in machine learning. Laurent, floor is yours.
Hello, everyone. Can you hear me?
Yeah.
Cool. Perfect. Thanks a lot for having me. Can you see my screen?
Yes, we see it now.
Cool. Perfect. So we'll be talking about Python and machine learning. Surprise. Okay. So my goal is to speak about machine learning and Python from the point of view of a developer. Quick introduction. So my name is Laurent Picard. As you can guess maybe from my accent, I am French. I am currently speaking from Paris, France. And I'm a developer advocate working with Google Cloud for 4 years almost now. And in a previous life before that, I worked as an ebook pioneer. That was 20 years ago. I worked for 17 years in the ebook industry. So in 20 years ago, we made one of the first ebook devices in the world. And for 4 years, I've been focusing on cloud technologies. And among these technologies, machine learning is magical. But I love this quote from Clark because it still represents what I'm feeling like when I see something new developed with machine learning. It's still magical, and it's been a few years that I've been watching applied AI, applied machine learning. But this is just technology, and my goal today in this presentation is to show you that as a developer, you can do something magical. You can use machine learning. Okay, I'll try to give you a big overview. So what's machine learning? This is my own definition. This is how I have used machine learning for the last years. You have data as input, and from this data, you extract information. You're able to understand what your data is made of. What is the information that you have in your data? Of course, as you know, this is not the real definition of machine learning. I will pass on this one because if you're here, most probably you know that machine learning is a part of AI. And in particular, deep learning gave us most of the progresses these last years, and it's just the beginning. So how does it work? The experts, and that was 40 years ago, the first researchers, they tried to mimic the way we think our brain works. We still don't know if it's if it's identical or not, but it seems to be very close because we get very close results. We also need many examples. So we need examples to learn from these examples. And if you think about it, it's a little bit like we learn. As kids, we do learn from examples, from our parents, from our sisters and brothers, from our friends, from our teachers, from anything that surrounds us. And the magic, anyway, for machine learning is that we are able to solve problems. So we can solve problems that we were not able to solve before with handmade algorithms. So that's the magic for me. And as I said, it's just the beginning. Maybe the only issue is that we don't always know why we managed to do the magic to solve the problem. But this is a big field, explainability, that researchers are working on right now. So why is it possible? One might say because it's been at least 40 years ago that researchers worked on this field. So first of all, we have a lot of mathematical, physical theory, even biological data, big data. We've been able for 20 years now to process, to store, to store big data on hard drives and so on. So big amounts of data. And for, let's say, 10 years now, we have access to very high computing power, and especially thanks to cloud technologies. Of course, we have very powerful laptops, computer servers that we can have on-premise, but the advances that we see for the last years is when you're able to do that in the cloud, to train a model in the cloud and do it in hours instead of days or weeks. Okay. So let's take a step back and see how we can benefit from machine learning as a developer. If you can develop expertise, and in this case, you will deal with neural networks, right? But that is very time consuming. You need to invest time. You need and somehow to specialize in some fields. You cannot know all about machine learning. It's so big now. If you spend most of your time developing solutions, then there are already pre-trained machine learning models available to you. They are available as machine learning APIs in different forms. And another big field that has been developing for the last years very quickly, and it's very, very promising, and it's filling a big gap, it's AutoML techniques. And with AutoML, you can actually build your own custom models, still without having any expertise in machine learning. So if you keep this schema in your mind, it means that in your company, if you're an expert or if you're working with experts, maybe they can focus on innovation, because now specialists, this is where they can provide added value. They can build something great and invent something, bring innovation. But as a developer, or sometimes you don't even need to be a developer to build a data set, then you can focus on developing developing state-of-the-art solutions that are very smart and that will use one of these two machine learning principles, existing models or a model that you can build yourself without any expertise, because this is a known problem, a problem that has been solved, that AutoML can automatically solve for you, build the best model for you. Okay. So let's have a look at this. Internally we call that the building blocks. So you see like these Lego bricks. It's because you can take any of these bricks and integrate it into your solution to have something smarter. Okay. So let's have a look at the machine learning APIs. Of course, I will illustrate that with something that I have access to, so the Google Cloud machine learning APIs. But keep in mind that I'm showing mainly principles, and if you're already working with another cloud providers, or maybe if you want to have a look at some specialized companies, the principles in general stay the same, and you will find many of the features and the examples that I show you right now. Most of the time they are available elsewhere. I will tell you when there's something unique. And so if you remember my definition, you have data as input. So data can be, in our case here, text, images, videos, or even speech. And from your data, you extract information. You understand what you have in your data. Or sometimes the data you want, the information, is actually your input that has been transformed into something else, something intelligible that you can use. Okay? So I always start with the vision model, the R vision API, because for personal reasons, in the 90s, this is when I was learning computer science. I was a student, and at the time we were trying to solve this problem. We were trying to recognize and detect objects in pictures. And at the time, what we could do, and my teachers were also researchers, is that we would use convolution filters, and we would try to detect edges in pictures. So it's the difference of contrast mainly that you can see, and from the edges detect maybe that those are flowers, maybe it's a door or a window, we don't know. There are some bricks here. here it's weird, maybe clouds, so that we managed to do something. But as soon as we would use new pictures, it just failed miserably. So this is where magically machine learning is able to solve this problem very nicely. Somehow machine learning is already doing that. Edge detection is embedded. Machine learning is doing convolution filtering on pictures, but it's doing a lot more. It's able to understand, detect textures and maybe groups and so on and so on. And there are different layers. Okay, and this is why it works. So let me show you examples of what a vision model can do. If you give a picture to a vision model first, of course, it's able to describe it to you with labels. And here what I get is, okay, this picture is about nature, flower, and so on. And I have a confidence level here, 95%, everything's correct. Here, this is the kind of response that you can get from the API. So you see, you have this JSON stream is a list of labels, nature, with an identifier and a score here. This is the 95% that you have here. Okay, but more precisely, and this is something that amazed me. A machine learning, a vision model is able to match pictures, pictures that are different. And so this is the same pictures as before, but I changed it quite dramatically. I flipped it, I zoomed in, I cropped it, I applied a color filter on it. So it's very, very different. It's not even the same ratio. The pixels are a lot bigger. And still, the vision model is able to match this picture with another one that is actually the source that I got from the web, and tell me from the environment, from the context of the picture, tells me that most probably this picture has been taken in New Zealand, and I even have the GPS location of Hobbiton, and this is really where the picture has been taken. This is the set of the movies, the Lord of the Rings trilogy. So, of course, it's not cheating. It's not using the GPS location that can be found in pictures. Can use it if you ask it for, but by default, it's just guessing and tells you what this picture looks like, or if it's close to another one. More precisely, a vision model is able, and that's more recent, is able to detect entities, persons in a picture and give you a precise location. And here, so that's the movie cast that I think went to the restaurant. And what I get here is bounding boxes for the different persons, but more even a person in the background here. But more precisely, I have here a bounding box for pants, for tops, and even here for a ceiling lamp. And even more precisely, if there are faces, then you can know now. So here it's a 3D rendition of Gollum. Not really a human face, but let's say it looks like a human face. It's able to tell me that this is a face. It even gives me the cropping box. So if I want to zoom in and have a close-up of the face, I should use maybe this box or even closer this box. And I have the precise locations of the mouth, the nose, the eyes, and everything. And more than that, I can have a sense of generic emotions. So sentiment detection is done here. And what the vision model tells me is that likely this face is angry. You see the big score here. And that's Gollum. And yes, Gollum is always angry. And I have a lot more features like the position in 3D of the head, and also the depth of the different features, face features that have been found, and even more. Another problem that was hand solved before, and that's nicely solved now, fully solved thanks to machine learning, OCR, optical character recognition, text detection. So here, this is a screenshot. And what I get from a vision model, I get all the different levels, so the different blocks of text, the different sentences, the different words, even the different symbols. That is near perfection. It doesn't make mistakes on this kind of screenshots. So it's also interesting to see the limit of models, because as humans, as machine learning models work a little bit like human brains, or we think so, they can make mistakes. And so I always try to see the limits here. If I apply a perspective effect to the screenshot, it still works nicely. Maybe the only difference that it does is here, the double quote at the end becomes a single quote. So no big deal. It's still an almost perfect transcription. So I said we can consider that OCR is a solved problem. But the next step, and it's also almost solved problem, is handwriting detection. It works very well. It makes a little bit more mistakes. But here, this is a sheet of paper with Tolkien's handwriting, with his famous quote. And here, maybe the only annoying mistake is here, shadows. So there's no syntactic analysis. It's just based on our OCR and writing detection. So here I have a V instead of a W. And a small mistake here is that the bottom of the F letter becomes a single quote here. But everything else is great. If I want to be picky, I would prefer this to be a single block of text to be detected, but everything else is just great. That's perfect. And also a cool feature of machine learning models is that they improve with time. As they're learning from samples, the people who train machine learning models just have to give more examples, better examples, counter examples, and machine learning model improve with time. And I have the proof with this, because last year I tried the exact same example, and it was making two more mistakes. As of today, it's making two less mistakes, and maybe in a few months it won't do this mistake anymore. So that's also a very super cool feature of machine learning models. And finally, with a vision model, also you can try to detect web entities. So web entities are persons or objects that are famous. And here, to illustrate that, I took a very rare picture. I found a very rare picture of Tolkien that has been used only once in a Spanish newspaper. It happens that the article is online, but just once. And to really try to trick the system, I also, once again, zoomed into the picture, cropped it, and applied a color filter. So it's derived from this unique picture, but it's a very different picture, and especially for a machine. And still, the vision model is able to tell me that there's a partial match with my original picture. And what's amazed me is that from the context of the article on the web, it tells me that most likely this picture is about Tolkien. Okay, and what I get also that's great for a developer is that I get a unique identifier here, a unique ID that I can use to uniquely identify Tolkien wherever. So this ID comes from our knowledge graph. As you know, we've been crawling the web for 20 years now, and so this comes from there. This is the knowledge graph ID for Tolkien the father. Of course, if it was Christopher Tolkien, his son, then it would be a different ID, and it means we can use identifiers and not just deal with text that can vary sometimes. Okay. So I told you it's an API. So this is an interface that you can call. You can do a web request if you want, but of course it's a lot easier to use your favorite language, and Python it is, right? And so those are wrappers around the APIs that are open source. And here, this is the Google Cloud Vision package that you can install. And it's always the same principle, because it's a wrapper around an API. You create a client, you define your input. So here, that's an image. And then you call the feature that you want. So for instance, face detection. And for a picture, it's almost real time. And then you can use the result right away. You know where the faces are. You know whether faces are surprised or sad or and so on. Okay, and you see just these few lines are enough to identify faces and know where they are located into the picture. We will do a live demo altogether a bit later in the middle of the presentation. Okay, in the second part. Okay, let's move on. You can extrapolate what you've seen on pictures with videos. Videos are like pictures, but with one more dimension, right? Time. And so I will go pretty fast. I will just show you a demo altogether. If you're able to understand what you have in your video, it means you can index it. And so here, so this is an example of this demo, where if you input videos to the model, you will have annotation. So you will have different labels. But as it's a video with time dimension, then you have the different sequences, you see? So I know that here there's a skyline and so on. You can, from a video, you can extract text. So from all the everything that has been spoken into the video, you can get the text. And also, if there are entities, then you can know where they are located. So here I have many persons if in this video, but also you can track them. So let me show you an example. I know that there's a horse here. I will zoom in. Okay, let me show you the horse. Okay, and what I found very interesting here is that there's a person, so that's the movie Rebel, I think it's called like that in English. There's a person on a horse. So the person is perfectly detected and the horse too. But actually there's a morphing. There's a morphing from the drawing to the 3D rendition. And you can see that the person is tracked. So maybe you see. Okay. So the horse and the person are being tracked perfectly from the beginning to the end of the sentence. And that's something that I wouldn't know how to do with just algorithms. Okay. So let's, an example in Python of how you can do that. I've written a few tutorials to use these APIs. If you want to have a look maybe at just the Python code, they are available. I forgot to tell you, I will give you the link to my presentation at the end in the chat on Pine tool. So you can focus, you will have everything at the end, okay? And so here on my GitHub and also on Code Labs, there's this tutorial I've written where I detail all the features that you can do. Just here, I'm showing you one. It's object tracking. So always the same principle. You can create a client. You indicate you indicate what you want to do. So here, for instance, object tracking, and you call the feature you want annotate video on your input video. You wait a little bit. This is not real time. Of course, it will depend on the length of the duration of your video. But then at the end, you have all the results that you asked for. And here with object tracking, you can actually know the bounding box of the different objects that have been detected. And so it means you can extract them or index them or whatever. Okay. So we've seen most of what you can do with visual content, right? But at the beginning, everybody worked on text. So now let's speak about text. And that's like OCR, that's also a very big field. It's called NLP. You must know NLP is natural language processing. And so there are natural language machine learning models. And ours is called the Natural Language API, the NL API. And of course, the first feature is you're able to analyze the syntax of the text that you provide. The text can be anything, can be a full chapter, a full book, a full article, can be just a few paragraphs, can be sentences. So let me show you an example on this sentence. So first, the natural language model tells me that it's in English. Okay, no big deal, pretty easy to guess. but it's able to give me the exact syntax of this sentence, a very precise one. And I did work with companies that specialized in natural language processing. They worked with linguists, and they were not able to get this level of precision. Here, what I love is that I have the punctuation analysis. I have all the different relationships between all the items. I can also work with lemmas. Lemmas are the canonical forms of the different. So, for instance, was is the verb to be, and I could also get rid of the tenses or the plurals or work with canonical forms. It can be very handy. Another thing, and that's something that you saw on pictures, it's able to detect entities or it's able to label your text, right? And here I have three main groups. In red, I have persons. Tolkien is detected as a person, a writer, a poet, and so on are persons. But what amazed me here is that Tolkien here in this sentence is detected, of course, as Tolkien, but I have the unique ID here for Tolkien, and that's exactly the same ID as before in the picture with Tolkien. So it means I can really deal and recognize a work with entities in text and videos and pictures. Okay. British is recognized as a location. It's mapped to the United Kingdom, which is correct. And the three books here at the end are each detected as works of art, and that's also perfect. Okay. Another very useful feature is content text classification. And so if I ask the natural language model, where should I classify this? It tells me it should be classified under books and literature at 97% of confidence, and that's perfect. This kind of feature is used by, for instance, newspapers. Especially legacy ones that have been here forever. Their first editions were just in paper, right? And they have big amounts of archives that they can scan. And from the OCR, then they can get the text, and from the text, then they can classify their different newspapers and each article individually also. Okay. And finally, like in pictures, you can get a sense of the sentiments that are expressed. Sentiment analysis on text is a score that is between -1 and +1, telling you whether we are speaking negatively or positively about about the level of text that you're dealing with. It can be a full paragraph. It can be one sentence. It can be one entity inside the sentence. So to illustrate that, what I did, I chose two different reviews of The Hobbit. A negative one that I found on a social network, and a positive one from the New York Times back in the days when The Hobbit was released. And what I get works really well. I get negative scores for the sentences in Pauline's review. She really hated the book. I get positive scores up to 0.9 for the positive review of the New York Times. And I get, of course, I didn't show you, but I get many, many neutral sentences because most of the time we speak neutrally, right? That is super interesting because some companies are using this kind of feature to know how their users or their customers are feeling about their products, their solutions, their services, or even just the company, the brand, or some products. I know that some are browsing social networks and analyzing everything that is being said about them. And I even know one company that has optimized and improved their customer service because they are parsing all customer emails every day on a daily basis or during the day. But when the customer team starts their day, they deal with negative emails first because negative emails most of the time represent problems, and you want to help the customers that have problems first. A very positive email, maybe it's not worth reading it in the morning. Maybe you can wait a few hours, right? And so what it means is that this team is now a lot more efficient than before. They have improved their customer satisfaction. Okay. Here's an example of how you can use that with a Python package. You create a client, you provide a document, and you call the feature you want. Can be analyze sentiment, and then it's also very, very fast. Then you can know for the different levels. At the level of the document, for instance, you can know whether we're speaking positively, neutrally, or negatively in this corpus. Okay. Then the other part of text and machine learning is translations. So it's also something very, very big. And maybe I will not describe everything, because I think all of you have used Google Translate at least once. Okay, so here's an example. The code is not very readable because I have too much comments or logs. There are just 2 lines needed. You create a client and you call translate. But I'd like to share a fun fact with you. So in 2016, I was still working in my ebook company, and I was using Google Translate. And one day I noticed something really weird. I was mainly translating Chinese and Japanese document into French or English, and suddenly the results became very, very good. Because before that, you could tell that it was a machine translation. And one day I thought, oh, the quality is a lot better. Are they doing that manually now? And I know what happened. And actually, there are some public articles. In 2006, so about 5 years ago, the Google Translate team switched the model from a mainly statistical model to a purely machine learning model. Of course, there are still statistics embedded in machine learning models somehow. But the machine learning model is the one that brought up the bump in quality, this huge advance. And for 5 years, the team is still monitoring the results. And for 5 years, the machine learning model just kept improving gradually. And so it's almost, so we couldn't say it's human translation quality, but almost. It's very, very good translations that you can get, and in many different languages, over 100. So that's the kind of amazing thing that machine learning can do. And as I said before, it just keeps improving, but maybe you helped improving it. So if you use Google Translate on the web, there's I think a small box where you can indicate that the translation that you get is not good. When you do that, somehow you indicate you are not giving a counter example, but you are giving an indication that the result is not good. And so this is useful to train and improve the model. And even better, some users can provide a better translation. And so it will help at the next iteration to train the translation model and get a better one. So this is why it just keeps improving. And of course, there's also still a lot of research being done to improve everything. Okay. So we've seen everything that is visual and textual, or most of it. Now speech. And speech, as for a few years now, just became also a solved problem. So the first one is speech, the speech-to-text model. You can speak, and your speech is transcribed into text. That is the first building block for any assistant. Maybe you didn't think about it, but whenever you use your smartphone, I think it's on all smartphones now, whatever the brand or the OS, you can speak to your assistant, and your voice is transcribed into text. The text is analyzed, so 2 building blocks: speech to text and natural language analysis. And then, of course, there's some processing that can be done, maybe by another machine learning model to give you an answer or to understand what you really want to do. One magical feature of the speech of a speech-to-text model is, as it's learning from real life samples, the model is robust to noise because the real samples have noise, right? And so this is why it's working so well, and we don't think about it because it's able to work with a noisy environment. Okay. It's able. The latest features I forgot to tell you. It's able to detect automatically detect the language. It's able to provide you a transcription with punctuation. Also, that's something that was nobody did before. It was very hard to do. And of course, if you're able to understand what's in your speech, you're able also to index every word and get a timestamp for every word. So it means you can maybe do a search engine and browse among your dozens or hundreds of hours of speech that maybe you have in your archives. Okay. So this is another tutorial that I wrote, how to parse an audio file and extract the speech and transcribe it into text. So I recorded myself with a French piece of poetry by La Fontaine, Maître Corbeau sur un arbre perché tenait en son bec informatique. It's a very famous French piece of poetry. And I tried it. And so I said, okay, this is French, so I think it's not necessary now, but this is or this is to help or get the model to work faster. I asked for automatic punctuation, and so that's really nice to have punctuation in your transcription and for timestamp for all the different words. And what I get is this. This is exactly what I pronounced. I have an uppercase at the beginning. I have a dot at the end of the sentence, and I have a high level of confidence. And that's really, really great. And this is why assistants work so well. Maybe you have also an assistant hardware device nearby. It's the same technology. Okay. Now the opposite, text to speech. And I did work with text-to-speech engines in the past. If you remember, I told you that 20 years ago I made one of the first ebook devices. I was very proud because I embedded a text-to-speech engine 20 years ago in this ebook device. I worked for 3 weeks. We launched the firmware update, and then we waited for the results. And people just didn't use it because 20 years ago it was a robot speaking the book aloud to you. It was like Alice in Wonderland and so on. It was really painful. So you just tried it for 30 seconds. Now speech generated, synthesized speech generated by machine learning models is very, very natural. And ours is called WaveNet. So the WaveNet voices, the WaveNet technology, they are research papers if you're interested. And it's been developed by DeepMind. Maybe you know them because they've beaten the world champion for the game of Go. More recently, they have beaten gamers at StarCraft. And they're very good at starting from scratch and building machine learning model to solve very specific problems. So two cool features with this model is that the voice is really, really like a human voice. It's very hard to tell the difference. And also it's doing better than real time because in 1 second, you can generate 20 seconds of speech. Okay, I'm going to show you a quick demo. Maybe you didn't notice, but you can do a search in your browser. So let's go to the English page. Okay. Okay, I go to the English one, and you see here you can do a search with your voice. So I'm going to use my microphone and pronounce something in English. Could be in French, but I'm doing it in English for you, but with my French accent. Okay, and let's see what happens. What is the temperature in Paris? and I'm hearing the answer. So I don't know if you could see with the frame rate, but I got results in real time, and as soon as I started to pronounce, I got another word, but the final result is just perfect. So it means that it's real time. So maybe you can go a lot faster and prefetch some results and so on and so on. But here, what I want to show you is the way I pronounce it with my French accent. Maybe an English person wouldn't understand it. And here it got me. It understood everything. So somehow, and if I do the opposite, if I pronounce a French sentence with a British or with an American accent, or whatever alien accent from outer space, it works. It's able to understand me and transcribe my weird sentence that some people wouldn't understand into what I have pronounced. Another amazing problem that is solved thanks to machine learning. Okay, so here this is a tutorial that I've written, and just to show you that with just these few lines, you can generate WAV files pronouncing these sentences with different accents: the Australian English, British English, Indian English. Of course, there's the American English, but it also works in I think it's 42 different languages right now. So there's the French, the Canadian French, and German, Italian, Spanish, many more. Okay. So we've seen what you can do with existing machine learning models. Now let's see what you can do when you're stuck and still without any expertise. And this is when AutoML techniques can help you. So let's imagine I want to build something based, I want to detect the shape of clouds to build a weather forecast application. If I use these features with the vision model, I will get the same results, because basically those are clouds in a sky, right? So it's almost, it's basically the same results. So I'm stuck. What if I want to detect cirruses here and altocumuluses here, right? Then I can use AutoML. And for AutoML, I need to work a little bit more. It's not ready to use. You need to build your own private data set. You need to provide examples, samples. And here in this case, that would be examples of cloud pictures, right? And then everything else is automated. You can launch a training and it will be the state of the art, the best model available to you. You have two options. Either you want the best possible accuracy, and so you will ask for a cloud model, and the cloud model will be available as with a REST API, so you can do live detection, prediction, and your API will be automatically served. Or maybe you just want to do batch processing on different files. And in this case, you don't need to serve the API. It will automatically be served just for the time of your batch processing. But what if you want a model to run elsewhere? And in this case, you will not train a cloud model, but you will train an edge model. And an edge model is a model that you can export and get to run elsewhere. So first of all, you can export it into the TensorFlow save model format, and it means that you can get it to it can run in a container. So it can run on a Raspberry Pi, for instance, with a Docker layer. You can export the model in the TensorFlow Lite format, and it means you can embed it in a mobile application. And what amazed me more recently is that you can even export it in a TensorFlow JS model. So it means it can run in a web page, and actually did a small project with that. And once you have the model where you want it to run, it can run in real time and offline. Okay, so let me go on with the cloud example. You need to provide pictures. This is image classification in this problem. You need to give a label to each picture. So you see, you don't need thousands of pictures. Here, 100, 200 on average per label, and you get very good results. And then you launch a training. It's an iterative process often because the first time you make mistakes in your data set. Every time I've done the data set, I've made mistakes. So I launch a quick training. I realize that I have mistakes in my data set. I fix them, and then I launch a longer training. And here on my second iteration, I reach 90% of precision for my model, which is very good, just with this small data set. Okay, one of the tools that can help you for this kind of problem is the confusion matrix. And here I can see that it's very good for 4 of the 5 clouds, but it's bad because it's misguessing for, let's say, 50% of the time. It's misguessing the altocumulus. So here I have an indication that my data set is not maybe diverse enough. Maybe it's biased. So first of all, I don't have as many altocumulus features as everything else. And even worse, they very much look like the same. So building data set is a kind of art, or will become an art, because you have to keep that into your mind. You need to have a balanced data set, and you have to try to remove bias. But here I know exactly what I have to do. I have to remove some altocumulus features and provide different ones, better ones, okay? And then once my model is trained, I'm happy with it, I can use it. This is a picture I took in Poland on my smartphone. The model has never seen it, never tested it, never trained on it, of course, and it's able to tell me that there's a cumulus in there at 97%, and that is perfect. Okay, so I showed you what you can do on pictures, but it works, of course, also on videos and text and even structured data. We could spend hours speaking about it. Here are the few features that you can use on videos. For instance, you can do custom object detection and tracking inside videos. Here, the problem we saw is custom classification, but you can also do custom object detection on pictures and videos, and so on and so on. You can do your own custom translation. You can detect custom entities into your maybe more business-oriented corpuses of text. Okay, so all the AutoML model services are available in the unified AI platform. So this is a screenshot to show you what you can do. For instance, the last project I've done is image object detection, but I very much would like to try this one out. Okay, so it's demo time. So I've done an AutoML model where I used a few pictures of myself, teammates, and other attendees that let me do it, of people with the tongue out, with their sticking their tongue out, people yawning, and people sleeping. And so let's try all together. Okay. I think there's a 20-second delay, so I will give you some time. So you can use this QR code to connect to my demo from your smartphone or from and from your laptop. Sorry, you can enter this short code bit.ly/python4ml, bit.ly/python4ml. Okay, so let's get started. It will ask you for if you're okay to use the camera, and you can try to trigger. So this is using the vision model, the first part. You can try to trigger any of these emotions. Okay, so my selfie is uploaded, so it's going fast, and it does recognize at over 80% that I am surprised. And as I know where my nose is, my mouth is, and the orientation of my eyes, then I can add a mustache to everyone. Okay, so let's do another one. Hey. Okay, you can do likewise. So here I'm joyful, it works. And now let's try my own model. And with my own model, you can stick out your tongue. So feel free to do so, have fun. And so it works, yeah. So I clicked that to be able to use my pictures again. And maybe let's try another one. So in AutoML mode, you will have a mustache with the colors of the French flag. And let's try to to yawn. Okay, uploaded, I'm yawning, it works. So you could say that I'm cheating because, of course, the model used pictures of me, of myself. But let's see what we have with you. So here, the two of us are surprised. Nobody sad, nobody angry. I did stick out my tongue here. I did yawn. And we have two attendees who will go to sleep. One more. Okay, so you see it works. I'm sorry, I'm rushing a little bit, so maybe some of you couldn't see the URL. And if you remember, we're also able to detect entities. And so here I'm showing you all the attendees who have glasses, okay, and mustaches now, okay? So you see that is very easy to do. So this is the architecture of the demo if you're interested. I'll pass on this one. This is just to remind you that there are 4 cases, 2 types of good results and 2 types of mistakes. If you want to focus on precision, then you want to minimize the number of false positives. Precision is like a metric for the quality of your model, but maybe you prefer quantity, and in this case, you will use the recall metric, and the recall metric relates to the false negatives, and in this case, you're trying to minimize them. And so the recall represents the quantity of results that you'll get. Especially if you're doing a search engine based on the machine learning model, you will focus on the recall. And to arbitrate between precision and recall, that is the threshold, the confidence level that you'll use. And the lower it will get, maybe the more you will focus on recall, on quantity, okay? Under the hood of AutoML, there are 3 main techniques. The first one maybe is unique to Google. Is there are research papers. It's called a neural architecture search. So before launching the actual training, we are first launching other trainings. We are evaluating with dedicated hardware that we built. It's called TPUs, Tensor Processing Units. We are evaluating the best architecture for your training. So that it gives the best quality and also the fastest way. Then a technique that is known to experts is transfer learning. From your data, you will have additional layers. This is how. Yes.
We run out of time.
So I'm overtime, right?
Yeah.
Okay. So I'm wrapping up. If you're interested, you can follow me. This is a project where I'm detecting components on an electronic board in a web page. And just maybe 10 seconds, the ML APIs, there's no difficulty. It's just a matter of hours to use them. With AutoML, you need days. And I needed 2 days to build my AutoML data set and get my demo to work. Okay. Those are examples on my GitHub of how you can build a summary of a video, how you can build animations, or the mustache demo that I just did. Here I'm going to give you the link in the chat. This is a nice comic book about machine learning. And here are my slides if you want to check them later. I want to thank you for having me today. It's almost 1 a.m. in Paris. I hope it gave you a nice overview of what you can do as a developer as of today. And ideally, I hope I gave you a few ideas. Thanks a lot for having me.
Thank you very much, Laurent. And now we will move on to Sen to investigate the encryption techniques for deep learning. Sen, floor is yours.
Okay, can you hear me now?
Yes.
Okay, great. Let me share my screen. Okay, you should see my presentation, right? Hello?
Yes, we see it.
Okay, should I start now? Should I start now?
Yes, you can start.
Okay. So our agenda today, I will give a little bit information about myself. Then I'm gonna introduce about deep learning service and orthogonal encryption. Then the goal and how I design my experiments. And then I give out the results and analysis about my experience, and then some summary about what I have to do, and some future work that we should do. So a little bit about myself. So this is how you pronounce my name. I know it's kind of hard to pronounce my name. So I think it's better to put it there. So a background of my education, I got a bachelor degree in computer science from Metropolitan State University of Denver in USA in 2019. And then I recently finished my master degree in computer science, but focused on cybersecurity from Colorado School of Mines, USA also. And onside the computing works, I'm also an archive collector and reader. You guys can learn more about me on my personal website on the link on the slide. Yeah, so first, deep learning service and orthogonal encryption. So deep learning service is getting more popular every day in our computing work, because it's a subset of machine learning where neural network algorithm inspired by human brains and normally learn from a large amount of data. Deep learning service have so many complex problems in AI, because user can avoid inexpensive investments on buying a high-performing computing system for AI applications, and it also provides user a fast and stable infrastructure. So by using deep learning service, it's fairly easy to scale up the system without any worrying about all the aspects of scaling. And user only have to pay for what they use, so it's nice. It's a great solution for small companies, researchers, and individuals like myself. It's also a great deal for all short-term user. But however, to ensuring the confidentialities of the data is a big challenging in deep learning service. Because in many cases, it's very important on who can get access to the training data, especially when the data is sensitive. For example, when a group of researchers want to train a model to detect a new disease, they would not want any third party to have access to that training data set, because it may contain some information about patients, and it may be illegal for them to share. So encrypted deep learning service were introduced as a solution for this. So in encrypted deep learning service, only encrypted row of data are shared for the training process. This means that we can use encrypted deep learning service to train, predict, and validate our model without any worry about revealing of the original data. This enables researchers to get access to more sensitive data for researching and still ensure the confidentialities of the data. So figure one on the slide show a typical sample architecture of an encrypted deep learning service model. So the training data set is first encrypted before it's being sent to the service for training. So there have been quite a few encryption techniques that have been introduced in encrypted deep learning service, like homomorphic encryption and orthogonal encryption. So in talk, I focus on investigating orthogonal encryption technique that's introduced in the pattern called methods and process of encrypted deep learning service. So orthogonal encryption is a linear transformation that preserve the length of vectors. So if V is a vector that represent the original image, and T of V is the transform image, then the length of vector V is equal to the length of vector V of T of V. So this technique claims to be able to transform an image into a new image that contain no informations and usability of the original image. The figure on the slide just demonstrate how orthogonal encryption works. So from a random selected image to use as a key called image A. So we can derive the key called Q in this slide by perform the QR decomposition, and then the key Q then used to encrypt an image. Then the cipher image is then decrypted by multiply with the reverse of the key Q, which is Q to the Q reverse. So my goal in this experience is to measure the accuracy of deep learning model that trained on encrypted datasets and analyze some possible vulnerabilities of the orthogonal encryption technique. So the experiment gonna be just a little bit about machine learning and security. So in this experiments, I use two datasets. The MNIST dataset that contain like 70,000 digit image, and the CPA10 dataset, which is a small set of the CPA dataset that contain 60,000 color image of 10 different objects: airplanes, automobile, bird, cat, the dog, frog, horse, sheep, and truck. So I use convolutional neural network as the deep learning model for this experiment. The reason I choose to use CNN is because it's a good architecture neural network that can produce high accuracy with low pre-processing and computing power costs for the digital applications. And CNN is also really good at reduce overfitting while training, which is one of the big issue in deep learning, and also it kind of simple. So I don't want to put too much time on machine learning, and so additional to a typical CNN model, I will show you a subsampling layer in the model. So a subsampling layer is also called a pooling, which is a function that normally immediately follow a convolutional convolution layer in CNN model to downsample the spatial size of the output, height, and weight. By doing this, the subsampling layer will reduce the number of parameters to be learned by the network, so it can avoid overfitting during the training process. So I try to use it to minimize the computational complexities of the CNN model that I use, and try to get the high accuracy. With the MNIST datasets, I will train with 3 CNN versions. One with 1 subsampling layer, and the other 2 with 2 and 3 subsampling layers. And after my experience, I find out that it seems like 2 and 3 subsampling layer models result in a highest accuracy. So to save time and reduce computing power for the training process, with the CPA10 datasets, I only train it with 2 subsampling layer model. First, what data I will train the two data sets on clean image, which is the original image from the data set without any encryption. And I use like 10 different encryption key in this experiment to encrypt the image for the later task. And 5 of the 10 key that I use is from QR decompositions, and the other 5 key that I use, I just use a random generating orthogonal matrix to generate the key. So this figure shows the 5 keys that derived from QR decomposition. And this is the 28 by 28 metric, and this is a 32 by 32 because we have the different size of image from the two data set. So because the different size that I just mentioned, I need to create the different size on the key also in order to encrypt the image. So to make the key as similar as possible, I generate the 32 by 32 orthogonal matrices to use for the CPA10 dataset. And then I resize them to 28 by 28 matrix so that I can use for to encrypt the MNIST dataset. So this figure shows how I resize how I downsize the matrix. Basically, I just take up the last 4 row and column from the 32 by 32 matrix. So after repairing the key, then I go on to encrypt the two datasets with 10 different keys to generate 10 different encrypted datasets for each MIS and CPA10. And then go on to train my model. And then when I finish encryption, some sample of encrypted datasets, I will use them to perform some virtual analysis to measure the strength of the orthogonal encryption technique. So one of the things I want to look at the strength of this encryption technique is the no plain text attack, because it's a no plain text attacks are critical to any crypto algorithms, and according to some previous works on digital encryption, no plain text attacks succeed on many digital encryption methods. So in this experiment, I will also perform some analysis on orthogonal encryption to find possible vulnerability. So overall, with the clean MIT datasets, all 3 versions, 1, 2, and 3 subsampling layer, got 99% on accuracy. So the 2 and 3 subsampling layer model, like I mentioned, have approximately 0.3% higher in accuracy compared to 1 subsampling layer. And I think this occurred because the 2 subsampling layer and 3 subsampling layer models can reduce overfitting during the training process better. And this table shows the accuracy of the 10 CNN model that trained on 10 encrypted MIT dataset that are encrypted by 10 different keys. So on average, model trained on dataset that encrypted by QR decomposition had higher accuracy than those that trained on the dataset that encrypted by orthogonal matrix generating keys. It's about 0.2%. The average accuracy of model trained on encrypted datasets is approximately 1% lower than the model that trained on a clean MIT dataset. And so when I examine the same object that encrypted by different keys, it shows that the same object encrypted by different keys produce different cipher image, but there's still pattern of the unencrypted image that pass on those cipher images. So if we focus on the yellow pixel on the picture on the slide of the cipher image, the shape of digit 2 is still presented in the cipher image. So this shows that the orthogonal encryption technique does not completely hide all the information of the original image. There are common patterns from cipher image of the same object, even if they are encrypted by different keys, still present. And for when I try different objects encrypted by the same key, it clearly shows that different objects will have different cipher image. So when they are encrypted by the same key, this provides possibilities of categorizing the cipher image. And when an attacker can obtain a large number of cipher data, which is very easy for an attacker to obtain those cipher image. So when I try to exploit the no plain text attacks on the MNIST datasets, it shows that none of the image in the entire MNIST datasets is invertible. So this means that the inverse of a plain image cannot be directly derived. This results a very low possibility to success for no plain text attacks, because without the inverse of the plain image, we could not derive the encryption key. So with the CPAT10 datasets, the accuracy of the model that trained on clean datasets is about 73.51%. So this table shows the accuracy of 10 different models that trained on 10 encrypted datasets. So overall, the accuracy of this 10 model is approximately 18% lower than the accuracy of the model that trained on the clean CPAT10 dataset. And I think the different accuracy between unencrypted and encrypted datasets in these experiments is a lot higher than with the MNIST dataset that we recently see. However, if we consider the size of the image in the CPAT10 datasets, so each image is a size of 32 by 32 and by 3 channel. So that's going to be 32 by 32 by 3 pixels. So when we do the encryption, there will be almost 200,000 multiplications and addition operation performed on encrypted image. So this is about 150,000 more operations than an encrypted image in the MNIST dataset. So this means that more information of the original image is transformed, and this could cause confusion between cipher image of different objects during the training process. So confusion between cipher image is a good feature to have in a crypto algorithm, but it may not be a good thing for training data used in deep learning. So when I analyze the securities of these encryption methods, for the same object encrypted by different keys, not like in the MNIST datasets, the cipher image of an object that is encrypted by different keys show fewer common patterns than what is shown in MNIST dataset. And I think this is because of we have over 150 small operations that a cipher10 image needs during the encryption process. So with different objects encrypted by the same key, the same characteristics show in the image dataset is also shown here. So with 50,000 images from the trend datasets of the cipher10 word check, there's like almost 50,000 black channel metrics that are invertible, and 63 red channel metrics that are invertible, and we have 18 green channel invertible. So this means that there is a very high possibility that the no plain text attack could success on this dataset. So this figure show an example exploitation that I performed. On the left is the image that derived by a no plain text attack, and on the right is corresponding original image. So even the derived image and original image are not absolutely the same due to some shifting that may occur during the transformation and calculation processes. But the patterns of these two images are absolutely the same. So if an attacker performing enough data analysis on the derived image could convert it to one that's more similar to the original image. So we have higher possibility of successful in no plain text attacks with this dataset. So overall, the accuracy of encrypted datasets is lower than the clean dataset. It's 1% lower on the MNIST datasets and like 18% lower on the cipher10 dataset. The different dataset present different strength of the orthogonal encryption technique. So it seems like that the accuracy and orthogonal crypto algorithm strength are in inverse ratio. So compare the MNIST and the cipher10 datasets. So MNIST is less secure and it had a higher accuracy, and cipher10 on the other hand, it seems more skewed than the MNIST, but it has lower accuracy. Something about my experience, both MNIST and cipher10 datasets is a small dataset. It only contains like 10 classes of objects. So it should be better if I can do it with a dataset that can contain a larger number of classes. And according to my experience, it showed that the resolution of image in the dataset has significantly impacted the accuracy of the deep learning model that trained on those encrypted data. So how is it going to be look like if we try to train the model with a larger data set with a higher resolution image? And the thing is can we make the crypto process more secure? Yes, we can. There's there are lots of techniques right now that we can completely make the cryptographic process more secure. But then we will lose the accuracy when we try to train the model. So there are threat line for us to consider. And if we want security right now, we need to trade off for accuracy. And if we want more accuracy, we need a trade off in security. So it's an interesting topic and thing to consider about. And I think this is just a beginning of encryption in deep learning service. And I think we get better later on in a few years, and it's gonna have a lot in deep learning service. So that's all for my talk today. And if you want to have more detail about my presentations, you can check out my personal website. I have a full report of my experiments, and I have on the Python code that I build, how I build my model, how I implement the encryption technique, everything. You can check it out there. Okay, thank you.
Thank you, and I have a couple questions for you.
Uh-huh.
What is the best career advice you have ever received?
The best accuracy that I was able to receive.
Yep.
So with the immerse dataset, I think I got like over 90%. Let me go back to, yeah. So with the immerse dataset, the highest I can guess is 99.4%. And then with the C-pattern dataset, I have way lower accuracy. So with the C-pattern, the average accuracy only around 56%, which is really low. And we can see like when I encrypt the image on the C-pattern dataset, there like exactly 150,416 more operations that perform in order to encrypt that each image on the C-pattern dataset, because it have like 3 channel. That's a color 3 channel image. So the more operation that we perform when we try to multiply it with our the key metric, it make the encrypted more skewed, but then we lost a lot of detail on the image for the training process.
I think we still have time to know your story about Python, how you learn it, and how you see the biggest challenge in machine learning at the moment.
Pardon me, can you repeat your question, please?
Yes. I need to know more about how you learn Python, how you learn machine learning, and the biggest challenge in machine learning at the moment.
Oh, so I'm not really an expert in machine learning. So my focus is on cybersecurity. But I say that it's interesting to do something that, like a combination between machine learning and cybersecurity. So on machine learning, I did take a couple of classes in machine learning during my bachelor degree, and then all of the stuff I just like self-teaching about machine learning. But I don't know, it's for machine learning for myself, it's like prepare the data sets is kind of challenging for me. I have done another project that we try to use machine learning to process and train the data and that we collect on some website, and it's very challenging for me to try to get the data to work with the model. And also, like construct the model is kind of challenging for me. Like every single time I use a model, I need to like spend a lot of time on learn how exactly it works. And I mean, most of the time I'm not like 100% understand like fully the model work. So yeah, data processing and model structures is kind of challenging for me.
Okay, thank you very much, Sen. And now we will move on to Ravi Shankar Nair from Patient Bytes. He is a chief consultant and will be talking about Apriori unification pattern for machine learning. Ravi, floor is yours.
Okay, great. Thank you. Bye-bye.
Thank you. Good evening and good morning, everybody. Can you hear me?
Yes, we hear you.
Thanks, you. Thanks, Adele. You're doing a fantastic job. I think we have got many interesting sessions today, and everything is going on well, right?
Yes.
All right. So I'm going to share my complete screen, and let me know once you see my screen. Is it visible?
It's now visible. Yep.
All right. So the topic here is a priori unification pattern for efficient machine learning. So we will know what does this mean. Though it is sounding a little bit complex and difficult, it's a very easy design pattern that I'm going to discuss today with all of you. So I will start by giving a very brief introduction about me. I'm a technology evangelist, one who likes technology, and more oftenly on the open source, a lot of open source technologies. Because I see that in the current world, you can do wonders by using existing open sources, combining them, integrating them efficiently, and making results out of it. My experience over 20 years in trade and logistics, healthcare, financial, transportation, business intelligence, big data, etc., and well versed with distributed computing applications. And I have given some of the references which I will be converting into PDF and sharing to all of you, so that you can just click on the links and read some of the machine learning things that I have done on my past experience. And on the left hand side, you can see my LinkedIn profile. Please connect with me or shoot an email whenever you have any questions or you need more clarifications, you need more consultancy, etc. And as a whole, this machine learning world, I would like to call it as architecting the unknown. Why? There is a big difference between science and computer science, right? Science is moving from unknown to known. We don't know about solar system centuries back, right? We don't know about what moon is all about, what is the shape of earth. Everything was unknown. Science helped us to move from unknown to known, right? What about machine learning? What about computer science in general? We move from known to unknown. That's the difference. Because we got some data, and that data is raw. We don't know how to make sense of that particular data. As we write our algorithms, as we combine them, compose them, effectively combining data from multiple sources, we start getting the value out of that data, so that we are figuring out what was unknown in that data. So I would always tend to call my field as I'm always architecting the unknown. When I start with something, I don't know, but I move in order to find out what is in it, right? All right. So a very simple agenda. What we are going to talk about is, we'll start with a simple example. Okay. what is this a priori unification. Then we look at the problem statement, we look at the solution, we look at the advantages that we want from this particular architecture, and finally we will go for a demo so that you get the complete picture, right? And feel free to ask any questions during the question and answer session, or anytime shoot an email, as I mentioned to you earlier. All right, so it's evening, right? Anyway, I'm broadcasting from this sunny state, Florida, in United States. So here it is evening. So let us take an example. We want to make nice broccoli chicken, right? And assume that broccoli and chicken are available to you. Small data, it's available. Okay, let's assume that. But you don't have soy sauce and salt. Let's assume that soy sauce and salt are the external data, right? So we are going to cook, we are going to make broccoli chicken, right? And call that as our ML or AI application. We got data. What are our data? Broccoli, chicken, soy sauce, salt. Broccoli and chicken are available, but soy sauce and salt we need to bring. The cook is ready, and we are going to start cooking. And let's see a good approach, right? You want to buy soybeans. You want to bring in raw salt. And you have chicken, you have broccoli. But please look at that diagram. I don't have soy sauce, I have soybeans. I don't have refined salt, but I have only raw salt. So this guy is doing little bit tedious work, even though it is a nice approach. What is that he or she is doing? Is bringing the soybeans and creating the entire process of converting that soybeans into soy sauce, the raw salt into the refined salt, iodized salt, and then he or she is going to combine the chicken and broccoli and going to cook it. You'll ask, is it good? Well, this cook is a special kind of person. He wants everything in his house. The complete factory which converts soybeans to soy sauce. The complete factory to convert the raw salt into the refined salt, right? Whatever complex process you saw in the previous slide, he or she is building in the home and then creating this particular dish. So let's think about this particular process. Is there any disadvantage? Okay, first thing, how much space you need to build this factory? Soybeans to soy sauce and raw salt to refined salt. How many areas you want? In our computer world, how many machines you want? And are you going to tie to a particular company? Are you going to build it monolithic? Can you do parallelization while you are doing the work? If tomorrow a new machine is coming, can I just take it out and plug it in? Difficult, right? If you agree that this particular process is okay, you are doing everything by yourself, but it is very complex, it is not nice, that's what the entire world of machine learning and data scientists are doing. What are you doing when you want to combine the data from multiple data sources? You are connecting to the database, bringing the data from Oracle, bringing the data from the other system, MySQL, bringing the data from SQL Server, and then you are doing the complete factory of soybeans to soy sauce, raw salt to refined salt within your ML application. So how can you make it better? Come on, you already know the answer. Just buy the soy sauce, just buy the refined salt from the market and just prepare the chicken in your machine learning application. What did you avoid here? You avoided that complete heavy lifting, the process of refinement of the data. If you are not using this approach, as you have seen in the previous slide, you might have created that entire factory in your application for converting your data, and then you might have used that in your application. But is that a good approach? Your ML application in data science is meant for machine learning algorithms. It is not meant for data refinement and data factory kind of things. Whenever you want to get the data from multiple systems, you must not attempt to do that within your ML application, but you should consider it separately. If there are people in this audience who are familiar with web application development, what is meant by model view controller architecture in the web development? What did you do? Rather than writing the entire code in an HTML or a JSP code or a ASP code, what did you do? You just created a view, which is the presentation layer. You will use React.js, AngularJS, those kind of applications. Then you will have a kind of model, which is doing the business layer. And then you are going to have the data, which is connecting to the database layer. Model, view, controller, architecture, correct? We could have written everything together, but that's not a good design pattern. In the similar way, in ML applications, if you are combining everything about data from multiple systems and you are doing those kind of things inside your ML application, it seems that it is not a good design pattern. And my experience working on different ML projects where the data is brought inside the ML application and then joining affected a lot of out-of-memory exceptions in your ML applications. Please search Spark out of memory joining the data frames. You will get more than 10 million hits in Google. The reason is if you are not prepared to manage the joining of the data very well, you are going to hit with out of memory. Why? Because assume that you are bringing 1 terabyte of data from MySQL and another terabyte of data from Oracle, and you want to join it, and the resulting data is just 10 million rows. But for joining, you are bringing the entire terabyte into your ML application, which is not good. So we should try getting the unified data. And what is the advantage? Tomorrow, if this soybeans to converting into soy sauce is a different company, I can just change it, but my ML application is not changed at all. I can do distribution because I am unifying it outside. It is fault tolerant, which means that if something is not working, I can just plug it with another and it can do an automatic failover. It's extensible. What do you mean by extensible? If suppose you want to join one more data source, you can just add that extra data source here and next data source here, and your ML application still remains mostly agnostic to what changes are happening outside. So this architecture is polyglot and flexible. And this design pattern is what I mentioned as a priori. That means we are doing a unification and combination of data prior to bringing it into your application. looks efficient, right? So what will be the overall architecture? Always you will have your ML or AI platform or your application, your Jupyter Notebooks, your R code or your Spark code, whatever it is, right? But whenever you have a situation where you want to join multiple data sources, remember that use case. I'm not talking about one data source. If it is one data source, you directly pull it. There is no efficiency here. Why? Because it is just one. When you are dealing with multiple data sources, because the world is going into big data, you might have seen a lot of presentations today talking about data science and big data, right? What is big data? Big data is talking about not one single database. Big data is talking about polyglot persistence, which means that you may have MongoDB, you may have Oracle, you may have MySQL, you may have Pinot, you may have the Hive, Hadoop, right? So there are multiple systems in the enterprise, and there may be websites from where you want to do the web scraping, you want to bring the weather data, you want to connect to the CDC website and get the COVID-related data for those analysis. Multiple data sources. And whenever you want to combine that multiple data sources, please don't bring individually all the data sources into your ML platform like the guy who was creating the soy factory and the raw salt factory, but join it before you are bringing the data into your ML AI platform. And once you bring it, you start doing your imputing, balancing, your correlation analysis, all those kind of things into your ML application. But the most important thing to note here is you are bringing the unified data, not the individual terabytes and petabytes of data into your AI platform, which may not scale. Even if you use the application framework like Wakes in Python, there is a limit to the distribution. Why? Because you are unnecessarily storing the data. All you need is the unified data from all these particular data sources. So, a priori unification means you are keeping a data virtualization layer in front of your ML AI platform. And trust me, this has produced more than 40 to 50% of efficiency in the ML AI frameworks that I daily deal with. It allows more concurrent users to run your ML AI applications and algorithms. You just assume that in an enterprise, there are 3 different departments running ML and AI code on a single platform, and all the 3 groups are bringing individual data sources. There is hardly any space for dealing with your ML AI algorithms as such. Why? Because already the platform is filled with the data. What are you going to do? There is no memory. Even if you use columnar formats, you use Parquet, ORC, advanced kind of formats, compressions, columnar data, no use. Why? Because terabytes of data are residing in the data frames. And you know very well that in Jupyter, if you are executing a data frame, that data frame will be available until you finish off that particular code, correct? So, what's a good option? We should have a data virtualization tool, right? So let me introduce one of the most powerful data virtualization tool, completely free, of course. Save millions of dollars. How? Use PrestoDB. PrestoDB is open sourced by Facebook in 2013. And please look at the left-hand side. You cannot find a commercial vendor in this industry who has been stress tested to such a big scale. Look at the companies which are using PrestoDB. You will know what is the scale in which they are working. And this particular sentence is taken from the PrestoDB site. You can see how Facebook is using PrestoDB. 300 petabytes of data warehouse, 1,000 Facebook employees, 30,000 queries. Pretty stable, completely free. It works very efficiently. Whenever you write a query, It will combine the data from multiple data sources. Please look at this right hand side where you will see this is one data source, this is another data source, and when you run the query, it will do the virtualization and it will be distributed completely onto the platform and you get the resulting data. That resulting data you can use in your Python and your R and your Spark code. Well, it is time for a demo. So what I'm going to do is I'm going to open a new terminal window and I am going to go to my directory where I have installed the Presto DB for this particular demo. And if you look at the Presto DB, you will have this directory structure. Very simple. It's a matter of few seconds in order to install Presto. And please look, if you are going into the etc directory, you will see another directory called catalog, and I have put two files inside this catalog. One is called excuse me, MySQL.properties, and another is called Oracle.properties. Can you imagine what are they? One is the soy factory and another is the raw salt factory, right? MySQL is the database which is connecting to MySQL, and Oracle is nothing but the connectivity to Oracle. So please look, if you want one more connector to MongoDB, you need to create one more file called MongoDB.properties. That's all. So quick, so flexible, so easy. And I'm going to start the server. Okay, so let me start. So your Presto DB is running, and while it is starting up, I am going to start another window, right? And let's start a different color. And I'm going to go to the directory and I am going to start the Presto DB client, right? So the Presto DB client is started. Now let us start writing the queries. And what's the query that you want? You want to get the data from, let's say, the MySQL tables, for example. So I am going to write select star from mysql.ml.employees, which is going to give me the data related with MySQL. Fantastic. Let's write another query. Now I am going to take the data from Oracle. Did you change the window? No. Did you change any different connections? No. In the same window, you queried SQL and Oracle. Amazing, right? And now comes the magic. Select, right? And let us do a join between MySQL and Oracle in one simple query. Please look at that. I am querying Oracle and MySQL in one window. And once you run this particular query, you are getting the joined data. This is beautiful. And if it is not there, what you will do? You are going to go to your Python, and inside your Python code, let me take an example. You are going to write this particular code, right? So let us just look at this not efficient code. You will install the Oracle library. You are going to connect to Oracle. You are going to get the data related with Oracle. You are going to connect to MySQL, and you are going to get the data related with the MySQL. Remember that now you created two individual data frames like the soy factory and the raw salt factory, and now you are going to do the join and you are getting the joined result. You are resulted only, you are concentrating only on this result. Why are you creating the two individual data frames which are too huge within your notebook itself? You should be trying in order to get only the unified data. So what are you going to do? Let us take the most efficient way of doing this particular one. And I am going to call it as Apriori pattern. Please look at that. Only one block of code. And in that block of code, I am connecting to Presto DB by using PyHive. So PrestoDB comes up with a PyHive-based Python installation, a package, which will allow you to connect to PrestoDB, and you write your unified query from Oracle and MySQL, so that now you get the data frame which is the result of Oracle and MySQL, but that join is happening in PrestoDB now, not on your notebook. And you get the result. And that's the idea of a priori unification pattern. And don't worry if suppose you are coming up with, oh, how will I do if I am writing an R code? Don't worry at all. Because if you are writing an R code, you will use, instead of PyHive, you have R Presto. And you connect and execute exactly the same query, which is joining Oracle and the MySQL, and then you get the unified data frame rather than building the complete frame inside. How about Spark, PySpark? I'm sure there are people here who are writing in Spark, right? So let me open Spark now, right? So I'm going to go to my big data architecture, and I will go to my Spark directory. Spark, yeah, right. And let us go to bin, and let us start the Spark. And how will you start PySpark? Just type PySpark, right? And we have the latest version of Spark running, completely distributed machine learning platform, a distributed computing cluster. Spark is running. So what do you want to do now? So assume that you don't have this particular mechanism. What you could have done? You could have created a data frame, which is now your MySQL data frame. So I'm going to copy this particular code and I'm going to write it. Look at that. I'm creating a MySQL data frame, which is bad. Entire data is now coming into MySQL. And if suppose you write MySQL df.show, it is going to give me only the MySQL data. Not good. And if you want to connect to Oracle, you are going to do exactly the same thing. You need to install all the Oracle drivers, etc. And you are now going to write Oracle and then write Oracle df.show, which is going to print only the Oracle data frame, which is not good. Why are you individually creating the multiple data frames? Instead, what we can do, I am going to create a JDBC data frame, which is using a connectivity to Presto, and Presto supports JDBC. So Presto supports JDBC, PyHive, and R Presto. You can connect from any machine learning tools for your AI ML applications. And now if suppose I am loading this particular data and I am writing JDBC df.show at this particular point, it is now giving me unified data rather than the individual data frames, and you get the result. Got it? That's what a priori unification pattern means, and PrestoDB is a great tool for quick installation and put it in front of your ML AI architecture. So these are the advantages. You can build custom connectors. It supports complete SQL standard. You can store the result if you want into a local storage. It has got connectivity to S3, Cloud, AWS, Azure, etc. You can access it from any language, and it has got Python or Spark integration, which I have demonstrated just now. You can write custom ELT, which means that if your data needs pre-processing, if your data needs removing the null values, missing values, etc., in the unification layer itself, you can perform it and get the resulting data into your Python or R or Spark applications. And finally, if you have reporting needs, you can connect it. And all that is completely free. So, what is the opposite? The not so nice approach of doing this? A posteriori composition. That is an anti-pattern in machine learning. And unfortunately, we are all doing that. So avoid that anti-pattern and use a priori unification, where you get the unified result into your ML applications, and then you proceed with that. Right? And that improves the efficiency. That helps you to make your architecture much beautiful and much scalable, resilient, and distributed. You will use your machine learning platform only for what is intended. Because a machine learning or AI platform is not for data storage and data management. It is meant for your linear regressions, your TensorFlow, your scikit-learn, right? So use your machine learning platform and AI platform for those purposes by creating an extra layer. Right? And you might say, I have to manage that extra layer, but you are getting a huge advantage, because your primary importance is for getting your machine learning output efficiently. Right? So that's all from me, and thanks a lot for listening. If any questions or anything, please come into the question and answer session, and we will take it up from there. Thank you. Back to you.
Thank you.
Adam.
I'd like to ask you about the biggest challenge in machine learning at the moment.
Yes, please. Oh, you are asking me what is the biggest challenge?
Yes.
Okay, absolutely. Fantastic question. One is the scalability, the distribution of your machine learning, right? There are applications like Horoward, and the cloud providers are coming up with the SageMaker and Azure Cognitive Factory, etc., for scaling machine learning. But the problem that you are going to face is the huge cost associated with it and the data that is being associated with it, right? So by bringing in these multiple layers, as I mentioned, by bringing in this PrestoDB and distributing it and carefully architecting it, you may achieve a better scale and better efficiency in dealing with that challenges. So biggest challenge is distribution, deploying machine learning, and efficiently using with concurrent users, but that can be now avoided with these technologies that I mentioned, Adel.
Okay, what is your advice for young people in AI and ML starting career?
Write code.
Yeah.
Write code as much as possible. Even today, I write code. What makes you know machine learning is understanding the data, writing different kinds of algorithms on that particular data, deploy your algorithms into ML flow, and look at the performance and track your model performance. Look at RMSE values, look at the log square errors, look at the efficient metrics that are available in each of the algorithms, and then try to find out and fine tune until you get a better accuracy. Yes, there are people who will be using, as one of the sessions I saw the question answers, SageMaker, etc. Yes, you will not know the internals if you use those particular platform. There is autopilot in SageMaker. I have used autopilot. Yes, it is very easy. It may give you best efficiency, but the problem is you will not know the underlying artifacts until you write the code and experiment it. So as youngsters, please write and efficiently train your models until you get the desired accuracy, is my humble advice.
Okay, what is the best resource for people who want to dive deeper?
There are many. One of the best course, as all of you might be already aware, is Andrew Ng's Coursera course. Please don't miss it. One of the best that you can get is Andrew Ng's Coursera course on fundamentals of machine learning. That will give you, for example, the people used to ask me that what is the relation between matrix multiplication and machine learning? And as you are writing your code, when you are identifying that your multivariate expression is equal to y equal to a0 plus a1x plus a2x square plus a3x cubed, you will understand that it is nothing but a matrix multiplication of rows and columns. So you get that kind of fundamental understanding by attending that particular course. Rest, please take an account in Kaggle, and in Kaggle, start participating in the competitions and create a leaderboard for you, applying and making sure that you are getting some prizes in Kaggle. Not only Kaggle, there are many sites. Kaggle is one of the premium sites, right? And third, please read, subscribe to Medium, articles on different algorithms that are evolving. For example, for imputing missing values, you can use an algorithm. Many people do not do it. Imputing missing values, they just substitute with an average. They just substitute with some statistical calculation. No, you can use a machine learning algorithm itself in order to substitute the impute values. So you will get all these kind of ideas by reading, subscribing to Medium, etc., etc. Please go through this.
Okay, last one. What career mistake has given you the biggest lesson?
I would say that before coming into the data world, some of my expertise was in the web-based technologies. And I think that if you are concentrating on something which are very frequently changing, you won't be able to get the expertise. For example, in the web development, initial days, it was HTML. Then JSP came. Then ASP came. Then Angular, React.js, Play, all these kind of things came. So which one you will get expertise on? So concentrating on a technology which is very frequently changing might not be a good idea. But if you concentrate on data technologies, machine learning, AI, linear regression is from last 50 years, it is linear regression. The fundamentals and the core will not change. And as I told you in my beginning, architect the unknown. Try to architect the unknown.
Thank you very much, Ravi. And now we will move on to Serg Masis from Sanjinata. He is a climate and agronomic data scientist and will be talking about the importance of interpretable machine learning. Serg, floor is yours.
Hi, it's Serg. Yeah, I work for Syngenta, agronomic agribusiness, a global agribusiness company, and I look forward to talk to you about interpretable machine learning. And thank you for the introduction, Ravi. Let me share my screen. So. Oh, hold on, and show. There you go. Okay. Hopefully you can see it already. Thank you for your patience. I didn't have this set up. All right. So welcome to my session. Thank you for joining. My contact information is there. Feel free to reach me if you have any questions directly. I'll be asking questions, of course, after this session. Let's dig in. Oh, and also, given the broad audience, I won't get too deep into the weeds, but I welcome technical questions. So here we go. Before we begin, let me quickly introduce myself. My name is Serg Masis. Serg is my English nickname, but you can call me Sergio if you speak Spanish. I'm a data scientist at Syngenta, where I work on food security problems for the Climate and Agronomic Decision Science Department. For the last 10 months, I wrote a book for PAC that is a comprehensive hands-on overview of interpretable machine learning. It was just released 1 week ago, and it's available at Amazon. This is actually my second career. I think I heard people just before entering this session talk about web development. I was, for 10 years, a full stack web developer, an app developer, a webmaster, and even the founder of the search engine. I think probably this connects to that, as I'll be talking a bit about that. In this roles is how I got into analytics, since the internet is often the source for big data. So first, I like to start with a story. Actually, a few stories, so bear with me. I will connect them to machine learning interpretation. So the first story concerns Python. So for the last few months, I have been promoting the book before it was released. I've gotten quite a few people reach out to me with questions like this one. You know, what ML algorithms to use, or this one, can you explain which model is better? As well as all of these ones, which are similar, you know, all about algorithms, machine learning models, you know, what libraries to use. And of course, these ones, which are a little bit more like a specific, you know, what to use, PyTorch or TensorFlow, NLTK or Spacey, you know. And then, of course, the age-old question, which is better, Python or R? So, of course, we know the answer to that question. Python, of course. Python is awesome. We import libraries that give us all kinds of superpowers. As you can see here, you know, Python can make you fly, of course. You just have to import anti-gravity. I don't know if you've done that, but, you know, please try doing that. It's really fun. So, but we must remember one thing. Python, as great as it is just a toolbox. It's a nearly bottomless, magical toolbox, but it's a toolbox nonetheless. So that's probably a sacrilegious thing to say at a Python conference. So before you all chase me out with pitchforks, please allow me to explain. Asking a data scientist a question like this one is like asking a plumber if he uses wrenches and plungers. The answer is simple. We just simply use the best tools for the job out of those available in our toolbox. If you already program, learning how to use them is relatively trivial. What matters the most is why we use them. So this brings me to the first point, which is when it comes to data science, the why is always more important than the how. I will now let you into a short story of why I know why matters most. Some of you might be too young to remember 1999, but it was the year of the Matrix, the Fight Club, SpongeBob SquarePants, Britney Spears, Star Wars Episode 1, and the craze for something called Y2K. You can look it up. I won't explain it here, but everybody was in a panic about that. It was also the first year, it was the year of my first paid job. I was a web developer back when most people dialed up and websites looked like this. Horrendous, right? And browsers were so different, you had to tailor websites to them. They could look entirely different or not work at all on different browsers. Certainly don't have that problem now. So I also learned to code HTML by hand, you know, before web development software made it easy to do with drag and drop or higher level coding that abstracted it. Then, of course, came data-driven websites, which I would do in Perl, Confusion, Cold Fusion, Java, PHP, and connecting it to databases in Oracle, MySQL, Sybase, SQL servers, and Access. Back then, if you wanted a content management system, an e-commerce site, a customer relation management system, you would have to do the code from scratch. And I did. Now, for over 15 years now, it's pretty much inconceivable that someone goes through the trouble of making most of the most common forms of websites needed by scratch. Even when they do make custom applications, most of the low-level code has been abstracted by frameworks like Django, Laravel, Angular, Ruby, Flask, CodeIgniter, whatever. So to recap, back in 1999, there were a lot of problems a web developer had to be concerned about. Some were with the user devices like limited screen size and slow internet, not to mention browser compatibility, but this also had to do with with standards compliance. In addition to that, there were some major bottlenecks with servers and ISPs, and even the internet as we know it. Being so new, a lot of programming language frameworks and development platforms became quickly obsolete. Lastly, the tools used by developers hadn't consolidated, and it still was largely a manual process. So these problems were mostly fixed, right? Hooray. No. As you know by now, web developers just sit back and relax since the internet runs itself. Not really. With so much out of the way, they focus on improving their products, making them easier to use, more profitable, safer, more reliable, etc. In other words, fulfilling the mission of their organizations, the why. And in fact, AI plays a big role in a lot of that as well. So after I got bored with web development, I switched careers to data science. But it's deja vu. The reason I'm telling you the story is because I've been here before. When I see code, of data preparation steps, model training, and evaluation in Python, it takes me back to the days where all websites were custom, artisanally crafted, if you will. And who among us doesn't get giddy in anticipation while our model is training? This takes me back to when we waited a few minutes while website pages loaded. The feeling is one we take for granted now, but we surely don't miss. But when it comes to work, we spend a lot of time configuring libraries that can become incompatible, debugging minor issues, and looking for answers in Stack Overflow. This takes me back to the days when website content could make a browser crash and become easily unstable with a new version or something like that. But all this pain is temporary. Because what if I told you that the future of AI and machine learning is low code or no code? And much like everyone and your grandmother can now create a website in an idiot-proof interface and deploy it with one click, models will be able to train and deployed just as easily in a few years. Soon enough, writing code to train models with Python will seem like as quaint as writing HTML code to create websites. But before this becomes a reality, we must address the elephant in the room. In the early days of the internet, had tons of technical hurdles. And so has AI overcome many, but it still has a few more large ones to overcome. Namely, interpretability. And that's what this session is about. So I'm going to offer another analogy to where we are in machine learning. And I would argue that we also have a lot in common with aviation 70 years ago. The inspiration for this comes from this article. This is a 3-year-old article. It's really good. You can look it up. It turns out machine learning and AI in general right now has many parallels with civil aviation 70 years ago. There has been hype about it for decades. It's finally more accessible to the masses. It's magical, and practitioners, are regarded magicians. I've actually had an agronomist in my company call me a magician. And in my previous company, a financial planner called me a wizard. But we better not get this praise get to us. I'm no Gandalf. It's no more wizardry than flying is thanks to physics. Also, because it has yet to reach its potential, it's a new frontier, and all the organizations that regulate the industry have yet to be born. Machine learning projects have an issue of taking off reliably. Likewise, in the 1940s and early 1950s, it was dozens of times more common that flights got delayed, redirected, or canceled than it is right now. not to mention turbulence and issues with limited flight distance and connections. These were very common, and we take it for granted now, but it happened a lot. Of course, there were also crashes. You could say machine learning has had its fair share of blunders over the last decade. I could fill dozens of slides with news clippings like these ones, represent only the ones we know of. There's a publication called AI Now that keeps tabs of them in case you're interested, but they happen a whole lot. Yeah, and the early history of commercial aviation was filled with high-profile catastrophic events. The high proportion of deaths over millions of passenger kilometers made flying an extremely deadly activity in the early years, especially considering that commercial planes didn't carry as many people. And now, believe it or not, it's the safest mode of transportation. Incidentally, AI, I know it's not killing people, at least yet, but the ways it causes harm are mostly more subtle and more widespread. So, how did aviation improve? First of all, several regulatory bodies were created in the early 1950s and started to ensure safe use of the airspace and aircrafts, allowing the greater public to trust this new mode of transportation. International standards were created from everything from structural integrity to aerodynamics and pilot licensing and certification. Speaking of which, in the early era of flying, most pilots were Mavericks that performed acts to impress crowds on the ground. And even after World War II ended in 1945, there was a surplus of fighter pilots that could be enlisted for civil aviation. But capable as they were, the daredevil mindset of fighter pilots did not suit the mission that they had to be retrained. Lastly, instruments. More and better instruments. When safety is involved, you cannot get enough of them. Be honest. Which plane would you rather fly? The one to the left or the right? Seriously, which one? As for machine learning, we may have to wait a while before most governments enforce comprehensive AI regulation and international organizations and industry leaders enact standards. But you know what we can do in the meanwhile? Get in the habit of using better instruments. So these are the tools that the most common diagnostic interpretation methods and tools, and there are even more. Problem is, we tend to focus heavily on only predictive performance, which is the first one on the top, when there's so much more that we could learn and improve in the model if we use the rest. While using predictive performance alone is good enough under perfect conditions, it's like learning to fly only on clear days and then winging it when it's cloudy. That's a recipe for disaster. Then there's a flip side to diagnostics. This is how you fix issues that you find with the diagnostics. And I'm not talking about strictly performance issues, but those related to the main concepts of interpretable machine learning. So the main concepts of interpretable machine learning are fairness, accountability, and transparency, or FAT. It's fairly simple. You expect the machine learning model to produce fair predictions. They must be robust and traceable back to something or someone, and you should be able to understand exactly how they were made. There are many ethical concerns associated to these concepts. As you can see here, H1 connects to these three concepts. And ultimately, what we want to know is, can we trust the model? Well, aviation would have taken over the world without all of our collective trust. Not just the trust of, in this case, the aviators, but also the passengers. And when it comes to AI, the passengers are the people that use AI products. And believe me, they're losing trust. And trust is mission critical. As a transhumanist, I, for one, dream of an era of mixed reality and assistive augmentation where smart glasses or biohacked appendages can interface with us through thoughts and gestures and help both disabled and able-bodied people. But how would we trust AI to empower us in such an intimate way if right now it seems to bring out the worst in us? So it's fair to ask, is interpretable machine learning and ethical AI the same thing? Not really, but both concepts overlap. Ethical AI, also known as responsible ML, encompasses much more than interpretable ML because it includes data and algorithmic governance aspects. These aspects include privacy regulations, data management procedures, and even modeling standards. They uphold FAT. On the other hand, interpretable machine learning is how we implement fairness, accountability, and transparency with machine learning. However, these very same tools can be used for ethical reasons, can be used with no ethical reasons in mind, simply for curiosity, and they can also be used unethically too. So ethics aside, why would we need interpretable machine learning? Machine learning interpretation is needed because machine learning by itself is incomplete as a solution. Think about it. Simple problems could likely be solved with procedural programming. Solution covers all of it. The complex problems we optimize with machine learning require linear algebra, calculus, and statistics precisely because we don't understand all of the problem. By explaining the decisions of the model, we can cover gaps in our understanding of the problem, its incompleteness. One of the most significant issues is that given the high accuracy of our machine learning solutions, we tend to increase our confidence level to the point that we think we fully understand the problem. Then we're misled into thinking our solution covers all of it. So indeed, I believe overconfidence has curbed the adoption of interpretable machine learning amongst practitioners. They would think, well, if my model or my insights are so great and they tend to be true, why bother? Unlike the plain analogy, there's really no barrier for entry for using more and better instruments. So why wouldn't we use them if they're already freely available? Problem is, we have the following assumptions that lead us to become overconfident. So bear with me. Like here we have descriptive analytics. We have that truth. There's a truth that is, in machine learning, we first start, by exploring data and deriving insights through descriptive analytics. But this is not the only way to learn about the data. A model can discover much more, and we can use interpretation tools to this end. Once it's time to train a model, we change a single metric when the problem calls for much nuance. Maybe a fairness metric, maybe a cost factor. Often the incentives are only there to shoot for accuracy and nothing else, but at the expense of fairness, accountability, and transparency. And it is true that AI is eating up software, and software engineers are gravitating by the droves into AI and machine learning. But a machine learning model is not what I would call software. Yes, it's ones and zeros, but it's not deterministic in the same way software is. I'm not bashing engineers here. I have an engineering background myself, and we need more software engineering principles, but without the deterministic mindset. Soon enough, most models won't be even trained with code, but with drag and drop interfaces. So it shouldn't be seen as programming either. So what is it? It's statistics. And what you do with the statistics, you interpret them. We make predictions and imagine that a human won't take them at face value. But that's exactly what happens, which is why this human needs to understand what influences this prediction and how confident the model is about it. Also, wouldn't it be refreshing if the model could abstain from a prediction and not support it with a statistically sound margin of error? It's really common for us humans that when someone tells us, asks us a question, we say, well, I'm not sure. I'm not confident about it. I don't know. Why should a model should always be determine an answer it's forced to make an answer even if it doesn't comply with certain confidence bounds. So the next one is, I'm sure we're all aware of this one, but the minute our model produces 99% accuracy or a very low MSE, we forget about it. It's entirely possible for all the decisions, predictions, or insights to be right for the wrong reasons, or to be right now, but wrong tomorrow, or to be right in the wrong way. Let me explain. Trusting the model is rarely about the model. Let me repeat that. Trusting the model is rarely about the model. We derive meaning and predictions from a model or the data directly from that is supposed to represent the truth. The most fundamental problem we are aware about is bad data. Typically data entry errors, random if we're lucky. However, there are also biases associated to bad data we should control for. And anomaly detection methods and comparing with the external data sets for issues and distributions can help correct these issues. By the way, biased data doesn't always involve people. I deal with crop data in agriculture, and there's bias there too. As for truth, we have a whole host of issues. We have the ugly truths, all the prejudices and systemic biases that exist in the world and our data is merely depicting. We can make sure our models mitigate them. Our models don't have to reflect the truth that exists. It can reflect the truth that we want. We also have fake truths and the many ways models can purposely be tricked. And the truths change over time and geography, but often models have no notion of this. Of course, spatial temporal models excluded. All of these issues only aggravate data issues. Lastly, we have our own biases with our models. Chief among them, observer bias, when we blind ourselves to what we assume or we want to be true. So the choice is yours. You can be a daredevil, chase after a few metrics and hope for the best, or through better instruments, understand the data conditions better and tweak the model for smoother, safer, and more reliable operation. Also, let's stop making predictions about only following trajectories, but possibly even changing them. There's a fitting quote that says, the best way to predict the future is to create it. It's often attributed to Abraham Lincoln, but it was Alan Kay of Atari that said it. So, you know, if there's any Gen Xers in the audience, they know what I'm talking about. So now I'll make this last part a quick overview of how to incorporate interpretable machine learning. So this is your typical machine learning workflow. Many of you will be familiar with it. You first start with problem understanding, then data understanding, then data preparation, then modeling, then evaluation, then you do deployment, and then once it's deployed, there's inference on that deployed model. So the way I suggest is that once you've done some data hygiene, you can explore some, perform some exploratory modeling to let the model tell us what features matter the most and how they matter and how they interact. This will of course be a different process for image and text data, but very analogous. From these insights, you can iteratively combine features with feature engineering and remove some feature selection. This will produce a rough draft of a model that performs well enough. Once you have settled on features, or at least have a short list to test, you can create an optimized model through hyperparameter tuning. The key here is sparsity. You want a model that will generalize well, because otherwise you'll have something that won't work well in the real world. Evaluation ought to be extended not only to include performance with holdout data, but test for robustness with perturbed data, uncertainty with sensitivity analysis, and bias testing as well. It's very important to use error analysis tools for this sort of thing as well. usually data isn't static. So you have to have a pipeline test for changing data, which is called feature and concept drift. Then you can retrain the model on the state data and deploy it if it passes evaluation. Last but not least, and this is very important, whenever the model delivers a prediction, it should be automatically returned, which is what is called a local interpretation method, which tells the end user why this particular prediction was made, including confidence intervals. So it's very common when we would deliver a prediction, it's just whatever that prediction is, and there's no explanation to why it was made. I think this is wrong. I think this should change. I think it should be standard to come with an explanation, and a thorough explanation at that. And as I said before, I'm also advocating for abstention, especially in cases where there might be unfairness involved or some high consequences, because a lot of these things on a case-by-case basis can have very big consequences for people involved. Such as loan applications, judgments in criminal cases and so forth. And so now I have a bit of conclusions. So interpretable machine learning has a synonym, which is explainable AI. And it's gaining growing popularity, as you can see here with academic publications. And then also with book publications. And here it is with search trends. But I don't think this is a trend or a fad. I honestly think this is the future of machine learning, because machine learning depends on this just as much as the future of aviation depended on better instruments. That's something really important, because a pilot now can, sit back and simply relax, because and be there when obviously things start to go wrong. They have to maybe manually pilot the plane, but for the most part, they just sit back. And the only reason they can do that is because they have good instruments, and they have also good tools based on those instruments that automate the process. And we don't have that yet for machine learning. And I think the future of aviation depended on planes not crashing, and the future of internet on higher bandwidth and more stable browsers and a lot of other things, those all relate to each other in that way, that these industries are only the way they are because these measures were taken. And I think of course, there's other measures, but interpretability is one of the most important measures that can be taken to get machine learning where it needs to go. Lastly, this is a quick shameless plug about my book. It just came out. It's 14 chapters. There's Python code and a lot of visuals, but without excluding theory, which is very much needed to also be able to interpret the outputs. What makes it unique is that it covers both interpretation methods and solutions for interpretability issues, which is something not addressed in any book so far. Also tax interpretation specific to deep learning and not tabular data. I also have avoided any hello world examples, and those use those toy data sets like Iris, and that most data scientists have seen 100 times and lacking context. The reason for this is to use only plausible, fully developed example that have a backstory, which I call a mission. And in machine learning, the how should never be disconnected from the why. Anyway, there's a exclusive discount for anybody that wants one. It will be active for only 1 month. You can print screen this if you're interested, or I can can paste it into the Q&A if anyone asks for it. So without further ado, now I'm ready for your questions, and I'll stop sharing right now. Thank you.
Thank you. I'd like to know the story behind the first book of you.
Behind the what?
The first book you published, the story.
Oh, the story. Well, it's a very interesting story. What happened was May last year, someone from Pact had read a blog post I think I had written on interpretable machine learning, and she said, would you be interested in writing a book? And I thought it was like, why not? I mean, I'm stuck at home, I'm anxious all the time, it'll keep my mind on something else. And also I love the subject. I've been studying it for a few years, and to me, I don't call myself an expert in the same way a researcher at a university is, that is dedicated to certain methods. But I'm studying their papers. I've been studying their papers for years, and what I want to do is connect the world between academia, which was all this stuff that's happening in labs, and what's happening with practitioners in industry that are completely unaware of all these methods. And yeah, eventually they'll trickle down, but they'll get distorted because the thing is, industry doesn't quite understand how these things are meant to be applied, and which ones are the best ones, and where the focus should be, and they use them very selectively. Whereas I think the focus should be always there. It should be embedded in every process. It should be integrated to AutoML, and to ML ops. And so far it's not. I hope that's where it's headed.
Okay, what advice would you give to young people in a starting career?
Yeah, I would tell them that they have to focus, like I said there, more on the why than the how, because one of the things I found, and it's probably where I was when I was starting with web development, and also to a certain degree when I transitioned to data science. I thought data science and machine learning was learning TensorFlow and learning pandas, and that was it. I mean, I didn't quite. And early on in web development, I thought the same thing. I just had to learn all these programming languages, and I realized that the most important thing is understanding the problem. It doesn't matter what you work in what field, in what industry. You have to understand what you're trying to solve, because sometimes it might not even be machine learning. Machine learning might not be the right solution. And sometimes even when it is, your go-to might not be that. I had an intern a few months ago, and he was eager to apply deep learning to everything, but not every problem can be solved with deep learning. So it's very important to understand those things, and to realize, well, you'll eventually find a problem deep learning is perfect for, but in the meanwhile, just learn some other things, and then when you're ready, you'll apply that, and first focus on the why, focus on getting excited, on if you're not working yet, create your own projects, and make them something that you're excited about. Don't just grab anything. Just create a project. If you're interested in, I don't know, like cars, why not starting like self-driving cars, and the technologies used for that, and data sets used for that, and then play around with that. If you're interested in agriculture, like I find a data set that has to do with food, and that will get you motivated and excited to start using tools for that. But don't go off and just pick the tool that you find the coolest, but the one that is most appropriate.
So what is the biggest challenge in machine learning at the moment you think about?
The biggest challenge?
Yeah.
Well, it depends where you work, but I think throughout machine learning, I agree wholeheartedly with, there was a talk Andrew Nan did a couple weeks ago, and I agree wholeheartedly with it. Like, so much of the focus has been on more and more data, on getting the most amount of data. And that sometimes is the bottleneck to do quality models. But the biggest, to me, in my experience, has been getting quality data. And that's always a frustration, because it's very connected to what I spoke earlier, which is that you can't trust a model if your data is crap. It's like even like I was saying earlier about the planes, you can't fly a plane unless you have quality jet fuel. In other words, your plane will just eventually just fall apart. So that is the fuel you need. You need the best, most refined data, and that's more important than anything. And I think that's a problem. The other one relates to what I spoke about, which is something people aren't too aware about, which is things like fairness, accountability, and transparency, and that's a big issue. It's kind of one of these silent killers, because people know it's there and they don't address it, because till something breaks down and a huge blunder shows up, your company won't do anything about it. Because as long as accuracy is high and nobody's complaining, well, the model's working, right?
Thank you very much. And now I'd like to invite all our speakers for Q&A session.
Thank you.
Hi, Adele. This is Ravi Shankar. I'm a little bit internet issue. That's why I'm only audible. Is that fine?
It's fine. Okay.
Yeah. Thank you.
Okay. Okay, let's see the first question. When did intelligence first become artificial? I think Ravi.
Oh yeah, fantastic question. Right. So the best way to think about that is when we started thinking about the need for intelligence to be artificial. Okay, it's a counter question, because when the human labor became too much, for example, character recognition, or you have got a big bunch of papers and you want to recognize the handwriting, and the labor that is required for that is humongous, and the people started looking at a computer, whether programming languages or anything can solve it or not. But then the problem is, programming languages can follow only the rules that you specify. We need a mechanism to make them learn. And then the people started thinking about neurons and bringing in the idea of embedding that neuron caliber into the machine, and then make sure that the computers are able to get trained. And slowly we started thinking about augmented and artificial intelligence. That's why whenever we talk about AI, there are two things. AI stands for augmented intelligence as well as artificial intelligence. The difference is this: if you are having a driverless car, but your presence is needed as a driver, that is an augmented intelligence. But if suppose you don't need a human intervention at all, that is artificial intelligence. Currently, you will see most of the things are augmented intelligence, and we are going towards artificial intelligence, and I don't know when it is going to become a reality. So I will tell the labor needs, that is what made intelligence to be artificial. That's my summarized answer, and I open to other two gentlemen for adding.
I don't know. Do you want to say something first? Thien is, or I answer?
Oh, sorry, I mute myself. Yeah, I don't know. I think one of the reasons I think about is people get lazy and they want to make something that do the work for them. So that when it become artificial, kind of similar to Ravi answer. I think.
Yeah, I think the distinction, I hadn't heard that distinction, the one Ravi said, but yeah, like he pretty much said the difference between augmented and artificial intelligence is the difference between predictive and prescriptive, analytics, pretty much. Yeah, I think. Well, tell me if I'm wrong in making that assessment, but yeah, I think it's I would say so. Like as if a human is not needed, and if decision making is, at the very least marginally better than humans, then we could say it's artificial intelligence. It might not be general, probably will never be general, but it is narrow artificial intelligence.
Let's take another question. Machine learning is a part of data science. If you have data, we have machine learning, how a person can work on areas where there's very little data available. I think we can start with Serg. Yeah.
You go, me.
Okay.
I don't know. I haven't worked on a field in machine learning, so like this is also a good question that I would like to hear answer from other two people. To be honest.
Okay, maybe Serg.
Well, I'd say, like when there's very little data, there are a few like recommended methods that are used for that. Usually it's not a problem I find, but there's a chart that that scikit-learn distributes around that says, oh, if you have less than these samples, these are the algorithms we could recommend. They're usually like I'm not sure if they're like a linear discriminant analysis or one of those, but they're lesser known methods, and certain like the white box methods as well, like linear regression, logistic regression. I would use those when there's little data. They work quite well, and they're easy to interpret, and like you definitely wouldn't throw small amounts of data to a neural network. It's overkill.
Absolutely. I want to add to whatever Sergis has mentioned. That's a great insight. If you ask a question that can I teach addition to a small child who never knew addition in one simple class, what will be our answer? The answer is going to be, they can learn it, but partially, 10% or 20% they will get it. That's what exactly will happen, as Sergis has mentioned. If less data is there, the efficacy of the output of your algorithm are going to be directly impacted by that. The more the data is, the machine understands it. And just like human beings, how we learn. And if we are learning with much experience and much practice on much exploration on the outside technologies, then we get better. The same way, a machine is also. So when less data is available, algorithms like Sergis mentioned can be applied, but the efficiency will be a matter, because machine learning needs the data and optimization of the models over a period of time to make it stable and perfect.
Okay, next question. Is machine learning is accurate and safety for health and life decision in real human life?
Yeah, there. I would say there are instances in which it could be it could be adversely affecting human life. I mean, these are more like fringe cases, like diagnosis for like medical situations, you know, like X-rays and also all kinds of things that are used in that domain of medicine, as well as you know, I would even dare to say in criminal justice as well, because you know they might not kill someone, but they might put them in jail because you know, like there's a prediction that there's high risk of that you'll be committed a crime. Also, people, you know, by facial recognition, they might be targeted. You know, someone might, you know, think, as it has happened before, people are using facial recognition to, you know, if they see a picture in a crowd of a person that was at a rally, and then they use facial recognition on it and then dox them, you know, then someone could come after them and kill them, you know, because they were incorrectly marked. Even if they were correctly marked, that's just a stupid reason to kill someone, but it could happen. And the culprit would have been that machine learning model. So and not to mention like self-driving cars, it was mentioned earlier, you know, anything that is self-driving, accidents could happen. So then there's all this whole area of ethics. You know, we could become a utilitarian, or and then there's the, I don't know if you've heard of the trolley problem, but what do you do in those cases where you have to save one person to, you know, kill one person to save two, you know, or something like that. And that can happen in a self-driving car scenario, right? And it happens naturally to us humans in a split second if we were driving that car ourselves. But now it's a machine, and so who's accountable? The manufacturer of the car, the person that built the model, you know, how do we trace that accountability? And so that becomes really complex really quickly. So yeah, like we have to think about these things. And that's why I think ethics should be embedded in the organizations that do these things. Any kind of machine learning model that has any kind of ramification towards human health, you know, or life, should have ethicists working side by side.
Thien, you want to add something?
Yeah, I were thinking about a self-driving car, but I don't think I have anything else to add now. That's a perfect answer.
Ravi?
I completely agree with that. That ethics has to be inbuilt into that that particular scenarios. And another thing I want to add is, see, in one of the consumer shows in Las Vegas last year, I have seen the AI-based assisting artificial hands to the humans, which is a perfect example of whether it is helping for decision making. It is absolutely doing it very well. But if you ask me that will I change my pacemaker with an artificially controlled pacemaker, I won't do that. So there are limits to what we can do, and there are limits where we should stop. As you mentioned, self-driving cars, whatever technology is coming, I would like to sit there and I want to feel what is happening, because I can't believe it. Maybe in the next generations, I don't know, it may be fully automated and no human beings needed. Because one day I heard that Elon Musk was predicting that, you know, when you are going to the office, you can tell your Tesla car to do Uber job on the daytime and come back in the evening to pick you back. But I don't know whether that is going to be a realization and when it is going to be. But it is interesting to see. But to answer the question, there are positive situations where people are currently using AI for real decision making, but not too much. And also, ethics is a very important criteria in these technologies. Yeah.
Last question we have. How does ML differentiate from deep learning and AI?
I see them as, three Venn diagrams. Well, a diagram of three circles, a Venn diagram of three circles, and one is contained in another and another. It's like a Russian nesting dolls. Yeah, ML is deep learning is a subfield of machine learning. I don't distinguish them in the same way other people do. I just think, well, deep learning is the sort of tool that is specialized for different, definitely unstructured data and semi-structured data. I'm not too keen on using tabular data on deep learning. I mean, it's probably overkill for most cases. And then as far as AI is like the mother Russian nesting doll. It's the one where everything, ML is inside AI, for sure. So that's the way I see it. That's how they don't differentiate. They're a family of things.
Perfectly said. Perfectly said. You said whatever I wanted to say. Thank you.
Okay, thank you so much, Thien, Ravi, and Serg. At the end of today's sessions, we hope everyone is enjoying the conference. Goodbye and see you tomorrow.
See you tomorrow. And nice to meet you guys, Sergius and Thien. Thank you.
Likewise.
Thank you.
Bye.
Bye.
Bye-bye.